Gosling. And this is a star 7.
Hello, dear Devoxx community. We are glad to welcome you today at Devoxx Ukraine Online. This year we have a special occasion to celebrate, 25th anniversary of Java, the technology that united all of us together. And of course we wish you were here with us celebrating this day and tasting this delicious cake we have. Unfortunately, it's not possible, but we believe that if now all of us will make a wish together, it will definitely come true. So let's do it together and celebrate the happy birthday of Java.
Woohoo! Okay, all right, congratulations, Java community. Hello, everyone. This is our third edition of Devoxx Ukraine. Despite all the difficulties that we had this year, we make this event possible, even though it is so online. Can you even imagine, we have almost 10,000 of registrations. Wow, right? And we are grateful to each and everyone who made this registration. Without you, it wouldn't be possible, and your support is priceless. Thank you. And now I want to welcome on our online stage a person without who this event wouldn't be possible. A Devoxx founder, Voxx Days founder, co-founder, Devoxx Belgium organizer, and also a father of the Voxx family, Stefan Janssen. Stefan, hello. Hello, Kiev is calling. How are you?
Hello. Good morning. Very good. Thank you.
Hi.
So yeah, this is great. Thank you very much for organizing this. I really want to take this opportunity, first of all, to thank everybody from the steering committee, from Devoxx Ukraine, the program committee, of course, the events company, and also all the speakers who are willing to actually do this virtually today. So thank you very much for making this happen.
Thank you very much, Stefan. Nice hoodie, by the way. Okay.
Okay, thank you. Thank you, Stefan. And now we also would like to give a word to the head of program committee, who worked hard on preparing all these talks and communicating with the speakers. Oleg Tsaltsaliko. Oleg?
Yeah. Hi, everyone. To be honest, I'm super excited that we managed to organize Devoxx Ukraine this year, despite all the current circumstances in the world, and while most of the other big conferences got postponed to the next year. To be honest, the online format became a challenge for us, but we managed to do it, and now we are live here with 10,000 participants, 35 top speakers from 15 different countries around the globe. Right? I want to say thank you to all of the program committee members who did really hard work, carefully selecting best talks, best content for you guys, and I hope you'll enjoy that. This year we have three streams, and one of these streams are almost fully dedicated to deep dives and small talks. I'm very happy that so many engineers around the globe joined this conference today to get new knowledge and collaborate with each other, and I'm pretty sure it's going to be fun. We we have like only 40%, I guess, participants from Ukraine, which makes Devoxx Ukraine really international and global conference. As you probably also know that we are celebrating 25 years of Java this year, and we have more Java champions and Java rock stars than ever before. So I'm pretty sure you will enjoy this 2 days event together with us. Enjoy, guys.
Thank you, Oleg.
Awesome, awesome.
We are very excited to start. And also, we would like to thank our partners, the companies that supported this year Devoxx Ukraine. Without you, it won't happen, so thank you so much. Our gold partners, Slugsoft, Infopulse, NX, Sigma Software, Svitla Systems, Lunatech, Playtika. And our silver partners, Grid Dynamics, DN Simple, and Itera.
And also, we have a platinum sponsor and co-organizer, EPAM, which is supporting us every year, and also this third edition of Devoxx Ukraine. And with this, you know, we have very nice tradition each year. And this is a tradition when a head of EPAM, Central Eastern Europe, and Vice President of EPAM, Yuri Antonyuk, is coming on stage and saying a welcome word to the Devoxians, wishing best of luck and great 2 days of the conference. And today is not an exception, so I welcome Yuri to this online stage. Yuri, are you with us? Hello.
Hi everyone, and thank you for invitation. Yes, I'm here and hope you hear me well and see me well. It's absolutely new experience for myself. Okay, thank you for confirmation. It's absolutely new experience for myself because all these last years when we supported Java community in Ukraine, in other countries, and last 3 years together with the Devoxx brand, it was absolutely huge, exciting to come morning, a big crowd of young and mature engineers, see all this spirit. And now, as we all see, it's online experience. So definitely for us as co-organizer and a big supporter, and me personally, a big fan of Java community and Java technologies, all modern technologies built around. I definitely would like that we help together and we work together with communities, with experts, with gurus, with all speakers which will be, and you share this knowledge and you get this knowledge. So we still very welcome everybody and hope that all this, as was said, 10,000 big engineering community across all the world, these 2 days will get maximum value out of the conference. And I am very happy that it's not just a regular event, it's a 25th anniversary of Java, and 20 plus years ago, being a kind of like already mature developer and learning Java and deploying in projects, I definitely didn't even understand that in 20 plus years that such a big communities across the whole world and millions of people and billions of programs implemented will be working and developing new technologies based on this framework. So really very happy on this. By the way, it's a good occasion that EPAM in Ukraine also has celebrations this year. It's a 15th anniversary, and I hope that all this year we were good supporters of software engineering industry, development community, developers communities, and promoting new technologies internally and externally across the globe. And I hope that next 5 years we will be happy to see all these new challenges and all these new endeavors which we have together with communities, with the Devoxx brand, and with the EPAM. And definitely, I don't know, nobody knows, as we didn't know last year when met online, offline, in live, and as we don't know today what will be in 1 year. But what I can definitely confirm that EPAM will support the Devoxx brand, will support software communities in Ukraine and in Central Eastern Europe, across all the globe. And definitely we will be very, very happy if you guys get as much as possible new and exciting things. And personally myself, and I believe organizers, we are very welcome and waiting your feedback from this online event. How make it better? Nobody knows what will be next year. Nobody knows what will be in few years. So any crazy ideas, I am really very glad to hear, to understand what we can do better, how to promote better support for conferences, for communities, together with Devoxx, together with the PAM team, together with all sponsors. And also I would like to join Stefan and Oleg in thanking all organizers, all teams, because nobody believes that it's possible to do. We've done, and we definitely happy to welcome you to Devoxx Ukraine 2020. Thank you and enjoy.
Thank
Thank
you,
you so much
Yuri, very
for
much.
your support.
Yeah, and I like crazy ideas. I like this point from Yuri.
Don't go crazy. Don't go crazy. Don't go crazy.
Okay.
Okay. And now a bit of organizational information. So you are watching this broadcast from a special user page. We gathered all the links to the streaming, to the chats, and prize raffles from our partners in one page. The streaming is done through the YouTube platform and is done in 3 parallel tracks. So you will be able to switch each stream during the day at any time. Under the streaming, you will see the chat. You can communicate in the chat with each other, with speakers, and also see some important announcement from the Devoxx team. Also, the chat has several rooms for each stream, so please be sure that you switch the stream before typing your questions to the speaker. Also, please note that the speakers will not be able to see your questions during their talk. So if you want to ask them, you can join the Q&A Zoom rooms after the talk. You will find the links also under the stream. And in these Zoom rooms, you can turn on your video, audio, and actually communicate in person with each speaker. Also, our page at the right side of it, you will see the information about our partners, the companies who support this event this year. And our partners has prepared interesting quizzes and games and prize raffles for you. So please register via the links you will find on this page. And the winners of the raffles will be announced at the closing ceremony at the end of the 2nd day of event.
And also, we want to remind you, don't forget to vote for the best speakers and best talks in the Devoxx Ukraine application. You should download the Devoxx Ukraine application in App Store or Google Play Market. And go to the application, choose your favorite speaker, choose your favorite talk, and please vote, vote, and vote.
Yeah, and the winners, the best speakers and the best talks will also be announced at the closing ceremony. Okay, so we are almost ready to start. We also encourage you to post the photos, how you watch Devoxx Ukraine online, using the hashtags Devoxx Ukraine, Java 25th anniversary. And we will select the best photos, the most crazy ones, and you will get the present from our Devoxx team. So guys, let's start.
Yeah.
Cool.
Ready, steady,
go! Hi.
All right. That was a start,
Okay,
right?
and I'm glad to invite on our virtual stage our first speaker, Sven Peters. Hi.
Hello.
Hello,
Hi,
Sven.
welcome.
How are you today?
I'm doing actually fine. I'm looking forward to the keynote and to speak here at Devoxx Ukraine. Big props to you. Thanks for organizing all this. I know it's a huge effort, so thanks for doing this for the community.
Thank you for supporting our event and joining it. So, okay, the mic is yours. Please start.
All right. Okay. Thanks for joining the keynote. about effective software development. The effective developer works smarter, not harder. My name is Sven. I work for MongoDB, and I'm a developer advocate. So if you think about what is an effective developer actually doing, I have some ideas here in my mind what actually is effective development. So, for example, they write very, very smart code, right? If you look at the code, you think, wow, this is amazing. I need to find out what this code is doing. And then you look at it for 1-2 minutes and say, wow, this is so smart. So these effective developers write smart code. But not only that, they're also fixing bugs immediately, right? If they have a bug, if there's coming a bug in their issue tracking system into Jira or GitHub issues or wherever, they just grab it and fix it, right? And it's done in 5-10 minutes. So they jump on bugs immediately, very, very effective. And also, they just adding new features. So they just grab it from the backlog and just 1 or 2 days later, the feature is done, it is deployed, and it's running and people are using it. Amazing how fast they are. And then also, they never stop. They're always hacking, right? Always hands on the keyboard. If they stuck somewhere because they have to wait for a designer or someone else, they just grab the next issue from the backlog, work on that one, and then once the designer has done their work, they come back and work on the previous task. So they're always on it. And they actually live and breathe code. They just inside out. They know exactly where to look at. If they have an issue, they just know where to look at, which class, which line of code actually. So they know the code inside out. Very, very effective developers. Well, that was me kind of. Maybe not that cool, but I was feeling it in 2003. So 3 years after I graduated. Yeah, sorry, I'm that old dude. But I thought I am super effective. I know the code inside out. I can program. I can do everything. But then looking back from now, I just asked myself, was I really super effective? I would say no. So let's take a look at these things that I just talked about and see them in retrospective. So I was writing very, very smart code. It was actually so smart that even I don't understand it anymore. So I said, please don't touch. I know it's working and it's cool and it's great, but I don't know why actually anymore. So, and then I was fixing all the bugs, just like very, very fast. Someone reported a bug, I fixed it, maybe in the evening, but I actually never got the time to work on the root problem. I should have actually taken the time at that time and just fix the root problem so less bugs would have come in. But I was just like, I want to get this done. Adding new features, same thing, right? I was just wanted to do new features at that time and just grabbing features and then switching to another feature if I got stuck. But you know what? Some of those features got actually, I wouldn't say never used, but they were rarely used. So I didn't really take the most high priority features or the features that had the most impact. So I was just adding features. And then I never stopped, right? As I said, designer needed to work on the task. I stopped and brought and worked on another task, right? But that was a lot of context switching. So I had to stop working on something. And we know when we switch context, it takes us maybe 20 minutes, maybe half an hour to just get into the same flow. So it would have been actually better to use that time to really think things through, to fix things first, and then work concentrated time on that. I live and breathe code. I know every line of code in the code base. I was thinking I know every line of code, but hey, I had the feeling I know everything. But what I missed was actually the broader view, right? Where is this software going in 1 or 2 years, right? What is our vision for the software? I was so in the code that I didn't see the purpose of the software and where should it go. So in other words, I was super efficient, right? I was working on my efficiency. I was ticking the boxes. I was fixing issues, adding features, all the things. But effectiveness, I would question that actually. Well, if you want to work on efficiency, right, then you can do a lot of things, automation stuff, blah, 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 blah. But you actually need to work harder, right, to be more efficient, to concentrate more. But what we actually should look at is to work on our effectiveness and work smarter. Now, you must say, Sven, yeah, you were telling about something in 2003. Sure, things were different down. You know, you had this waterfall processes, and I was actually doing waterfall in the beginning of my career. You didn't have really repositories. I was actually checking in my files on my source code files on a file server. So we had some conflicts there when we were working with two persons on the same file. And then also we worked in silos. We had QA departments and all these things. There was nothing like DevOps at that time, right? So really, if you look at that, what we have now, times have changed, Sven. So now we are agile, right? And we have continuous integration, continuous delivery. Everything gets deployed to the cloud automatically. We just change the line of code and press the button, and boom, it's there. Right? No big release cycles and stuff like that. And we work closer together with the ops guys, right? We know DevOps. Actually, we run our software ourselves these days and don't throw it over the wall to the IT guys like back in the days. So times have changed. Did we not become more effective? Well, actually, there's more, right? We work now in cross-functional teams. We have actually product managers on our team, so we work closely together with them, and designers on our teams, and IT persons on our teams, right? And then we have the cloud, which makes it so easy now to just use things from the cloud and deploy everything to the cloud, right? So these days, we should be super effective. We changed so much stuff in software development the last couple of years, right? Are you feeling you are super effective? You're working on the right things. You have enough time to learn, to work on stuff? Okay, this talk is then for you, the effective developer. And I want to talk a little about how we can work a little bit smarter, but actually not harder. Right, sounds stunning. Let's get started. And the first thing I want to talk is about code. And I wrote down this line here, and it says team code. Why team code, right? Because we write code together as a team. There's just rarely people that just work on the code alone. So most of us work together with other folks on the code. So it's actually a team code. But let's take a step back. So actually, writing good code takes time. We know that. It's not just like we can put our hands on the keyboard and it's flowing and then the good code is on the screen, right? It takes time, and we know that. Well, I once had a boss who said, well, why do you spend so much time in making your code look good, feel good? Actually, the machine doesn't care, right? It compiles everything to machine code and then gets executed. So the machine doesn't care how the code looks like. It is actually the humans that care. Why should we write code for humans? Don't we write code for the machine to get executed and have great apps, right, for the users? Well, unfortunately, we have to maintain code. So once we've written code, it's not done. It's never done, actually. So actually, we read actually code more often than we write code. So actually, when you write code, it's just like a fraction of time that people coming back to that code and reading it and trying to understand what this code is doing and then change it, because we're changing code frequently, right? Once it's written, it's not done. It's never done. So we have to think about that we read code more often than we write code. So it's good to invest actually time in writing very, very good code. And if you look at code like this, you think, whoa, what's going on here, right? It's really hard to read that code. So when I got this, when I opened a class and see this, I said, oh my God, I don't understand it. So who can I blame? So I just look at the original author and go to the author and say, hey, come on, tell me what is this code doing? But then I found out, it was actually me writing that lines of code just a few months ago, and I forgot it. But I know, okay, it was a hectic time, and I had to write this code, and it had to be delivered, right? but that was not a good choice, right? So there's a lot of stuff wrong with this code, but I was just like point out something out here, print income information. We should use camel case here. Then the indents and the lines, it's just like super not aligned. It's really hard to read because of this. Then we have the curly braces that are sometimes on the same line, sometimes on the next line, no consistency here. We have this, okay, I don't want to touch on this magic number that is in that code, but we know the variable and the constant is just like, which way around is that now? And it's really hard to get your brain adjusted to one or the other. There should be rules for that. And then also the variable names are just like, what does it say? Deduction A, deduction B, temp. I have no idea, right? So we should work on make that code look good. So we should actually go and refactor this and make some formatting things. And it's important that we as a team agree on certain coding standards. So because when you read that code, it is like seeing matching patterns, right? You can just see it and you see some kind of patterns when you are in that form, when you are doing the same formatting for the whole code and everyone agrees on some coding rules, right? Because actually what the human brain does, like the human mind does not read every letter by itself, but the word as a whole. We can read this, right? We can actually understand this. And it's the same with code, right? We just look at it and we understand what's going on, and then we can dive deeper into the weeds of the code and look at the lines and what it's doing exactly. But we can just, from a glance, just see what it's doing if our mind is trained for this coding standards, right? So have formatting standards. And tools make that easy to automatically format stuff. I know that, but also go beyond that and say and look at what you can actually format, what you can agree as a team how your code should be formatted. It helps a lot with the readability. And we also know that meaningful names, not temp or A or B or something like that, and for variable methods helps also for people to that need to understand that code, that need to read that code, and helps with the understandability. So I was actually talking about my smart code that I was writing. I call it now here clever code, right? Why do people write that super clever code? Maybe they want to show off, I don't know. Maybe they want to protect their knowledge, I don't know. But it's actually not a good thing. You should actually just look at it and it should be readable, it should be understandable. The code. So I would say it's make your code more simple. Make it more simple. Add one line more if it helps people to understand what's going on, right? So I would go for simplicity over cleverness. So make your code more simple instead of trying to show off and show how clever you are, right? It should be very, very simple. Why? Because I told you this. We are working together on the code, right? We're working together. Someone is writing it, the other one is reading it, and code is our common language. So we need to make it understandable for all the team members in the code. And if you write clever code and maybe some super senior cool developers can understand it, but your junior developers don't understand it maybe. So let's talk about code. Is your code simple enough? How can you find out? And I just read this blog post from Trisha G, and she actually suggested to do something like the canary test with your code to find out if your code is actually simple enough. So like canary birds back in the days in the coal mines, when people were working in the coal mines and they had this canary bird, and the canary bird is just falling down, you know, the air is poison and you have to get out. You know, actually, you give the code to your junior devs. And if they actually don't understand what's going on, your code is not simple enough. Your code is not readable enough to have a common team code, right? We work together as a team on the code. So how do we actually give code to the junior devs and try to understand, let them try to understand what the code is doing? Exactly, code reviews. Invest time in code reviews. Let every line of code be reviewed by a peer, by a coworker, right? It ensures you that you have a consistent code quality, that you have this formatting standard, that you have readable and understandable variable names. But it also helps not just to check if the code is simple enough for everyone to understand, but it also helps to inspire junior developers. developers, right? They see and they learn through code reviews. Now, I've been telling that a lot in my talks, that invest time in code reviews are important, blah, blah, blah. And I get always the question, we have actually problems with code reviews in our team. Not everyone wants to do it, and then there's a lot of ranting going on. So I have here 5 rules how to do code reviews right. And this is more about the team interaction in code reviews. First, if you read code in a code review, try to understand what's going on. So seek to understand. This is super important. And the next thing is, like, if you criticize something, if you're not agreeing with something in the code, just don't criticize the people that have written the code, not the person that has written the code, but the idea as itself, right? Say, maybe I would do that differently. And that's the next thing. Don't rant, right? Don't say, this is ugly code. Just make suggestions how to improve the code. But don't just say, do this instead. Spoon feeding is not good. So don't spoon feed. So don't tell people directly what they should do, right? Just give them suggestions, give them hints, how they should improve the code, how they can make it better. And also important, just for senior as for junior developers, comment on positive things too. It's actually not just you. You should have a positive feeling. Code reviews should leave a positive feeling, right? So also comment on positive things and say, this is a great way, great. Or, oh, I didn't know that. I learned something here. It helps really to make code reviews enjoyable, right? It should be an enjoyable thing to read through code from other people. And the people that give the code, they should just say, oh, great, my code gets improved when you do the code review. So this makes you actually super effective, because actually your code gets more readable, so it's more maintainable and more understandable by the whole team. So also if new team members join, you know that they can dive relatively easy into the code if your code is good. So write team code. All right, let's touch on the second thing I want to say to talk about today, about being effective as a developer, right? And that's learning, right? So when I came from university and I looked at the code base that I had to work with, I said, wow, cool. I didn't know that this is possible. This is so great. My learning curve was so steep. I learned so much. I know it was hard because all the new things just came together, but I found it a great experience, right? And when we look at our industry right now, and it doesn't stop. I'm here since, as you saw, 20 years, which is a long time. Oh my God. So new technologies are still showing up all the time, and we get excited. That's why this conference is so successful, because we want to constantly learn new things, right? We want to constantly learn how to improve, right? But then there's this tension in the industry that we all say, "Ooh, super exciting, a new technology. We have to use that in production. It's the newest ever. So let's go for it." Well. That's nice, and I really love new technology. But when you're starting from this excitement, you also get a little bit like, oh yeah, this new technology that we actually used in production is not maintained anymore. So maybe we jump too fast on this bandwagon, and now the train has moved on to the next cool thing. So you get a little bit like this person here, right? So, you know what? I will also survive the microservice and serverless hype. It's going over, and there's something new coming. Oh, really? A new front-end framework? Again, I've seen so many. Or Scrum boards. That for me. I already know what's important. Don't tell me what's important on the Scrum board. I already know what is important to me. Or code reviews. My code is perfect. I don't write code. I don't need to do code reviews. So with other words, you actually, over time, become a little bit grumpy. Maybe this person is very extreme and rarely to find that is such a grumpy, but I have this tendency sometimes too that I say, yeah, great, thank you for a new front-end framework. I will wait and see where it goes before I actually think it's cool, right? There are some technologies that would stay, some not. But you get this tendency. But we we have to get over this and constantly learn, because actually being in this industry and being in software development is a constantly learning experience. So how do we keep up with all these new things that's actually happening around us through the whole day, through the whole week, through the whole month, through the whole year, right? So what I do actually, when I commuted to work back in the days, I was listening to podcasts and audiobooks. Nowadays, I'm stuck here at home, and I'm doing some workouts in the morning. So I'm doing that during my workouts. I'm listening to some good software engineering podcasts, and also listening to some audiobooks, just to constantly be up to date with what's going on, what's cool, and dive deeper into some of those things. Meetups are cool things. Also, now in the virtual world, there are a lot of meetups that you can attend. So I hope we can meet in person again, because that's actually the thing that meetups do. They're just like the networking thing, and we talk to each other and we get to know people. But still, they are still happening, and we should still support them. We should go them also to constantly learn new people, learn new opinions from other people, and open ourselves, right, to new things. What we do at MongoDB is actually our developer relations team, Lauren Scheffer, actually. She actually invited us to a book club. I'm not the book reader. I really have problems just constantly reading a book. But this book club helps us, because we are reading a chapter each week and then meet for 1 hour each week just to talk about what we just read. And it's not just like that I got to read a book, but I'm also discussing things, and we have this intense discussions about certain chapters that we read in this book. So just try to start a book club and meet regularly. What I also did was I was actually organizing this Video Fridays when we're all sitting in an office. So on this Video Fridays, we actually looked at a video on YouTube that we want to see, a talk from a favorite with an actually interesting topic. And then we met at 3 p.m. On a Friday afternoon, just before we went into the weekend, watched the video, discussed it, and then went into the weekend. That was a regular thing. Also here, same as the book club, we take time as a team, and that helps us to learn, right? Sitting alone at home, but doing it as a team just gives us a little bit more like motivation to learn, and it has this regular thing. So I can just recommend, we need to constantly learn. And you're here at Devoxx Ukraine, so you know what I'm talking about, right? You're here also to learn. But I hear that sometimes from junior developers, Sven, why should I learn, right? Why should I actually learn? Because if I have a problem, all the answers are in Stack Overflow. I just go to Stack Overflow and look it up. So why should I listen to a whole book about this topic? I can just copy and paste the code, right? This is how we do it. Maybe it solves the problem short term, but you don't really understand what's going on. Someone else solves it for you. So first thing is always try and solve the problem. Try to understand the problem, and then try to solve it yourself, right? That's the first thing. Sometimes we got stuck and say, I can't go on here. I'm stuck here. So what should I do? Yeah, you should ask for help. But before you go to someone and ask someone for help, ask yourself for help. This is a technique called rubber ducking. So you just take the rubber duck and explain the problem to the rubber duck. And it's amazing because you just step a little bit back and just think about the problem from another view. And all of a sudden, some answers are popping up in your brain and say, oh, I can try this or that. So this is actually a technique. Before you go to someone else, tell your problem to the rubber duck. Sometimes the rubber duck doesn't help, and you can't come up with an answer. So third thing is ask actually someone for help. Don't be shy. Say, I don't know what to do here. Ask someone for help. That's a great way if you work in teams together. We are here to help each other. And then this also helps us to understand the problem and to dive deeper, because actually this learning experience makes new connections in our brain. We know that. And it helps you if you run into the problem again, use that connection to solve the problem. But not only making new connections is important. And coming back to this grumpy developer, right? actually getting rid of some of these connections is actually also important. We need to learn to unlearn. As I said, I was actually learning waterfall methodologies. That's the best thing. I was learning this in university. Waterfall is the best thing to develop software. We all know that having this big chunk of work in front of us, working on it and showing it then to the customer is not a good idea. Software is way too flexible. So a little bit more agile approach is way better for most of software development teams. I needed to unlearn that. That was pretty obvious to me, but we also have learned some stuff that we need to get rid of it, because actually we need to get rid of some connections and also learn to unlearn. Now, how we become a little bit happier is also to give our knowledge to other people. And I know that a lot of you are actually not junior devs. You're probably also on the senior dev after 2 years in this industry. You have seen things and you become more a senior developer. And I want you to help the junior developer, because we are actually getting so many new developers, because we need so many developers in our community to help them actually to overcome this first 2 years, right? And so please become a mentor. Become a mentor, and mentoring is very important. So give your knowledge, pass that on to the next generation of developers, right? So how do we become a mentor? It's a little bit like this rubber ducking, right? Rubber duck needs also to listen. So let people speak, because same thing as the rubber duck. It helps people to frame their problems, and maybe they can't come up with an answer themselves. Ask questions, go deeper, ask the right questions, and then maybe if they don't come up with their own direction, give them some pointers. Also here, like in the code reviews, don't spoon feed, just give them directions where to go, and then always have an open door. Don't say you can come back next Monday and then we can discuss it again. Say, if you can't move forward here, just come back to me. My door is always open. And actually, I had to learn it the hard way. I was thinking I can do it faster if I do it myself. But actually, just taking the time and listening to this people, and it surprised me what solution they came up with. I wouldn't have chosen that solution. Sometimes I'm thinking, oh, that is a good solution, but then it works out, and I'm just like, I'm super surprised. I'm a little bit ashamed that I didn't come up with that solution, but it's great. So they actually surprise you. It also helps me to continuously learn that there are some other ways of doing things that are maybe better, maybe equally good. So, but this learning is actually a constant thing. So it's an infinitive loop, right? We learn and then we unlearn. And as I said, mentoring is all about advising people, but there's one ingredient missing here. And this is just like to experiment, to see, because learning is about like what other people have told you, and then maybe try something out. But experiment is really something that gives you another push, pushes you in another direction, right? And that's the next thing I want to talk about. How can we be better in experimenting, trying new things out? Because when we look at what we do day in, day out, it is, well, all our tasks are on this board, right? We look at the board and all our tasks are on that. Well, maybe not all our tasks. The rest is in Jira. I know it's already full here, but the backlog is even more full. So all of the tasks are here. That doesn't leave room for any improvement, anything new, any cool new stuff that we can try out. And we know that not all the tasks that someone has written on the card are the best solution, right? We know actually that there might be a better idea actually for this task that is on the board. So how do we actually come over this known unknowns, the things that we know that there is something that might be better or might not? How do we know that? So we know maybe there is a better solution out there. There must be a better solution out there. Or we're missing a better solution out there. maybe a new technology can help us there. I don't know. I haven't tried all the new technologies that are in the world, and I don't know. Maybe there is something that can help us. And also, we're missing some opportunities here. Maybe this direction, this cards, is not the right way to go for the software. So how do we overcome this known unknowns? Well, don't be shy. Just try. Try out better solution. Try out new technology. Try out new opportunities. And that's just carving out time, because this is what we don't have. We work day in, day out on this board, but we need to also take time to experiment, to work on this known unknowns. For example, what I do is with my team is we're doing coding sessions. So we're trying a new programming language, or let's say we want to try TypeScript, or to find out if that can help us, right? And then we're doing 1.5 hours, 1.5 hours a week. We set the time aside with the team, and then do some coding together. We're doing this as a team, and this helps us to really stick to this time and to learn together as a team. So let's say this is 1.5 hours of improving. So seems to be good, right? So 1 hour improving, we can invest that. Then all the tools that we're using, dive deeper into the tools that you use. Do you use all the features? Do you know all the features? Do you know what's actually what this tool can do for you? And then also, what are other tools out there on the market? Are we using the right tools? Should we use something modern or some other tool? So go and find out and try those tools out. So for example, go and try GitHub Actions, right? Try them out to see if this is something that can help you, or try another IDE like this new online IDEs like Gitpod, where you have your whole environment built in the cloud, your workspace environment. Maybe this can help you to boost some productivity. If you never try it, you don't know, right? You don't know if this is a better way to do things, if you do the same things inside out. So do a little bit of tools training, not just your own tools, but also try to use some other tools. Let's say half an hour a week, or even more, I don't know. So add half an hour to this timesheet, so it's 2 hours of improving. So this is also just all trying things that other people have thought before. Where are the other opportunities? Where are the things that we don't know? The innovational things, right? So how can we improve our software? How can our software be better? So what can we do to try things out with our software that we're building, and spark some innovation things in our software? Well, first I want to talk about what not to do, right? What not to do. These are not good things, and I've seen that in actually some kind of a lot of companies, that some people think like, the boss is the genius. So the boss knows what to do. The boss tells us what to do. We trust the boss. The boss has to say what we're doing. So the boss is the genius, comes up with these new ideas. Not a good thing, because we all have good ideas, right? Same as the lone genius. This person that sits in the corner and thinks about new things and tries new things out and give that to the team and say, we have to try this. There are maybe people that have great ideas, but other people have great ideas too, but maybe the voices are a little bit lower, right? But maybe you think about, there are some people with all these great ideas, so why don't we put together them in a team, right? A team of geniuses. Also not a good idea. We tried that actually when I was working at Atlassian. We had this team of geniuses. The problem was that the rest of the organization said, oh, innovation is happening in that team, right? We don't have to think about new stuff, but good ideas can come from everyone. The problem is not that the lack of ideas, right? Everyone has great ideas. What is the problem then? The problem is the lack of time, right? As I said, we're working on this board day in, day out, trying to please the customer, but we're missing some opportunities how we can really push the needle forward, probably by taking time off and trying some innovative things. So how much time actually do you need for innovation? Is it 40 hours? What if I give you 30 hours a quarter to try some innovation? But what if I give you 24 hours, right? We all maybe doing this, or we want to do this 24-hour hackathons. We're doing this at MongoDB. We actually have done this at Atlassian when I was there, and we were actually kind of the first ones that did this 24-hour hackathons. We called them FedEx days at that time because delivering in 24 hours, right? You have to deliver your idea in 24 hours, FedEx, right? Delivering in 24 hours makes sense, right? But we had to rename that because in the Google results, we were just in front of FedEx, the company, with our FedEx days. So they asked kindly to just rename it. So we called it Ship It Days. Anyway, small anecdote here. But we actually put that together in 3 phases. So it's a planning phase. Then it's the event phase. So what are we doing during the event? And then we have a follow-up afterwards. So let me dive a little bit deeper into how we organize these Ship It Days or these hackathons. First, we plan the days actually 3 months in advance. So everyone knows all the schedules, release schedules are planned around this hackathon. So everyone knows these 2 days we're doing a hackathon, right? Then we announce and tell stories. So we don't just go into a hackathon and say, well, now it's time for a hackathon. Let's collect some great ideas. No, we're preparing this. So we actually write stories, what we want to do and what we want to reach. And also we use these stories for pitching it to other team members because some team members may don't have time to think about great ideas. So what we do is we organize some brown bags 2 weeks before the event, and then we pitch our ideas to the company. And then we say, oh, we need some designers and maybe some marketing people to have a great slide deck for the presentation at the end. So we pitch these ideas to some people, and they can jump on the team. Then the hackathon starts on a Thursday afternoon, 3 p.m. The time is ticking. It's a little bit pressing, right? Because you have to deliver, or you want to deliver in 24 hours. So it's a little bit like very exciting, and it can be a little bit hectic at the end. What you should keep in mind is just like to having fun. This is a fun thing. It's about doing something that you're passionate about, that you want to do. It should be fun, right? It should be a fun event to work on your own ideas. Then don't forget to get energized, eat and drink. Actually, when we did that in an office, obviously, there were not a lot of people staying overnight. So no one really did 24 hours. But there were some people that stayed until 10 p.m. and then came back at 6 a.m. So they had a short nap at home and then came back. Do whatever you like, but just get energized and drink. So, and then 3 p.m. of Friday afternoon, so 24 hours later, we need to deliver. We should just show off what we have done, right? Give all you got. It's also about the presentation. Then we vote for the winner, for the best ideas, for the best presentation, whatever, the most innovative stuff. And then we celebrate together. And then we look at it and say, what can really go on the product roadmap, what makes sense. The coolest ideas is maybe sometimes not the best ideas to give it to customers, but still can win and be the coolest ideas. But there are some ideas that really could turn the needle, right? And then we plan for the next hackathon. So we say in 3 months, there's another hackathon, this date, and then the planning cycle is done. So we have this problem that not everyone actually could participate on these hackathons because it was more like a software engineering programming thing, right? So all the marketing people, legal people, designers, they also wanted to do something. So feel free also to involve those folks. They don't have to write software. So here's an example where someone came up with building a hidden whiskey bar in the office, and hopefully people can go there soon again in Sydney. So it's a socializing place, and it helps to bring everything together. So everything that improves collaboration, improves the software, is cool for a hackathon. So let's do the math here. 24-hour hackathons, doing them every quarter, gives us 0.7 hours a week on our timesheet. That's 2.7 hours of improving. Now let's put a little bit more hours in here, because we also have known knowns. So, these great ideas, maybe some ideas don't make it to the product roadmap. What are we doing with those? And we want to maybe we didn't really get to the point of showing what's really capable with this idea. Or there are this small other things, right? I call them paper cuts. So these are really small things that is a little bit like hurts a little bit, like paper cut. It hurts, but it doesn't really end up on the roadmap because it's too small and it doesn't have a lot of impact. But if your software is full of these small things, software get a bad reputation. People don't want to use your software because it's just full of the small little things, right? The small paper cuts. And maybe you heard the term of death by 1,000 paper cuts. Your software can be so good and so innovative if there are so many small things that really hinders the people to do a great job. Well, you should fix those, but they never end up on the roadmap. So what could you do? Here's the thing, right? Instead of 20% time, which we also tried and didn't really work out for us, we did innovation weeks, right? So every 8 weeks, we took a whole week off. I know this is a big time investment, but you're working on real things for the software. It's not like hackathons where you try things out. You really come up with a plan and work on this innovative things for the software that doesn't make it into the roadmap. And you work on paper cuts, small things that hurt the users, and you fix those in those innovation weeks. And this really this can turn the needle. And it's also good to do it as a team, and that's the difference, 20% time and innovation weeks, because you as a team take time off. So where 20% time is about the individual, and this is about the whole team taking time off. All right, this is actually a big add to this timesheet. So 5 hours of in a week make 7.7 hours of improving. You should invest time in discovery. It's so important. You should invest time in this one to help you move things forward. It's like training for soccer players. You should also invest time in discovery. Where should the software go? What are cool things to do? And use this time. But now you must say, Sven, my calendar looks like this. It's full. Where should I put it in? Right? I barely can come to my real job of doing programming stuff. Where should I carve in some innovation time? My boss won't allow this. And I've heard this a lot. It's time to reduce the overhead, to really spend time on innovation stuff and also to work on what matters. So reduce your overhead. Get rid of some of those meetings, right? Get rid of those. But which meetings should you cut, right? You should ask yourself, actually, do I really need that meeting? Is that something that I really need? And especially about recurring meetings, like one-on-ones, weekly status meetings, daily stand-up. I wouldn't put that actually in the time of them we're all working from home into this kind of necessary. If you're working in an office, we could question if we need stand-ups, right? But weekly status meetings and one-on-ones, you may don't need that. So here's an experiment that a colleague of mine did. He actually canceled all recurring meetings. He just said, okay, I'm going to cancel it. See what's happening. So first thing, I'm going to write to the person, is it still necessary, this one-on-one? Do we really need that? Let's stop it for 3 months and let's review it. If we miss something, maybe we do monthly, but do we really need this weekly thing? Another thing that you can ask is, am I actually still the right person? I know once I was the right person. Am I the right person in that weekly status meeting? Maybe you should invite someone else. Or am I actually always required? Should I be there the whole time? Or do you just need me for 5 minutes? Or just for certain meetings where you cover some topic that interests me, or that where you need me, actually? Just invite me when needed. So cancel all recurring meetings. That was an experiment that he did. Actually, it freed up a lot of time for him, and he didn't miss so much things. So also replace recurring meetings with status reports. So the Confluence Cloud team actually did this status report where they actually did this weather report. So every part of the Confluence Cloud team, engineering, product, marketing, did this weather report, put in their current weather report. So it was sunny or rainy or something, and put in the status update. So everyone knew what's going on without having a weekly meeting. And then if something gets stormy, they called in a meeting and said, hey, we have to talk about this, right? Because it's getting stormy here and we have to align. So just in case that something needs to be synced, they synced. If not, they got the updates through this weather report. So also stand-ups, as I said. I think it's at the moment it's still important that we meet and that we talk to each other. But there's some other ways, like having a Google Doc where you write in your daily stand-up, or Stand-Uply here as a tool for Slack that you could use. Try to see which meetings do you really need. Do you need that daily to carve out time, to have more time to experiment, to learn, and also to do concentrated work. Actually, you should ask yourself, do I have to call in that meeting? And there's this decision matrix, and there's a link at the end that you can jump on my webpage where you can get this decision matrix. So let's go through this decision matrix to see if it's really, if you should call in the meeting. So you want to make a decision, solve a problem, get feedback, generate ideas, right? So we call in a meeting for that. Let's say we want to generate some ideas here. Does that need to happen in real time? Yes, I want everyone in that meeting. So does everyone have enough background information to get it done? No, actually, I didn't share any information with them. I just wanted to share that in that meeting. Oops, fix that first. No meeting. All right. So I should send around the background information first so people know. Makes sense. So use this matrix to decide if there's a meeting or not. But at the end, maybe you come down to boom, schedule it. We're doing a meeting. Woohoo! Try to make it as effective as possible, right? Write down the agenda first, have meeting notes so people can decide not to attend, but still get the information out of it. So having meeting notes somewhere on a Google Doc, in Confluence, wherever you want that, so everyone is on the same page. At the beginning, introduce the agenda and ask people to leave. Do you think you have something to say today? If not, leave now, and you can use the time better than sitting in that meeting. Of course, physical meetings, close your laptops, but also in virtual meetings. Don't read Slack messages, don't answer emails. Be fully focused on the meeting, use that time efficiently. And then also in meeting rooms, we have this here. It's a rubber chicken, not a rubber duck, a rubber chicken. And once a person gets off topic, you take this rubber chicken and say, and all of a sudden the person said, oh, sorry, I went off topic. Let's concentrate on the things, right? And squeeze the rubber chicken. Nowadays, you just have to hold the rubber chicken in the camera and don't squeeze it, and people know, oh, sorry, I went off topic. So this is a good thing to just have a concentrated time in the meeting where we all concentrate on the things, and maybe carve out time. I know nowadays, we need to social interact a little bit more because we're all stuck in our home office. So reserve some time for some social interaction. But if you want to talk about something, then be concentrated on it and use maybe the rubber chicken. And I'm actually, these things can actually help me a lot using my time. Right, I'm wasting a lot of time by meetings, email, and Slack. Right, I call them time sucks because I spend so much time in them that the day goes by and I get nothing done. Right? Why is that? Because it's easy. It feels like we're getting stuff done if we answer emails, if we go to meetings, if we answer Slack messages, and it avoids a little bit thinking about the harder stuff. Right? The hard stuff. But this really needs some concentration time. I can answer a meeting, an email. Just between two meetings, that's easy, but I cannot come up with a new concept or really dive deep into coding, into a coding session. When I know in 10 minutes I have a meeting again, or the Slack message pops up and I'm distracted again. So carve out time actually for deep work. And I can just recommend to try to carve out time for the whole team for deep work. So the whole team takes time off and concentrates, right? So what we did is actually, we said from 1 p.m. to actually 4 p.m., we have this sign on the door when we were working in an office. Now we have a Slack status message we're not available, we are back at 4 p.m., we have deep work time. We concentrate as a team. So all the meetings were in the morning, and in the afternoon, we took time off. And that actually spread it throughout the organization. So nowadays, a lot of people are doing deep work time, certain time at a day, and people are looking forward to this concentration time. But some people have to make support, right? So have one person maybe that need to react, that can react. So just one person in the team that maybe is answering the Slack messages in the room, in your Slack room, or is the one, if you're working in an office, have a flag on the desk and say, I'm the support person, so talk to me, and then rotate the support person. So not one person has to do the whole duty, but one person a week has to do the whole duty, right? So a support person can answer the first level support things, and then maybe can talk to the team, but the team is not, the team can work concentrated on things. What I also do often is getting stuff done day. So reserve a whole day as a team to work on one topic. Like we need to refactor, right? We know that. So just reserve this one day to refactor. Call it a refactor day. You're always looking forward for that day. Turn off your emails, turn off your Slack messages, and do just as a team refactoring, documentation, whatever things lay on the table that you said, oh, we know we have to do that, but we need to concentrate on that, right? So just reserve one day and then getting stuff done day. So this is actually helps you to get this hard stuff done, right? But Sven, what is actually the hard stuff? Okay, that's the last thing I want to talk about, to work on what matters to be more effective. Let's give you this here. Let's say you want to work in you want to build a factory, and maybe a solar panel environment-friendly factory, right? Where you build your solar panels. There are experts talking about automation and chemicals and stuff like that. You don't know, you don't want to dive in, you trust those experts in these meetings. So yeah, do your thing, that's great. Automation, yeah, do your robot thing. But then the conversation comes to this here, the bike shed. And all of a sudden, all people in that meeting have an opinion about the bike shed. Which color should it have? How many bikes should there be in there? And that's called bike shedding, right? If people talk about spending too much time on things with low impact, who cares about the bike shed, right? Let's put it in a bike shed. But everyone has an opinion about that. And it's also called priority delusions. So we're talking about things that are not having a big impact. And we need to spend more time on things with impact. We should talk about this elephant in the room. We should talk about the problem that we want to solve in software development. What problem does this feature that we're gonna put on solve? I've been in a lot of projects, and a lot of people just say, "Oh, we need this button to add a user here." I say, you need to, yeah, that's great. Let's put in a task, or a project or whatever, to say we need to add a user here. But why should we do that? Is there validation data that people have really a problem and need that button right here? Or are there other solutions? Maybe it's not smart to add buttons everywhere, so people get confused. So talking about the real problem that we want to solve, we don't take enough time to do that. Maybe one person has thought about that, but not the whole team. But the whole team have to buy in if we work on a project to understand what the problem is. So what we do is actually we fill out that project post, and we've worked a little bit on that. Also, links are back on my page to download the project poster. And we worked on the questions a lot. So there's questions like, why are we doing this? How do we judge success? What are possible solutions? And before we start with the project, we need to fill out that project poster. And we're not just done. It's a living document. So also validation data ready to make it. So once we have that, we have a common understanding of the whole problem that we want to solve, right? And this is super important for projects to have this kind of information handy. Also to hand it over to people that actually want to know what's going on, right? What are you doing here and why are you doing here? You can just hand over the project poster. Now, and that breaks down actually to also user stories. So if you write user stories like this one, as a user, I want a new statistic button so that I can see the number of data sets, right? It could be a user story for MongoDB, so people want to see how many data sets are in my database, and I just want a statistic button to see which time did they get added. Great. But this is already the solution. That's not the problem, right? what do people really want? So you should work also on the user stories to carve out the real problem. So not as users, you should name the user as Yasmin. You want to know the number of data sets so that I can plan for growth. This is what I want to do. I want to find out, do I need to add another chart or another database so I can plan for actually growing my database. So you should think more like your users, right? Like Jasmine, as I just said, like Lucas and Tina. These are all different users with different stuff. So maybe Jasmine, she's a developer in training, wants to have the statistic, but Lucas has some other requirements too. So think like your users. Think always, when you talk about the features, you should always have the users in mind. So learn your users, and we're using not real users, we're using personas that represent users. So we have this personas. And when we talk about a new feature, we talk about, how would Jasmine solve that? How would Lucas solve that? So we have a sheet where we talk about how their education is, what they're doing, how their knowledge is. So we have that users in mind, and we should get reminded of these users all the time and actually everywhere. So you can't really escape from our personas, right? They are literally everywhere. Now that you have all those user stories, right? What user stories should you work on first? Think about the happy path of your software. This where 80-90% of the people spend their time, right? So this is actually the happy path. Fix this first before you fix the corner cases. So how do you find out what to fix in your happy path? Well, we do a technique called journey mapping. So we write down here, what is the journey that a user takes? So on every step in that journey, we write down, and then we write, what problems do people have? And how do we solve that? So we have a good understanding and fixing those things, so we make 80-90% of our users super happy, and that makes our software much better and much more enjoyable. And then do that for each persona. So different personas have different journeys, so you have a good understanding of how to improve your happy path in your software. Now, I've been talking a lot about features and how to improve software from a product perspective, right? But we are here, we are all developers, we think about code, and you, Sven, you have talked about all the product stuff. That's actually should be done by the product manager, not by us developers, right? We are just responsible for the code to get this done. Yeah, so this quote here, I wish engineers spent less time understanding the problem and more time coding. Who said that? That said nobody ever, right? We need to understand the problem, the underlying problem, what we solve there with our software. We need to understand that to make decisions on our own and help the product managers, right? Because we know what's possible. So let's go hand in hand with the product managers. We actually should become product engineers, right? So also as an engineer, work close together with the product side of things. So maybe you're a junior developer, that's fine. Care about the code first, and then learn more about the product. If you're more than 2 years working on the product, you should actually become a product engineer, if that is your thing. I know it's not for everyone, but think about it, becoming a product engineer. So what things can you do? First things, do hallway testing. I know the product managers do the user testing, but you could just, with a prototype, run around and show it to your coworkers and say, do you think this would work? And get some feedback immediately, right? Or go on support. We actually had this program where we sent developers for 1 week a year on support to help with support cases and get to know what the real issues are with real users. So that also helps actually to understand the user better and to improve the software where the user needs it. And also become a data detective. Don't just look at the performance data and stuff like that. That's of course, you should do that too. But also go in and see which features are used the most. Should we spend time on the least used features, or should we spend time on the most used features? Obvious question. Sorry for that. So it's important to work on the things that matters for the customers. So become an effective developer. Okay, let's wrap up here. My hour is always almost over. Think about team code. You code as a team, have coding standards, coding formatting standards, so people can actually simply read the code. Learn, constantly learn. Do a book club or whatever. Constantly try to improve. Become a mentor, right? Think about that, to become more effective and pass on your knowledge to the younger generation that can actually do the work so you become more effective. Experiment, try new things. This really turns sometimes the needle. The things that you haven't thought of, not the obvious things, right? Try to carve out time for experiment. This is a little bit on the efficiency side. Reduce your overhead, kill meetings, whatever. Try to have deep work time, and also work on really what matters. This is also important. Work on what matters, and this really turns the needle, and this makes you super effective as a developer. Now, this is a windy road. There's no approach, and you can't really. It's hard also to measure these things. It's not like efficiency is pretty much straightforward, right? If you think about efficiency, it's pretty much straightforward. So you are faster, you're better, you fix more bugs, all those things. And don't get me wrong, this is also super important. I know at the beginning I was a little bit ranting about that, but it's super important to work on some automation stuff, to automate things that you do twice or 3 times, and then you should automate it, right? Know your tools, know your command line tools, right? Try to use the command line, be more efficient in that, be faster, be more efficient. And then also deep work, and I was talking a little bit about that, carve out time for deep work to be more efficient. But when we talk about efficiency, it's to get more stuff done. We get more stuff done if we be more efficient. If we automate stuff, we have more time for doing some else things. But being effective is more about getting the right stuff done, right? Getting the stuff done that is super important. Or with other words, efficiency is about the output that we generate, where effectiveness is about the outcome. So think outcome first. Be effective, and at the end, get shit done. Thank you so much for attending my keynote. And I'm now jumping, I think, in the Zoom room to answer questions. Is that right? I think so.
Hi again. Thank you a lot for your talk, Sven. And we invite you to answer the questions from participants and to join our Zoom rooms. So once again, thank you for supporting our event, and we were glad to welcome you on this online stage. Thanks.
Thank you very much. Thanks.
Dear participants, we know that we are experiencing some technical problems. We are very sorry for that, and we are working hard to fix it and to bring you back to the streaming. So you have received an alternative link to the user page via the email, with a mail letter, and the link was also published into the Facebook and Twitter channel of Devoxx Ukraine. So please follow this link, and you will see the user page as you saw it at the beginning, and I hope it will work for you now. And to view the schedule of the program, please use the mobile application. Download it for iOS or Android, and it will reflect the relevant talks schedule. Okay, and now I want to invite you to view the presentation from our platinum partner, EPAM company. And we have a representative from EPAM, Evgen Mospan, Senior Solution Architect and Head of EPAM Java Competency Center Services. Evgen, are you with?
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right, to be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM. Focus on your growth.
Hello, Evgen.
Hello, Devoxx.
Hi. So, how are you today?
Good. How are you?
I'm great. I'm so excited that we started Devoxx Ukraine Online today. So, please, your welcome word.
Hello, Devoxx participants. And let me tell you about something we do at EPAM in scope of competencies. And today I will focus on Java competencies, Java Competency Center and its services. And before I start, let me tell you about something about myself. So my name is Evgen Mosman. I am a senior solution architect. Now I am a head of a Java Competency Center at EPAM. So I am more than 15 years in IT, have a different experience in the different business areas and expert areas. And here you see the contacts with the help of which you can find me via email or LinkedIn. And so today I'm going to talk about the competency centers at EPAM, specifically Java, and the services we do for our customers and for our contributors. So what is basically competency center at EPAM and specifically Java? So it is an organization which consists from experts who can provide some service in scope of a particular technology. And speaking about Java, we have a quite big range of representatives from location perspective at EPAM. So as you can see on the slide, we have presence in 16 countries from 30 plus EPAM locations. So we cover the biggest one in terms of engineering centers like Ukraine, Belarus, and so on. And so we do have core experts all over the world, which who help us to build the services and deliver the best support for the clients that require some technology consultancy in scope of Java technology, so who are looking for the innovation and services. And we do have more than 300 contributors from these countries who are being supervised by these core team experts. And if we talk about the services, so we tried to basically split them in three streams. So first is mostly oriented on our customers, and it is called pre-sale support, where we do different stuff like helping our pre-sales team to propose the best solution in Java world. We help to create this proposal. We help with discoveries, create some POCs, and so on and so forth. We also focus on development and production and help to kick off the projects, to supervise them, to help with architecture design, review, and so on and so forth. And we, of course, focus on our competency growth inside the company. And that is why we have knowledge base for our engineers who work at EPAM. We help them to get up to speed in terms of recent standards we require from our developers running the pre-assessment and assessment services. We do a lot of interviews. We also share our knowledge through webinars and tech talks. We do have partnership with other Java big companies like Azul or Lightband. And we, of course, run the certification process. So we promote the Java certifications, which are popular all over the world among Java engineers, and help them grow professionally. So in 2020, we just listed below some highlights from the customers we did really support. Not all of them we can share in this audience because we have NDAs. But what we can also mention is that we do support educational programs of EPAM, like master degree program in software engineering, and we run a global Java mentoring program in our own tool, which is called Learn and Development. So this helps us. This helps our engineers to grow professionally. And just to show you that it is all real, and we do really have a support from our colleagues inside EPAM. So this is the statistics that we gathered for the first 3 quarters in 2020. And despite the fact that we live in a new normal, we didn't stop any of the services. So we do have the requests. And on the left side, basically, the amount of requests shows that most of the requests are dedicated to the competency growth, which is pretty obvious because we do have a lot of engineers. They want to get a new level. They want to go through the certification process, but these do not require a lot of time, which is shown on the right side. So basically, we see that the time spent by our contributors are being split really smooth. And most of the focus we spent on development and production because this is where the things are happening. And we want to make the expertise real. We want to make it be helpful for our customers. So what else I want to say? So I really want to say thank you to all of you that you continue to grow professionally and visit such conferences like Devoxx. If you are interested in what we do inside Java Competency Center, feel free to contact me, and I will be more than glad to help you. So going back to the main stage, guys, do you have any specific questions?
Thank you, Evgen. Unfortunately, the participants can't join and ask questions directly to you now. So, guys, please, if you enjoyed Evgen's presentation and have any questions, feel free to contact him via LinkedIn or any other channels. So, thank you once again for your presentation. And
thank you for giving me a chance to talk.
Thank you.
Hello to everyone. Let me introduce myself. My name is Ira, and I will moderate our third stream during Devoxx Ukraine. I'll do my best to create a good atmosphere in our track, and we'll check some details later. Also, let me apologize for some technical issues. If you have some problems with access to our website and or streams, you can find updated links via email, or the link was also posted in our social media and on our website on the main page. Okay, that's all about organizational details, and I'm ready to invite our first speaker. It's Matt Atamel. Hello, Matt. How are you today?
Hello, I'm good. How are you?
Not bad, thank you. What did you prepare for us today?
Today I'm going to be talking about mainly Knative, an open source project to run containers in a serverless way. And then I'm talking about the eventing aspect of Knative, so how to build event-driven applications using Knative.
Sounds great. Okay, so the mic is yours. Welcome to start.
Thank you. Hello, everyone. My name is Meta Tamel. I am a developer advocate at Google. And today I want to talk to you about event-driven serverless architectures with Knative and Cloud Run. Now, before I start my talk, I want to let you know that I write about these topics on my blog at atamel.dev, and I tweet about them as well on my Twitter account, so feel free to follow me. And also the presentation is already on Speaker Deck, and here's the link, so feel free to get the presentation as well. I'm also going to be showing demos throughout the presentation, and they're all open source and on GitHub, and I'm going to share the links of that as we go through the presentation. Now, as I mentioned, this talk is about event-driven service architectures with Cloud Run and Knative. But before we get into the event-driven part, first I want to talk about serverless and containers in general. Then I want to get into what is Knative as a project and what it tries to do. Then Knative has two separate parts, Knative serving and Knative eventing. So I want to mention the Knative serving a little bit and just show you a little bit about that, because without that we can't really understand the eventing part. And then finally we'll get into Knative eventing, and then look at what Knative provides for you to be able to write event-driven architecture. So we're going to start building towards Knative eventing. And towards the end of the presentation, I will show you an app that I built during the lockdown. And this app uses all parts of Knative, the Knative serving, Knative eventing, and hopefully that will kind of bring it all together. So that's our plan as we go throughout the presentation. Now, first, let's just talk about serverless briefly. Of course, depending on who you talk to, different people have different definitions of serverless. But actually, you can think of serverless in two different ways. The first way is the operational ways of thinking about serverless. Like, so how do you actually run code in a serverless way? And when you say you run the code in a serverless way, you basically usually mean that you don't have to worry about infrastructure. So you don't have to set up servers. You don't have to worry about the security of those servers, blocking the ports and things like that. And then you only pay for the time that you're using your service. So for example, if you deploy a serverless function, you only pay when people use your function, but you don't necessarily pay all the time like you would on a server or like a virtual machine. Another way of thinking serverless is the programming model. So when you're building serverless services, you usually mean services. So we are not talking about background jobs or big data processing or anything like that. They are usually service-based services that are usually triggered by an event. So this event could be an HTTP trigger, but it can be other things like pops up messages or cloud storage events and things like that. And usually these services are stateless because these serverless frameworks or services, they are elastic, meaning they scale down to zero when no one uses them, so you don't have to pay. Then they scale up when a lot of people are using them. So when that happens, if you don't have the state, it's much easier to scale it up and down. So that's why this state is usually external. So that's what we usually mean by serverless when we talk about serverless things. At the same time, we have these other things called containers. The whole premise of containers is that you have your application. Your application has some dependencies on other libraries, and your application has some environment needs, like for example, it needs certain ports, things like that. And you define all of this, your app dependencies and its environment into what's called a container. And then this container, it's basically a context that you can replicate on different environments. So whether you run the container locally on your machine or whether you run it in the cloud, you can rely on this context. So because of this, containers became really popular because it gives you this replicatable context that you can run anywhere. It gives you a lot of flexibility, so you can choose any language you want, you can choose any library you want pretty much. And there's this huge ecosystem around containers where there are things like Kubernetes to manage containers, there's Istio to manage the traffic to your containers, there's other projects like Knative that we're going to talk about to run containers in a serverless way. So that's why containers became really popular. Now, when you look at it, up until recently, we had to make a choice from the beginning, right? If we start a project and if we can use a serverless service from a cloud provider, like Google Cloud Functions or AWS Lambda or Azure Functions or something like that, great, we can do that, and that will give us a lot of velocity because we have a lot of things that's done for us, so we don't have to worry about the details of how to run that service, how to scale it and things like that. But at the same time, as soon as you run into a problem with the framework, you had to fall back to containers. And by problem, I mean things like the things that are supported. For example, if you want to run a certain language, like I don't know, like Rust or something else, maybe that's not supported in the framework that you want to use. So then you can use a serverless framework for that. So what people did is basically they went with serverless when they can, and they get the velocity with the serverless. But as soon as they cannot use it for whatever reason, then they would fall back to containers. And with containers, you get the flexibility, but then you kind of lose the velocity of serverless. So this was a really unfortunate choice that we had to make. But thankfully, the projects like Knative and Cloud Run, they try to kind of get rid of this choice so that you don't have to make this choice yourself. Knative, it's an open source project that was started by Google, but now it's fully open source and a number of companies are contributing to it as well. And the whole premise of Knative is to bring serverless to containers. So usually when we talk about serverless, we talk about serverless functions, but Knative tries to give you a way to deploy containers, but in a way that's serverless. And we'll talk about what this means as we go along. So that's Knative. It's open source. It runs everywhere there's Kubernetes, whether you run it on-prem or in the cloud. You can use it anywhere you want. But if you are running in Google Cloud, there's also two flavors of Knative called Cloud Run and Cloud Run on Anthos. These are managed version of Knative that Google provides. For example, Cloud Run, it's a fully managed service that implements the Knative API. So if you're already on Google Cloud, it's probably much easier to use Cloud Run instead of installing Knative yourself. And also there's something called Cloud Run on Anthos, which is a version of Cloud Run that runs on Google Kubernetes Engine. So if you want to stay in Kubernetes ecosystem, but you want to be in Google Cloud, you can use Cloud Run on Anthos as well. In today's talk, I'm mostly focusing on Knative because it's the open source version that runs everywhere. But most of the things that I'm going to talk about, they apply on Cloud Run as well. So you can run them easier with Cloud Run if you're in Google Cloud. But we'll focus on Knative in this talk. All right, so what is the Knative stack? Well, first of all, you have Kubernetes at the bottom layer. So that's the platform where everything runs. Then on top of that, you need to install a gateway. So Knative, it doesn't try to solve networking problems, right? So it doesn't try to figure out how do you get traffic from outside to your containers. Instead, it relies on a gateway like Istio or others that you need to install yourself and configure yourself. And then once you have Kubernetes and Istio installed, you can install the Knative components. There's two components of Knative. One is Knative serving, the other one is Knative eventing. I'm going to show you serving, but our focus will be more on the eventing side. And then at that point, you can use Knative if you want. But as I mentioned, if you're in a cloud provider like Google Cloud, you might want to look into Cloud Run or Cloud Run on Anthos. And other cloud providers, they have their own implementations as well. So you might want to check what else is built on top of Knative to use that instead, because it will be easier. Now, let's look at the first part of Knative, Knative serving, so that we understand what that does, and then we'll get into eventing. Knative serving, in a nutshell, it tries to give you a way to deploy containers so that it acts like a serverless framework. And what I mean by that is that, normally when you want to deploy a container on Kubernetes, you need to create a pod. Then you need to create a deployment, Kubernetes deployment. Then you need to create a Kubernetes service to expose that deployment to the outside world. Then if you are using Istio for traffic management, you need to create a gateway to enable the port. Then you need to create a virtual service to connect the gateway to your Kubernetes service. So there's a lot of things that you need to do to get a container up and running. And then you also need to worry about scaling the container up and down, stuff like that. So it's not that easy. Whereas in Knative serving, what you do is you create a Knative service and you point to your container and you say, okay, this is my container, it's deployed on Docker Hub or Google Container Registry. And then Knative serving takes care of the rest. It deploys your container in a pod, but you don't need to define the pod. So it does that for you automatically. Then it configures the traffic so that the traffic goes to your pod. Then it sets up automatic scaling. So your pod automatically scales down to 0 after 60 seconds, and then it will scale up to n that you define. Then on top of that, you get configuration and revision management. So every time you deploy your container, you get new revision, and with that new revision, you can, if you have multiple revisions, you can do traffic splitting, or you can roll back to a previous revision. So in a nutshell, it gives you a much easier way of deploying a container, getting that container auto-scaled, getting the container traffic managed, getting its traffic managed, and then you also have a really easy way of getting some kind of revisions and traffic splitting with those revisions. Now, the Knative serving terminology is basically you need to know four things with Knative serving. At the top level, you have Knative service. This is separate from Kubernetes service, by the way. It's a higher level API, and it's a Knative service, and I'm going to show you some examples of that. So the service will have a configuration where you point to your container and other things like environment variables. Then you deploy your service and configuration, and that creates a revision, which is a snapshot of your current service and configuration. And then Knative also creates a route for you that points to that revision. So by default, the route goes to the latest revision. But then once you deploy multiple revisions, you can change this route to do traffic splitting, right? So Knative service at the top layer that has a configuration. With that, you get a revision, and then you have the route to point to that revision, and then you can do complicated routing if you want by changing the route definition. So let's actually look at some examples of this so that you know what I'm talking about. First of all, I want to point out that I have a GitHub tutorial called Knative tutorial, where I have this presentation, and I also show you how to install Knative. And then I have a lot of samples on Knative serving, Knative eventing, and also Tecton pipelines. So feel free to check it out. So I'm just going to show you some examples from this tutorial, but if you want to come back, this is the link for it. I already created a Knative cluster. So as you can see, I installed a Google Kubernetes cluster. I deployed Istio on top of that, and then I installed Knative 0.16, which is almost the latest version of Knative as of today. And I already configured it. So let's just double check that actually our Knative components are running. So if I go to my console, if I do kubectl get pods, and Knative gets installed into separate namespaces. So if I do Knative serving, these will be the pods for Knative serving. As you can see, they're they're running. And let's also make sure that Knative eventing pods are running as well. Yeah, so everything is up and running, so we're ready to deploy our first Knative service. Now, in this first service, what I want to do is I want to write a service where when it receives a message, it will just say, hello world with that message. So it's something very simple. Just to show you the code briefly, and this is, as I mentioned, this is all on GitHub. I have the code in C#, but you can write it in any language you want. So in this C# code, I am handling the GET request. When the GET request comes in, I look at an environment variable called target. If it's there, then I'll just say hello target. Otherwise, I will just say hello world. So the code is very simple. I create a Docker file for my container, and I built and push my image already. And then for the service definition, we create service v1. So this is the first definition of my service. And in this definition, you can see that we are using Knative service, Knative API. So this is a Knative service. The kind is a service. The name is hello world. And then it will be deployed into the default namespace, but you can choose other namespaces if you want. And this is a definition. This is a configuration of my service. In this configuration, I am pointing to my Docker image that I pushed before the talk. And then I'm passing in the environment variable target v1, right? This is all I'm doing here. So let's deploy this and see what happens. But before we deploy, let me also watch something. So I'm watching Kubernetes pods, Knative service, Knative configuration, Knative revision, and Knative route. So all the things that I talked about, I'm watching. Right now, there's nothing right now. But now let's deploy the first service. So I'll just say kubectl apply service. Oh, sorry. Service v1. Now we are deploying the first version of the service. You can see that right away, Knative realizes that the service is deployed. So I have my service created. I have my configuration that's been created. A pod has been created and it's running, so I don't have to create the pod myself. The revision is being created. This is the first revision of my service. And then we also have a route that was set up to point to a revision. And Knative comes with a dummy nip.io domain that I set up, so that I don't have to set up a fully configured domain. But now if I do a curl to that URL, you will see that it says hello v1, right? So our service is deployed, which is really easy. Now, if I want to do an update to the service, let's look at the second version of the service. In here, I am doing the same definition. I am using the same container, but I'm changing the environment variable from version 1 to version 2. So I'm doing a configuration change. So that's a change in the service. And then in the third version of this service, I'm doing something else. So I am changing the image from version 1 to version 2, version 3. So in this image, I'm changing my message from hello to bye. So I'm doing a code change. And then I'm also changing the environment variable from version 1 to version 3 as well. So I'm doing a couple of changes here. So let's imagine we do these changes and let's see what happens. So let's first apply the service v2. So this is the configuration change. And you can see that Knative immediately realized that this is a new configuration, and it created a new revision for it, and then it created a new pod for it as well, and that pod is running. You also realize that the previous pod is terminating because we haven't used the version 1 for 60 seconds, so it's scaling down, right? That auto-scaling is already set up for me. Now, if I do a curl again to the same URL, you can see that I see hello v2. So we did a configuration change. Now, in the version 3, let's deploy that as well. Remember, we did in version 3, we did more. We did a code change. We use a new container, but we also did a configuration change because we passed in version 3 as well. Now, in this case, again, the revision is updated to revision 3. We have a new pod running, and if you do a curl again, now it says by v3. So we did a configuration and code change as well, and we just deployed our new code. So you can see how easy it is to deploy new versions and get traffic sent to those revisions, things like that. As I mentioned, you can do traffic splitting and things like that in Knative. So let's look at an example of how to do that. First, what I want to show you is that you can give your revisions a predictable name. So for example, in here, you can see that our revisions, they have random names, like it's always hello world, but the name itself is dash something random. But you can actually change that. So if you go to your service definition, and then you just pass in this, let metadata name, you can name this revision. So right now I'm saying I want to name this revision version 1, and I'm going back to version 1 on my service. And then I'm also adding a traffic rule here, so I can change the traffic as well. So what I'm saying here is that I want this traffic rule where, you know, the current traffic will go to this revision that I just defined here, and it will be the 100% of the traffic. So all the traffic will go to this revision. And then I'm also defining that anything else will get no traffic. So if I deploy some other revision, it won't get any traffic. That's what I'm defining here. Now let's deploy this. So I'm deploying back service 1, but it's with a name. So the difference in this case, you can see that we deployed it, and then now we have a predictable name for our service. This is the version 1. And then if I do a curl again, you will see that now the pod is being created because we scaled down, but now we are still going to version 3. But if I do another one, we are back to version 1. So we are back to version 1 with a predictable name. Now let's deploy a version 4. Now in the version 4, I am deploying the same container, but I'm passing the target version 4, and I'm keeping the traffic rules the same. So the traffic still goes to version 1. So what I'm going to do is I'm going to deploy version 4, but it won't get any traffic. So I'm doing a silent deploy actually. So let's do that and see how that works. So let's do version 4. And now we can see that I have the revision 4, version 4 that's been created. It also has a predictable name, and the version 4 pod is also being created. But if I do a curl to the same URL, it still says version 1 because we specify that version 4 should not get any traffic, right? So that's the difference here, is that version 1 is deployed, version 4 is deployed, but version 1 is the one getting the traffic. Now if I go to this URL and then change this URL and add this latest dash at the beginning, now you can get to version 4. It says hello v4. So I did a silent deploy. I can test that silent deploy by going to a special URL, and once I'm happy that this version works, I can upgrade my traffic rules and let it get traffic. So imagine, let's say, you want this to get 50% of the traffic, then all you need to do is you can go to your service and then just change the traffic rules of your service and say, okay, I want version 1 on my traffic to get 50%, and I want version 4 to get the other 50%. And anything else after that, let's say we have a version 5, it won't get any traffic, right? So that's what we are trying to do here. Let's do this as well before we wrap up the Knative serving. So I'm going to do version 1, version 4 split. So now we are not creating anything new here, so there's no new revision. All we are doing is that we are updating the route, right, to do traffic splitting. Now if I do a curl again, it says hello v4, add a curl. Now it's scaling version 1 up, and it says hello v1. So it will roughly be version 1 and version 4. So this is Knative serving. As I mentioned, it gives you a very easy way of deploying containers and kind of configuring traffic to those containers. And once I'm done, I can just say kubectl delete Knative service, and let's say hello world. And now the hello world service will be created, and everything about the service will be deleted as well. All right, so that's Knative serving. Now, the second part I want to mention is Knative eventing. And Knative eventing, all it tries to do is it tries to connect certain event sources to event consumers with certain delivery methods in the middle. So it tries to kind of connect different kinds of event sources to different kinds of event consumers with some kind of control in the middle that you can define how those events will flow in your system. These event consumers, they are usually Knative services, but they can be Kubernetes services as well. And the event sources and the event types, there's a lot of different choices here that we'll go through as well. And you also have a lot of choice on how those events get delivered to your services. Now, the terminology of Knative eventing is that, first of all, you have cloud events. So this is the format of the events that we'll talk about. Then you have event sources. So who's actually creating the event, or where are we pulling events from? These are the event sources. Then once the events get into your cluster, they go to somewhere called broker, which is, it's a place that gets the events within your namespace. And then from the broker, you want to send the messages to your services, but you define that through what's called triggers. And then finally, you have services receiving these messages, Knative or Kubernetes services. We'll go through these one by one and look at them in more detail. Finally, there's also channels and subscriptions, but we don't really need to worry about this too much. There are things that are created under the covers, but once in a while you might need to look at them, so that's why I will mention them briefly here. Now, first of all, as I mentioned, the format of the events is cloud events. And cloud events, it's an open source eventing format from CNCF, so you can check it out in more detail at cloudevents.io. And these cloud events, they basically define a kind of high-level event definition, right? For example, when you look at cloud event here, it has a spec version, which is the version of cloud event. 1.0 is the version. Then the event type and the event source. These are the things that you need in any kind of eventing system. Then you have the typical things like the ID and the time of the event. And finally, the data of the event is the thing that holds the actual payload. So for example, in here, we are listening FTP, GitHub, Google Cloud Storage kind of events. They all come in, they all get converted into cloud events, and the data field will have the actual event that you're interested in. And then when the broker gets the event, it will get it in that format, right? And I should also mention that Cloud Events has SDKs to actually read and write events. So if you want to use them, you would start with the SDKs. And Google Cloud also has libraries to parse this data field, right? So if you're reading, say, Google Cloud Storage event, you would use this Google Events libraries to parse that event as well. So that's the format of the events, but what kind of events we can listen? Well, basically there's a lot of different kinds of events. So you can listen AWS events, you can listen Google Cloud PubSub events, Google Cloud Storage events. This is not the full list. You can check this link for the full list, but there's a lot of different event sources that you can install and list and pull messages in to your cluster. You can also write your own event sources. So if you have something custom that you want to read from, you can write your own custom event source. Now, once the event gets into your cluster by the event source, it gets to a broker. A broker, it sits in the namespace. For example, in this case, we have a broker in the default namespace. It has a default URL within the cluster. So people within the cluster, not people in the services within the cluster, they can send messages to this broker, and the broker will distribute those messages if you want. Or you can configure event sources to read the events and pass it to the broker. So it's a way to kind of get events into your namespace, and then from that namespace, you're going to distribute them to different services. And by the way, usually the broker is injected into your namespace. So you label your namespace with this label, namespace injected. And then that will kind of inject the broker into your namespace. Now, once you have the messages in the namespace, you create a trigger, and trigger defines what kind of events go to what kind of services. For example, in this case, we are defining a trigger, and then we are filtering on these messages, and the message type is Google Cloud Storage Object Finalize. So these are Google Cloud Storage events. And then the subscriber, it's a service, it's a Knative service. That's called filter. So all the messages from Google Cloud Storage will go to a Knative service called filter. So that's the kind of things that you can do with the filter. And then finally, you have to define a service to receive the message. This is typically a Knative service, like I am doing here. But then if you change the API version from Knative API to Kubernetes API, it can be a Kubernetes service as well. It will just receive the event, and it will either consume the event, or it can also consume and reply to the event. And that reply will go to the broker, and the broker will kind of send it to other people with the other triggers for that message. And as I mentioned, channel is something that you don't necessarily define or change every day, but it's something that you need to think at the beginning of your eventing pipeline. Channel is the persistence layer. So as services go through your system, how do they get persisted or not? That's what channel defines. For example, in my demos, I'm using in-memory channel, meaning everything is in memory. So if something goes wrong somewhere, like if my broker goes down or if my service goes down, I'm going to lose the messages. But it doesn't matter to me because it's a demo. But in production, you probably want something more durable. So there are things like Kafka channel, there's Google Cloud PubSub channel. These channels you configure, and then you set them as default channel to your broker, so that by default broker uses these channels instead of the default in-memory channel. And then there's subscriptions. These are kind of things that get created under the covers. So when you create a channel, and then when you have services connected to that channel, then behind the scenes there's subscriptions that's been created. Triggers also, they create subscriptions behind the scenes. You don't necessarily have to worry about this so much unless you're using old way of sending messages. And I'm going to mention this as we go along on how we deliver messages, but it's not something you typically need to worry about too much. All right, so we defined the building blocks of Knative eventing. Now let's look at how you can actually send messages through your system and what kind of methods you have for that. There's actually a few different ways, and I kind of grouped them in different headers. First is the simple way of sending messages. Second is the complex way with an optional reply. And the last one is broker trigger delivery. Usually, broker trigger delivery is the one that you should care about. The rest of them, they don't really have anything more than broker trigger delivery provides. But I want to mention them as well because they might be useful in certain use cases. But typically, you would just inject a broker and create triggers from it, and that should be enough for most use cases. But let's go through them anyway, just to take a look. Now, in simple delivery, you basically have an event source, and then you will have a service, let's say a Knative service, and you just connect them together, right? It's the simplest way of sending a message from source to sink, in this case, a service. This is simple, meaning there's not much to worry about, but at the same time, it's very limited. First of all, you can only do one-to-one, so you can have one source to one service. And secondly, there's no way to do to change the event the event persistence, right? Because here, if the source goes down or if the service goes down, this message goes down. There's nothing in the middle that will kind of persist the message for you, right? So it's for very simple use cases where you don't really care about what happens to the message and you just want to connect source to service right away. It's for that. It can be useful, but the use cases are very, very limited for simple delivery. Now, if you want to do one-to-many, then you need to start thinking about channels. So in this case, you have a source and you have a couple of services that wants to receive that message. Now, instead of connecting source to the service directly, what you need to do is you need to create a channel. This can be an in-memory channel or Kafka channel or whatever kind of channel you want. And then from that channel, you need to create subscriptions for each service. And then when a message comes in, it will be fanned out to multiple services. This is more complicated in the sense that you need to create these channels and subscriptions manually yourself. But it gives you more things, like it gives you fan out, first of all, so you can fan out messages, but it also gives you a way to persist messages at the channel if that's what you want. Now, these services, they can also reply back to messages. So in this case, for example, we have source sending messages to a couple of services, and then service 2 replies back with the message, right? So when it receives a message, it will reply back. Then you can route that message to the subscription, then it goes to the subscription, and then from then you can route it to another channel, and then that channel can go to another service, right? So, this is more complicated, but it allows you to do more complicated architectures this way, which is good. But at the same time, it's also kind of getting hard to set things up, right? So here, for example, we have 3 services, and we need to create 2 channels, and we need to create 3 subscriptions, and we need to make sure that everything is hooked up correctly. So it can easily get out of hand if you have, like, say, tens of services. It can be easily, like, you can easily kind of get confused between different channels and subscriptions and things like that. So that's why we have this thing called broker trigger delivery. And this is the latest way of setting up messaging in Knative, and it's the one that I recommend. Now, in this model, what you do is that you have your source, and then you inject a broker into your namespace, and by default, source sends messages to your broker. And then from the broker, you create triggers. So each service kind of specifies what kind of messages I'm interested in from the broker. So service 1 and service 2 will say, I'm interested in this kind of messages. And then each service can reply to the message. So in this case, service 2 is replying to the message. But then because of these triggers, they filter these messages. So when this service 2 replies to this message, it doesn't go to service 1 because service 1 will only get this kind of messages. Then service 3 will get the red messages because that's the type of trigger it has. So when you look at this, actually, it's the same use case. So what we are doing here and what we're doing here is the same thing. But here it's much easier to set up because all you need to do is inject the broker. So you do that once in the namespace, and then you just create triggers with the broker. So this is a much easier way of kind of setting up eventing in Knative eventing. All right. And then what I want to mention, well, first of all, I need to mention that I have, if I go to my Knative tutorial, I have examples of this simple delivery, complex delivery reply, and broker triggered delivery as well. So all of these, you can run examples of them as well if you want. But I'm going to show you a more complicated example shortly. So because of that, I don't want to show these examples right now. So let's just talk about one more thing, and then we'll look at a more real-world example of how to set things up. Now, as I mentioned, Google Cloud has different kinds of event sources to read Google Cloud sources into Knative. These are all defined in a project called Knative GCP project. And in this project, there's a number of event sources. There's, for example, Google Cloud PubSub source. That's for reading PubSub messages into Knative cluster. There's Google Cloud Storage source to read Google Cloud Storage events into your cluster. There's Scheduler source to kind of create Google Cloud schedules that run on a certain schedule and call certain services. So you can set that up with Google Cloud Scheduler source. So these are very useful, basically, if you're in Google Cloud and if you want to read Google Cloud sources, you can install them and then they let you read these events in an easier way. And that's what I'm going to use in my demo that I'm going to show you. Now, this demo that I want to show you, it's a BigQuery processing pipeline. And what I wanted to do is that, I'm based in London, and we started having lockdown in mid-March. We all started working from home. And at the time, COVID was a new thing, so I was checking the number of cases in London every day, at 4 or 5 p.m. I would check out and see what were the numbers for the day. So after like a week or two, I thought to myself, instead of me checking these cases by myself, why don't I build a pipeline that would check these numbers for me, and then it would send me an email every day at a certain time with the latest numbers, and maybe it will send me a chart as well. So I basically wanted an easy way to see the numbers for every day without me having to check for it. So that's when I started building this pipeline. So the way I built this pipeline is kind of like this. First, I said to myself, okay, how can I get this data? Where can I get this data? And in Google Cloud, there's something called BigQuery. BigQuery is a data warehousing solution. And the good thing about BigQuery is that it comes with lots of public data sets. And one of those, not one, but a few of those data sets is related to COVID. So what I did is first I built a service called Query Runner. This is a Knative service that will go to BigQuery and it will ask BigQuery using the COVID data set, what are the number of cases for this country in the last month or so, right? So it will query that, it will get that data, and it will save it to a temporary table. You can create temporary tables in BigQuery, so I will ask to BigQuery and save it to a temporary table. So that was my service number one, but I wanted this service to be triggered on a schedule, so I used Google Cloud Scheduler to trigger that service once a day at 4 p.m. for United Kingdom, for example. Now, once I make this query and save it to a table, I send a custom event. So I reply back to broker and say, okay, I run a query So I just reply back with a custom event that goes to another service called chart creator. It's a Python service that will read this table and it will create a chart from it using matplotlib library, right? So it will read this table, create a chart, and it will save it to a Google Cloud Storage bucket. And then I set this bucket so that when an image is saved here, a chart is saved here, it will call another service called notifier, which is another Python service that will use SendGrid to send me an email. And it will say, okay, there's a new chart created in the storage. Here's the link to go and take a look, right? So the good thing here is that it's event-driven. So the scheduler triggers the event, and then that triggers the whole chain. But none of these services, they know each other. The query runner just runs the query, then sends a reply back to sends a message back to broker, and then that goes to chart creator. All it does is, it kind of just reads the table and creates the chart, so it doesn't know that there's a query runner. Similarly, notifier, all it cares is that there's a new chart in the bucket, so it gets a notification of that. So the whole thing is loosely coupled, event-driven, and in the end, I get an email at the end of the day. So let's actually look at this in detail. So first, let me show you the code, not the code, but the configuration at least. And the code is on GitHub, by the way. So if you look at BigQuery, first what I need to do is I need to create scheduler sources. So in Knative, there's, as I mentioned, in Knative GCP project, there's different sources. So in this one, I'm saying I'm going to use Cloud Scheduler source, and it will be triggered every day at 4 p.m. and it will send a message to the broker with this data, and the data is United Kingdom. And my broker will pass this to my query runner, and query runner will get this United Kingdom data, and it will say, okay, I'll ask BigQuery what's the numbers for United Kingdom is. So that's my scheduler source. Then the storage source is my charts. Once I save my charts, after the chart creator saves the charts, it will send a message to the broker, and the broker will get the notification that there's a new chart in this bucket, right? So these are a couple of my sources. If you look at the query runner, I mean the code itself, we don't have time to go through it, but basically it gets the cloud event. So this is the event reader that I created. It gets the cloud event, then it extracts the country from it. Then it runs a BigQuery job, and then once it does that, it sends a message back to the broker that I ran this job, and there's a new table. But the interesting thing is to look at the Knative service. So the Knative service is the query runner that just points to the query runner container, and the trigger, it triggers on filtering on job scheduler. So it only looks for cloud scheduler events. So only triggers on the cloud scheduler events, right? So that's query runner. Then after that, it goes to chart creator. And chart creator, we don't have to look at the Python code, but if you look at the trigger, the chart creator will only look at the query completed custom message, right? So this is a custom message that the query runner will emit, and then it will go to this chart creator. And then similarly, notifier will only trigger on object finalize. So whenever there's a storage bucket update, it basically will emit this storage object finalize event, and this is what the notifier will get, right? So let's actually set this up and see if it works. So let me get out of here and go to eventing, processing pipelines, BigQuery. Now, I think I can get rid of this. Okay, so let's make this a little bit bigger. All right, so let's first create the scheduler source UK. So this creates the cloud scheduler source for UK. And then let's also create the storage source so that when we save the charts, we get those events as well. And then we will get into query runner, and then we'll create the Knative service and then the Knative trigger for that. And then let's do the same for chart creator. And then let's do the same for notifier. All right. So if everything goes well, we can look at our services. So you can see that we have 3 services that's been created. And then we can look at the triggers that's been created. And the triggers, they are being initialized. They will talk to the default broker. And I already have a broker injected into my namespace. So the default broker is there. And let's also look at Cloud Scheduler source. So this is the thing that will trigger the events. And then Cloud Storage source is the thing that will trigger storage events. So everything seems to be set up. Now we can wait till 4 p.m. for it to be triggered, but we can also manually trigger this event. So if I do gcloud scheduler jobs list, we can see that there's a job that's been created that will trigger at 4 p.m. But let's actually trigger this ourselves. So if I do jobs run and then pass in the ID, this should trigger the job now. And then now the whole event chain is being initialized. So if everything goes well, this will go to the query runner. Query runner will actually run the query. And if you actually look at the logs, you can see that we have the services running. So let's just take a look at the logs of query runner. Oh, sorry. Yeah, the query run is actually terminating because they scaled down, right? So if I look at pods again, you can see that they scaled down. So I couldn't see the logs, but I think the whole thing ran. So if I look at my email, you can see that I got an email, a new chart from BigQuery Pipeline, and if I open it, I have a link to a chart. A new chart is available. Let's just take a look. You can see that I can see the COVID cases in United Kingdom. That I get the chart, from the beginning of March till today. So that's it. Hopefully this was useful to you. As I mentioned, the presentation is already on speaker deck, so feel free to get it there. My Knative tutorial on GitHub, it has many more samples than I showed you today. Hopefully the samples that I showed you was useful and you have an idea on how Knative works. Also, as I mentioned, Knative, if you want to run Knative on Google Cloud, you probably want to use Cloud Run. And I also have a Cloud Run tutorial on GitHub for that as well. So feel free to check it out. Thanks for listening. And if you have any questions, feel free to reach out to me on Twitter. I'll be happy to answer. Thanks very much.
Thank you very much, Matt. It was really very interesting and useful speech. Matt, you and our participants, I invite you to our Zoom room to discuss all interested in questions. And now...
Great, I'll be in the Zoom, thanks.
Yes. Please join us. And now next we'll have a small presentation from our gold partner, it's Sweetless System.
Okay, welcome back, and I'm glad again to introduce our gold partner, Svitla Systems company, and the representative, Natalia, who will give the short presentation about the Svitla Systems.
Hi everybody, my name is Natalia and I'm talent hunter at Svitla Systems. Let me tell you more about us. Svitla Systems is a multinational software company. Our head office is located in California and business and development offices around the US, Mexico and Europe, Poland and Ukraine. We have 600 plus developers and provide a wide range of development services for such well-known companies as Ingenico, Ancestry, Thermo Fisher, AstraZeneca, and others. What I love most about Svitla is the freedom to choose your work location. And thanks to schedule flexibility, you get more time for your hobbies, family, and less time commuting. And what is also very important, no micromanagement. Moreover, there is no bureaucracy. Any question is solved quickly and easily. We care about your comfort. We do everything we can to help you focus on your work and your personal life. We truly appreciate our developers' work-life balance. We enjoy some vacation days, national holidays, days off, sport activities, family days, and splendid birthday presents. We care about your education. Svitla constantly organizes in-house and public tech webinars named Svitla Smart Talk. You can visit our Facebook page to see the schedule. Also, Svitla covers tickets for others' IT events and courses. Svitla is well known not only for its family-like attitude, but also for a big number of most innovative projects. I'm going to show you several projects we are especially proud of. For some of them, we are hiring now. The first one is a leading traveling platform. Each month, it helps over 400 million developers to make their trips across the globe. The app is available in 30 languages and works across 50 countries. Yes, leading team collaboration platform like Skype and Zoom, it helps enterprise users stay connected. It is used by thousands of companies and sends over 500 million messages daily. Multinational US technology company focuses on e-commerce, cloud computing, digital streaming, and artificial intelligence. Next one, a biotechnology leader, American provisioner of scientific software and services to healthcare, life science, and biotechnology. Safety observations solution, trained to recognize construction risks in photos and other projects' data. It creates an automated risk assessment. Global leader in robotics, enables self-driving robots development, deployment, and operations. Works in 40 plus countries, serving the mining, military, aerospace markets, and agriculture. Of course, we have more projects to tell you about, and we will be happy to do it personally. You're welcome to learn more about us on our career page on svitla.com. And now for more exciting part, our prizes raffle. Take a chance to win our awesome backpacks, AirPods, thermocups, and t-shirts, and more. Go to the Devoxx website to see Svitla systems page. You will find two options. First, simple fill-in form, and second, advanced Java quest. If you wanna challenge yourself and solve our tricky tasks. Again, links to raffles at Svitla systems page at Devoxx website. Thanks for your attention. I hope to see you at Svitla. Take care. Bye.
Thank you. Thank you, Natalia. Very exciting projects you're working with.
Yes.
And yeah, guys, very exciting prizes, new airports. So just solve the Java quest from Svitla Systems and take your chance to win. Thank you.
Thank you.
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
Hi guys, I'm back, and if you're ready for the next speech, I'm happy to invite our next speaker. It's Grace Janssen. Hi Grace, thank you for joining IPAM Ukraine. Devoxx
Hi,
Ukraine.
thank you so much for inviting me here.
Nice to see you. What topic have you prepared for us today?
So we're going to be taking a deep dive into sort of reactive systems and event-driven architecture and where they fit together.
Sounds great. Okay, it's your time to shine. The mic is yours.
Great, thank you so much. So thanks again for inviting me here to Devoxx Ukraine. It is my first time presenting sort of, I guess, virtually, but in the Ukraine. So lovely to meet sort of a new developer audience. And as I've said before, we're going to be taking a deep dive into sort of reactive architecture, reactive systems, and event-driven architecture. So my name is Grace Janssen. I'm a developer advocate at IBM in the UK. And if you want to reach out to me during this talk, after this talk, my Twitter handle is up on the right-hand side there. So it's at GraceJanssen27. Feel free to follow me, tweet me, whatever you want to do on Twitter. So without further ado, let's get started. So as every great demo seems to start with, we're going to start with a coffee demo because everyone seems to like coffee, although ironically I don't. But anyway, coffee demo time. So let's take a look at a coffee demo where we've got some coffee lovers sort of representing microservices, and they're going to pass in coffee orders to a coffee shop microservice via HTTP. Then that coffee shop is going to pass those orders to a barista microservice to make those coffees, so to process those orders, again via HTTP. This is kind of a classic example of using a fairly synchronous, fairly blocking form of communication, and sort of was what we used to do back when we first started sort of creating applications like this. And if you only have a couple of coffee lovers, this might be absolutely fine. But what happens when you start getting lots and lots and lots of requests, lots of coffee orders coming through your system, and you've got a large amount of data that you're having to pass through everywhere and get processed? So if you want to take a look at this example, it is on GitHub. It was made by our cousins over at Red Hat, and you can check it out at the link at the top of this slide. But essentially, how do we take this sort of more traditional form of architecture and improve it for large amounts of data, large amounts of requests, and sort of our really event-driven world that we're currently in? Well, that's where we introduce event-driven architecture. So event-driven architecture, if you haven't come across it, it's a really popular architectural approach that enables events to be placed really right at the heart of our system. So we've got a basic diagram here. Events here, what we're referring to is really a state change in the system. And so what happens is those events are stored on this event-driven messaging backbone. So you can see here we've got microservices that are publishing to that backbone, and we've got microservices that are consuming from that backbone. And some of those microservices here in this diagram, once they've consumed, are also doing some sort of processing and then publishing their own events to that backbone. So it really places events at the heart of the system and enables us to sort of loosely couple these microservices with their exchange of information. So let's see what happens when we introduce sort of this event-driven architecture form into our example. And actually, this second example, the second version of the same application, is also available in that GitHub repo if you want to take a look at the comparison between the two. So now that we've introduced this event-driven, this event backbone into our application, you can see here that we're still passing orders into the coffee shop via HTTP, but now once those coffee orders are in the coffee shop, they get added to an event backbone. So they get added to that topic or that queue. And then once they're in that event backbone, the barista can then pull or consume from that backbone whenever they're ready to create the next coffee order. And once they've created that coffee order, they can then update the board. So in the original example, our coffee lovers were having to sort of, if you can imagine, wait at the till for each of their coffee orders to be processed. So it's a fairly blocking process because the coffee lovers had to wait to get a response from the barista and had to wait to get their coffee. And they could only order really one at a time. Whereas now our coffee lovers can place their orders, and instead of having to wait at the till for each of their coffees to be produced, they can go and sit down, have a chat, talk about Java, as we all love to do, and then they can wait until the board's updated to tell them to go and collect their coffee. So it's a much more asynchronous process. So you can see here how we're trying to add in some of that asynchronicity and non-blocking behavior, and how event-driven architecture can help us to do that. And often when we're introducing event backbones, one of the most commonly and most popular tools that we can implement is Apache Kafka. So if you've not come across Apache Kafka before, it's an open source distributed streaming platform. And it's sort of different from traditional messaging systems in that it has this stream history. So it has this immutable data that you can go back and read again if you want to or if you need to. It enables scalable consumption, it's very scalable in itself, and it really enables that high availability of information that we're looking for when we're building systems. So now that we've added in this event-driven backbone to our barista example, it often leads to questions like this. So is my coffee shop now non-blocking and highly responsive? In other words, is my microservice system non-blocking and highly responsive? And people often assume the answer is yes, because we're now using this fabulous tool called Kafka. Unfortunately, that's not the whole story. What we actually need to be considering is every aspect of our application and how the different components of our application interact together to make sure the entire application from end to end, or the entire microservice system, is non-blocking and highly responsive. And this is where reactive systems comes into play. So reactive systems, what do I mean by that? What does that term really sort of signify? So the reactive systems is sort of an overarching concept for describing systems that sort of follow these behaviors and characteristics that are laid out in the reactive manifesto. So here's the reactive manifesto, and it's based off 4 key characteristics, or cornerstones they're often referred to. So the underlying characteristic that we need to see when we're trying to build really responsive, really reactive, non-blocking applications is this message-driven sort of asynchronous backbone within it. Now, interestingly here, it's message-driven and not event-driven. So I mentioned event-driven architecture, and often when it comes to Kafka, there can be various assumptions that Kafka is designed for event-driven architecture only. Interestingly enough, in the original Reactive Manifesto, so Reactive Manifesto 1.0, they were using the term event-driven, but they switched to message-driven in Reactive Manifesto 2.0, which was produced in 2014. And if you want to learn more about why they made this switch, there's an entire blog article you can check out online where they do describe why they made this transition. Let's take a look at what the difference really is, though. So on the left-hand side here, we've sort of come up with a definition of what a message is. So a message is an item of data sent to a specific location. And on the right-hand side, we have a definition for events. So an event is a signal emitted by a component upon reaching a given state. So really, it's that differentiation between sort of just emitting that signal and letting subscribers subscribe to it if they want to know, versus sending it to that specific location. So that's the main difference between those two. But if you think about it, interestingly, you can actually have a message that can contain an encoded event in its payload. So you can have this sort of weird mesh of both. But really, what matters is when it comes to Kafka, it doesn't matter whether you're doing message-driven or event-driven. When you look at the Apache Kafka website, they don't mention events or messages at all. In fact, they refer to records. So you can see here on the right-hand side, they refer to publishing and subscribing streams of records, storing records in a durable way, or processing streams of records as they occur. So actually, with Apache Kafka, you can design a system that's either message-driven or event-driven, or maybe even a mix of both. So Apache Kafka is a fantastic tool that we can utilize to introduce this asynchronous message-driven backbone that really allows us to decouple the components of our application and achieve some of those other reactive behaviors defined in the Reactive Manifesto. So let's take a look at our original barista example, and let's look at why you can't just add an event backbone in or a tool like Apache Kafka and expect it to be highly sort of non-blocking and responsive and reactive all the way through. So we're going to take a look at a couple of problems that we might come across and why the other behaviors that are defined in the manifesto really matter when we're designing reactive systems. So in our example, we only had 3 coffee lovers at first, but there are not only 3 coffee lovers in the world, there are many, many more. So what happens when we suddenly have an influx of coffee lovers trying to place coffee orders at our coffee shop? Well, more coffee lovers obviously means more coffee orders. So we've now got our event backbone, and that means that we can add these orders to the queue. So although our coffee lovers aren't having to necessarily wait at the till for this synchronous process, they're able to sit down and asynchronously wait for their coffee to be served, we still have a blocking component in our application, and that's that barista microservice. So we only have one barista trying to process and produce these coffee orders. So that barista can only work so fast. So we're going to be restricted by the speed at which that barista can produce these coffee orders. So we're going to have a fairly slow coffee order process because that barista can only work so fast, and our coffee lovers aren't going to get the best experience they possibly could because we've got that blocking and that sort of bottleneck within our system. So instead, what we need to be implementing is this elastic behavior. So really enabling our system and the resources within our system to both scale up and scale down depending on the fluctuating load to our system. So elasticity and building in elastic behavior into our application can help us to gracefully deal with these load changes over time and also keep our application as cost effective as possible by not only scaling up, but also scaling down when necessary. So let's take a look at our barista application again. So in this case, if we were able to scale up the number of barista microservices or perhaps the replicas of that particular microservice, we'd be able to get through those coffee orders much quicker because now we've got more baristas processing those orders. So in this regard, by elastically scaling our application, due to that fluctuating load, that increased load of more coffee lovers and more coffee orders, we're able to provide a much more responsive, reactive, non-blocking system. So that's why elasticity is really important. Let's take a look at another potential problem we could come across. So we've got an additional component to our application, and that additional component in this case is a serving table. So essentially this serving table is where the barista has to place the coffees before the coffee lovers can come and collect them. Now this serving table is essentially representative of a downstream component. And that downstream component could be an additional microservice that needs to do some additional processing. It could be a third-party application. It could be a third-party database. So it's representative of something downstream that we need to be passing those orders to, or that data, or those messages to. So what happens in the potential failure point of, okay, our coffee lovers are being a little bit lazy today. They're not coming to collect their coffee as soon as they should be. So now our coffee orders are building up on this table to the point where our barista is now trying to juggle coffee because they can't put it down on the serving table. So now our serving table's blocked, our barista's blocked, and we can't produce any more coffee orders. So this is a potential blocking point and a potential point of contention in our system that could potentially cause failure and an unresponsive system or an unresponsive coffee shop. So this is where we need to introduce resiliency. So resiliency is all about building in resilient behaviors into our application so that we can gracefully handle any potential failure to our system. As software developers, as hard as we might try, it is virtually impossible for us to predict every potential failure we might come across with our system. So it's really important that we build in natural resiliency within our application in the face of those potential failures. So with the barista example, we could potentially have provided some sort of feedback mechanism from those downstream components, maybe the barista or the serving table, to the upstream components to let them know to limit the rate of requests coming through, or to maybe spin up some more replica microservices or replica serving tables or replica baristas to help us deal with that potential bottleneck or potential point of failure. So resiliency is a really important behavior when it comes to creating really non-blocking reactive applications. Because if parts of your application goes down, you're naturally not going to have a reactive or responsive application. So we need to be resilient. Now, these three characteristics all lead to the last characteristic of the Reactive Manifesto, and that's responsiveness. And when we say responsiveness, what we're meaning is to be as responsive as possible to events or to state changes within our system. So really being responsive to those sort of changes, be it maybe a input or data from a sensor, be it a click on a website, any form of state change, we need to be as responsive as possible. And by implementing these four behaviors, we can really achieve non-blocking reactive behavior end-to-end throughout our application and throughout our system. So I've mentioned these sort of very high-level behaviors that we need to be implementing and thinking about. But how do we actually go about building these in and building reactive systems? So here you have sort of a fairly basic application. It's only 3 microservices big, but it's just to demonstrate the various levels and layers that we need to be thinking about. So we already mentioned Kafka and how providing sort of this event-driven or message-driven backbone can be particularly helpful in terms of enabling us to have decoupling and really reactive behaviors at the data level. But our applications aren't just made of data. They're made of microservices, they're made of various different components. So we also need to consider the behavior between those components and within those components. So when it comes to the interaction and the behavior between those components, we need to make sure that our components are interacting together in a non-blocking and reactive manner. And to do that, we can introduce these concepts called reactive architecture patterns. Now, I've got some examples here of sort of what constitutes a reactive architecture design pattern, and these are some of the 4 most commonly used patterns that we've come across. There are many, many more if you wanted to take a look. We haven't gone through them all today. This isn't an exhaustive list because we'd be here all day. So if you wanted to take a look at some additional design patterns, feel free to just Google the phrase reactive architecture design patterns, and you should get lots and lots of resources that will help you sort of learn about the various other patterns you can utilize. But let's take a look at these 4. So we've got CQRS. So CQRS stands for Command Query Responsibility Segregation, and that's really all about separating out that read and that write API to enable really high availability of that data. Then we got circuit breaker. So if you've ever done sort of electrical engineering, it's a very similar concept. So with circuit breaking in software, what we're referring to here is if a downstream component is maybe stuck in a process, maybe it's gone down or it's under extreme stress or load, it can essentially the upstream components can recognize those maybe like a repeated failure message or a repeated log message, and essentially that upstream component can temporarily put a stop on the requests or the messages or the records going down to that downstream component. And it can reroute those requests to an alternative, maybe a replica microservice. And by doing that, we enable this downstream component to not become a contention point and not become a bottleneck. Instead, we give it the time it needs to recover, to come back online, maybe to get through that process it's stuck in, so that it becomes healthy again, and we can reinstantiate that route for requests to that downstream component. Then we have sagas. So Saga is sort of a mechanism to take more traditional transactions that we normally would have done in maybe a more monolithic architecture and do it in a more distributed manner. So we create these sort of multiple microtransactions that have this fallback behavior to account for things potentially going wrong partway through. So it's essentially a sequence of local transactions where each of those transaction updates data within a single service. And then we have back pressure. So back pressure is another feedback mechanism, this time from the downstream component to the upstream component. And it's essentially what I was describing that we could have utilized in that barista example. Back pressure is where the downstream component is able to feed back to the upstream component to help rate limit so that that downstream component doesn't become overloaded or overstressed and become a potential point of failure or a bottleneck or a point of contention. So these are some of the patterns you can utilize in your application, and we'll actually be coming back to back pressure specifically in some of our examples later when we look at some of the reactive frameworks we can utilize. So we've talked about sort of the interaction between our components, but what about within our components? Within our components, we also need to make sure that the programming logic is also non-blocking and highly responsive and reactive. And to do that, we can utilize reactive programming patterns. So we looked at reactive architecture patterns. Now let's take a look at reactive programming patterns. But what do I mean by reactive programming? Here's a brief definition of what reactive programming sort of is. It's essentially all about focusing on this asynchronous style of programming. So it's all about driving forward the logic forward via the availability of new information instead of by this thread of execution. So really drilling in that concept of asynchronicity into the programming within our microservices. And we can implement this by introducing various different patterns, and some of these are included here. So we have things like future. So I imagine many of you are familiar with this as it's in the Java language. So we have futures, which is a promise to hold the result of some operation until that operation completes. You can also utilize reactive programming libraries. They're really designed for composing asynchronous and event-based programs, and they're actually utilized by many of the reactive frameworks and toolkits that we'll go into later in this presentation. But essentially, some examples include RxJava and Small Mutiny. And RxJava is a really popular language. If you're not using Java, or if you're interested in other languages, you're also able to get this Rx sort of library in various different other languages like Go, Scala, Node, etc. Then we have the reactive stream specification. Now, this is really a community-driven specification that's designed as a standard to help you handle asynchronous data streams whilst also providing that all-important back pressure. And again, this specification is often utilized by many of the reactive frameworks that we're going to be taking a look at. So these are some really useful patterns to use when you're implementing asynchronicity and reactive behaviors into the programming logic within your microservices. So we've looked at how we can look at the various layers and the various levels of reactive systems and introduce reactive behavior. But how do we go about really utilizing Kafka to build these reactive systems that are really event-driven? So we'll go through each of the behaviors in the Reactor Manifesto and examine how we can implement sort of various configuration options to really make sure that our applications are displaying as many of these behaviors with best practices as possible. So the first of those behaviors was message-driven. And as we've already discussed, Kafka really enables us to implement this message-driven backbone and this decoupling between components. So let's take a look at, and we'll go straight into resiliency. So in terms of resiliency, Kafka, just by nature, has built-in resiliency in it. So the fact that Kafka has this stream history and this immutable data within that stream history means that if a component goes down, it can come back up and reread those various records or messages in that stream history. So it makes it extremely resilient in the face of microservices going down, for example, or needing to reread a particular record for various reasons. And this is different to traditional message queuing systems, because in traditional message queuing systems, once a consumer has read from a particular topic, that record is then removed from that topic queue. So it doesn't have this sort of immutable data built in to the actual sort of backbone of messages. So it's a really useful tool that we can utilize and feature that we can utilize within Kafka applications to really enable that resilient behavior. Kafka also has this resiliency built in with the way that it sort of sets up its clusters. So when you set up a cluster, you essentially have various different brokers. And a cluster usually has a minimum of at least 3 brokers, and we'll see sort of why we need at least 3 later on. But within these brokers, we break it down into topics. So topics are essentially where we store our records. And what we're referring to here with a topic is essentially a logical grouping of a similar kind of message or record. And it's up to you to define which messages or records go into which topics. So, for example, with our coffee example, our coffee application, we might have one topic for maybe coffee orders, and we might have one topic for user information updates, as an example of different topics and different groupings. Within a topic, we then have one or more partitions, and these partitions are distributed across Kafka brokers. We'll see sort of why partitions come into their own with elasticity in a minute. But in terms of resiliency, the key thing that we need to be thinking about here, the key feature that Kafka offers us that really enables resiliency, is the use of leaders and followers. So for each topic in your Kafka cluster, one of the brokers is elected as the leader and the other brokers are elected as followers. So essentially what happens is all of the apps connect into the leader broker and they consume from and produce to that leader. Then replication works across the followers as the followers repeatedly fetch messages from the leader, and this is all done automatically by Kafka. So in this example here, we've asked for 3 replicas when I set up my Kafka cluster. So we have 1 leader and 2 followers, as you can see here. So broker 1 is our leader, broker 2 and 3 are our followers. But what happens in the potential case of the leader going down? So if the leader goes down, well, the great thing is that we still have 2 copies of our data in our various followers. So that's already some resiliency built in because we haven't lost all our data. The other sort of resilient characteristic that Kafka offers us is this leader election. So if one broker goes down, so in this example, broker 1's gone down, so we've lost our leader. What happens is Kafka initiates this new leader election. So a new leader is elected from the followers that are still healthy, and our apps are automatically told to transfer across to this new leader broker. So this is fantastic because essentially we don't lose any data and we're able to reinstantiate the system and allow that broker to come back online eventually and rejoin as a follower. So we have backup of the data in the various followers because we have replicas of that data, and we have this automatic leader election. So we have some great resiliency behaviors really built into Kafka itself. But what about our applications and how they interact with Kafka? How do we make sure that the records from our app are actually successfully being sent and consumed from Kafka? So let's take a look at how we introduce resiliency into our producers, first of all. So if you haven't come across the term producer before, a producer is essentially the name of an application that's sending records or messages to Kafka. So a couple of things that we need to be considering when we're trying to introduce resiliency into our producers is delivery guarantee and the configuration that we need to enable to get those delivery guarantees. So with reactive and sort of resilient systems, we can't just do this fire and forget method if we want proper resiliency. Because if we do fire and forget and our broker goes down and we've only got one, maybe none of the brokers got the message when our brokers went down, or maybe only one got it and they've gone. Essentially, we can't guarantee that those messages have been stored successfully or have been received by Kafka successfully. So instead, we need to be considering these two guarantees. So either at most once or at least once. With at most once, you may lose some messages. It's not completely resilient. So if you don't mind some of the messages making it, then at most once might be something you'd like to consider. But if you need guaranteed delivery, so complete resilience, then it's at least once that you want to be considering. But you do need to remember that you may get some duplicates if you choose this delivery guarantee method. So you just need to be considering that in your application logic. And we can achieve these delivery guarantees by configuring two different configuration values, and that's ACKs and retries. So ACKs stands for acknowledgement, and that's essentially an acknowledgement that's sent when the records or the messages have been received. And we can set that ACKs value to various different things. So if we set ACKs to 0, that's essentially for when we don't really care about the message being acknowledged. It's really good for fast throughput, but not good for resiliency. We can also set ACKs to 1, and setting ACKs to 1 allows us to make sure that the leader, at least, successfully received the message. So we'll only get that acknowledgement back when the leader acknowledges that essentially they received the message. So we know at least one broker got the message. But if we want to be sort of that at least once guarantee and we want to be completely resilient, we can use ACKs equals all. So if we set ACKs to all, that essentially it makes it wait for all of the replicas to confirm they successfully received the message or record. So by using all, it does slow down the throughput, but it does enable us to have guaranteed delivery and a really high resiliency within our application and within our producers. Then we also need to be considering retries. So what happens if our ACKs times out or perhaps fails? How often do we want to retry, and how many times do we retry producing the event? The thing we need to be considering here when you're thinking about retries is that you need to consider how that retry might potentially affect the ordering of your messages or your records within Kafka. So that's just something to consider. But by enabling retries and by setting that ACKs value correctly, we can really enable our producers to be as resilient as possible. So we've talked about producers. What about consumers? So producers send messages to Kafka, consumers consume messages from Kafka. So when we're consuming these records from Kafka, we need to make sure that we know which messages we've read and processed and which we haven't. So for this, we need to be thinking about offsets. So an offset is essentially the value associated to a particular record on a topic, and it essentially just adds 1 every time a record is added to that topic. So we start at 0, and it goes up and up and up and up, as you can see in this diagram. In other messaging systems, the reason we need this offset and the reason we need to be considering this within consumers is because of this stream history that we have within Kafka. So in other messaging systems, we don't have this issue because once the record or message has been read by a consumer, it's no longer on the queue, but this isn't the case for Kafka. So this means we need to keep track of where the consumers have gotten to reading the stream of records or messages. So this is why we need to be considering offsets. You need to store your offsets somewhere. Usually it's stored in a topic on Kafka, and we call an API to commit that offset. But there's 2 different ways that we can commit that offset, and there's 2 different ways of us keeping track of where that consumer's gotten to. So that's automatic and manual. So we're going to take a look at the barista example here again to really see the difference between setting at that offset commit to either auto commit or to manual commit. So here we have our barista. Our barista is our consumer in this case, and we have a topic. And in our topic, we have 3 records or 3 orders for our coffee lovers. So let's take a look at how committing offsets and how this affects the flow of our application. So if we have auto commit, this means we have no code in our application to sort of state when we want to commit that offset, but instead we're relying on the default settings in the underlying client, probably a Java client in this case. So this client will essentially commit that offset on a timer basis for the messages that we've read from Kafka. So with the barista example, our barista, our consumer, starts reading from the topic. So we take that first order and we start processing it. So we've got that coffee order being processed. So because we're on an automatic commit here, we're on a timer basis because we're relying on the underlying client for this and the default settings. So our barista's been making the coffee for some time. So automatically, due to the timer basis, we get this coffee order. We've committed this offset for this coffee order. However, unfortunately, our barista is a little clumsy and drops the coffee. This is representative of that consumer maybe going down midway through processing. So when that consumer comes back up, when the barista eventually clears up and gets back to making the coffees, when they go back to reading the topic, they'll see that they've already committed the offset for the coffee. So instead of making the coffee, they move straight on to the cappuccino. So instead of making 3 coffee orders, we now only have 2 coffee orders when we get to the end of our topic, or the end of the records or messages in our topic. So we don't have very good resilience here because we've lost one of those records. We've lost that coffee order. So instead, what we can enable is manual commit. So manual commit really means that we're introducing code within our application to state when we want to be committing that offset. So in this case, we're not going to commit the offset until we've served the coffee. So we finished processing the coffee and we've served the coffee to our customer. So in this case, our barista starts making the coffee, and you can see that tick doesn't appear until we serve the coffee to the customer. And the same can be said for cappuccino and latte. So in this regard, even if the barista had dropped the coffee midway through making it, we wouldn't have committed that offset. And so when our barista comes back online and looks at that topic again, it can see that it needs to start right from the beginning at the coffee order again. So this is a great way of introducing increased resiliency by committing these offsets manually and determining exactly when you want them to be committed in your consumers. Kafka also enables us sort of extra resiliency because it really enables this decoupling that we've mentioned earlier. So it enables us to decouple the components of our system. So if one microservice goes down, it doesn't bring every other microservice down in the system because we're sort of decoupling it by having Kafka in the middle. And we can sort of utilize Kafka as a communication mechanism. And essentially, we can, when writing a set of microservices that communicate with Kafka, we have to consider sort of the shape of the records being sent and received. So if a producer changes the shape of records being produced, this change could break consumers, and it might imply that there's still coupling. So although it does introduce this decoupling aspect, and it is helpful, we still need to consider the shape of the data we're sending to Kafka so that we don't sort of create any more coupling within our application. And we can remove this coupling that might still remain in our application by using things like schemas and schema registries, which is another feature of Kafka. And schema registries can include things like RPQRO. So a schema, in this case, defines the structure of the data in a record, and the schema registry is the place that we use to store these schemas. So there are various different open-sourced and vendor-provided schema registries for Apache Kafka, and they often provide additional features like validation and compatibility verification to make sure that producers and consumers can easily upgrade to new versions of that schema. So by sort of externalizing this data structure, we're able to make sure that we definitely have no coupling within our application code, and we can introduce even further resiliency when utilizing Kafka. So we've taken a very deep look at how we can introduce resiliency in the configuration of our application in using tools and features like schemas and schema registries, and how there's inbuilt resiliency by Kafka's leader elections and brokers and topics and replicas. So let's take a look at the next behavior in the reactor manifesto, and that's elasticity. So how can we enable this scalability within Kafka? So Kafka is designed to work well at scale and to be scalable itself. As we said, this is all about placing events at the heart of our system in order for our applications to be able to scale and deal with data at scale. So in producing applications, we use partitions. And as we said, in topics, there is one or more partitions. Now, Kafka aims to be able to spread these partitions from a particular topic out across the different brokers. And this allows us to scale producers really easily, as we won't have load for one particular topic on one individual broker. We can also add additional brokers if we want to, and if that enables us to sort of spread the load out even more if we need to. So this is great in terms of Kafka itself, but we need to be considering scalability within our application. So how do we enable scalability when we're talking about the code within our application? And the area that we really see a big difference is in consumers. So in consumers, in consuming in Kafka, it's made sort of possible because of this whole stream history by using consumer groups. Because you have to handle this stream history and you have to know sort of what message you've read, whether another consumer has read a different message or record within Kafka, we have to utilize these consumer groups. So these consumer groups essentially allow us to group our consumers together so that we can know which consumers have read which messages and get that ordering guarantee. So we're able to know which groups are in which consumer groups because they essentially state a group ID in their configuration. So in this example here, we have two consumer groups. We have consumer group A and consumer group B. And in consumer group A, we have 3 consumers, and in consumer group B, we have 2 consumers. Each consumer here is representative of a different Java application. And as I said, they joined their consumer group by providing a group ID to Kafka when they started up, and that's in that configuration value. It's in a configuration file of Kafka. So once they formed a group, Kafka will make sure that messages in the same consumer group read all of the messages within that topic. And this is where partitions come in again. So each consumer is essentially assigned one partition to read from. So in this case, you can see partition 0 is going to that first consumer, partition 1 to the second consumer, and partition 2 to the third consumer. But what happens when we don't have an equal number of partitions and consumers? So in consumer group B here, because we've only got 2 consumers, that means that essentially one consumer will be reading from one partition, but the second consumer will be reading from 2 partitions. So essentially, by enabling these consumer groups, we make sure that we haven't read duplicate messages, and from an ordering standpoint, Kafka provides this ordering guarantee per partition. So it provides this ordering guarantee for us. What happens if we want to add an additional consumer to a consumer group? Well, in consumer group A, if we add an additional consumer, because we don't have any additional partitions for it to read from, it essentially just sits there idle. Again, because of that stream history, that extra consumer can't read from the same partition as another consumer in the same consumer group, because that might end up with records being read twice or maybe missed. So it essentially just sits there idle. So when you're configuring your application, when you're setting up your application and setting up your Kafka clusters, you need to be considering how many partitions you're creating based on how many consumers you think might end up consuming from your application. But it is a delicate balance because when you can't add new partitions once your system's running, but the more partitions you have, the more load you're putting on the system when a leader election happens. And the other awkward part is if you add partitions once you've already started up the system, you lose that ordering guarantee. So do be careful. It's a delicate balance where you need to be considering, have I got enough partitions so that all of my consumers are actually, able to read from them? But equally, don't do too many, don't go overboard because you will add extra load onto your system when you're doing things like leader elections. So this is a really important configuration to be considering to enable that elastic behavior for us to be able to grow our consumers and to enable that scalability within our application. So I mentioned back pressure as quite a useful pattern when we're implementing reactive systems, because again, it helps us to gracefully handle those potential sort of fluctuations in load. As I said, that's where that elasticity comes in as well. So back pressure pattern consists of this feedback mechanism, and a back pressure pattern that's often utilized is sort of TCP IP back pressure. And this is normally achieved by having sort of separate send and receive buffers, and data is only sent between them when there's available space in the receive buffer. So you can see here on the bottom right, we have our receive window, and you can see our buffer, and that we'd only call enough data to fill that buffer. So rather than using a receive menu window and requesting data only when the downstream component has space, Kafka can be sort of introduced as a sort of infinite buffer. So where Kafka comes in is because we can just send events to Kafka and they get added to this topic, we can essentially, if a consumer goes down, Kafka can act as an almost infinite buffer for those messages coming in, because once our consumer comes back online, our consumer can start catching up with the messages it hasn't read yet and it needs to catch up with. However, Kafka doesn't have an infinite amount of space. So it isn't an infinite buffer, but it does help to act as a buffer between those aspects of your application, between those consumers and those producers. So this doesn't work for all use cases, unfortunately. There is, therefore, there's some level of back pressure is often required in systems that use Kafka. So essentially, that's where a lot of the sort of back pressure characteristics that we're going to mention later come into play in terms of the various different mechanisms that are used by the different reactive frameworks and toolkits. You can utilize the standard Java Kafka consumer client, so it does have this availability, this sort of ability to pause and resume consuming from Kafka, but it isn't an entirely sort of reactive form of back pressure. And this mechanism works well for consuming sort of simple use cases because it's modeled as a single loop. But where processing is fairly quick or perhaps complex, where we've got like multiple threads, for example, we are better off using some of the other sort of reactive frameworks and toolkits. So we've looked at how we can introduce elasticity, how we can introduce resiliency, and how we can utilize Kafka to really create a reactive application, essentially. So how do we go about writing this? How do we go about building reactive Kafka applications? So as I mentioned, there's a standard Java Kafka client, and that includes the standard Java Kafka producer and the standard Java Kafka consumer. Now, these enable some reactive behavior in, as I was saying, the pause and resume functionality, but they aren't designed to be really non-blocking and sort of reactive to the core. So that's where we like to sort of point people in the direction of reactive frameworks and toolkits. So we're going to focus on sort of 3 of the more common reactive frameworks or toolkits. This isn't an exhaustive list. These are just the ones we've worked with previously. If you're utilizing things like Spring Webflux, for example, you might be interested in Project Reactor, which is an additional framework we're not going to be touching on in this session, but is an additional sort of alternative to these technologies. So the ones we're going to be focusing on are sort of Akka, or the Alpaca library within Akka, MicroProfile, and Vertex. And all of these have connectors to Kafka, so you can really utilize that reactive behavior for an application that utilizes Kafka. So the first one we're going to take a look at is Akka, or the Alpaca library. So the Alpaca library essentially provides this Kafka connector API for us to be able to connect Kafka into Akka streams. And Akka streams is essentially part of the Akka framework or toolkit. So Akka is slightly different to many other reactive frameworks, or sort of many other frameworks in general for helping you build applications, because it's based on something called the actor model. So it's not using microservices. So this actor model is essentially a paradigm or shift in thinking. So it's this conceptual model to deal with concurrent computation, and in it, the actor is the primitive unit of computation. So it's the thing that receives a message and does some kind of computation on it. Messages are sent asynchronously to each actor, and they store them in these mailboxes. Actors are able to communicate with each other by sending in these asynchronous messages, and that's where the asynchronicity really comes in. Actors also have this sort of hierarchy structure. So they have child actors and parent actors. So the parent actors can assign work or assign requests to child actors and monitor them as well. So it's a slightly different conceptual model. If you're already using the actor model, then Akka might be a great framework or toolkit to consider. If you're not, it is a little bit of a paradigm shift. So just be cautious if you're looking at Akka as a framework to utilize for those reasons. So as I said, each of the different frameworks and toolkits sort of implement back pressure in a different way. So whilst we go through each of these frameworks, we're going to take a brief look at how they implement back pressure as well. So in the Alpaca Kafka connector, it handles all the pull requests to Kafka, enabling the application code to request new records using the standard Akka streams back pressure mechanism. So this mechanism is implemented according to the reactive stream specification, which was that specification I mentioned in the reactive programming section of this presentation. And it works on the basis that an application is essentially split into stages, where downstream stages advertise to their upstream stage when they're ready to receive more data. So kind of a similar concept to that TCP IP backpressure I mentioned earlier, where you sort of have that buffer space and you're able to send the amount of space that you have and request that from an upstream component. So this approach to backpressure, it will probably be familiar to developers who have previously used Akka streams within their application, but this is a learning curve to understand the syntax and to fully grasp the paradigm shift of adopting the actor model, like I said. So do just be cautious of that. But that's how the Alpaca Kafka connector enables backpressure by essentially advertising to the upstream stage when they're ready to receive more data, as you can see here. The next specification we're going to be looking at is Eclipse Microprofile. So if you've not come across this specification before, it's a community-driven specification for enterprise Java microservices. And it's built and created and developed by a wide variety and a community of individuals, organizations, and vendors. And that includes developers that are sort of individual and they work for themselves, those who volunteer, but also developers from IBM, Red Hat, Payara, and many, many other vendors all working together. So with Microprofile, you get various different APIs and specifications. You can see here on the bottom, that sort of triangle shape, those are the specifications that come as standard with the Microprofile stack. Now, the Microprofile stack 3.3 is available at the moment, sort of fully production ready. 4.0 is in beta at the moment if you want to check that out. The one we're interested in, though, is a standalone project. So standalone projects are projects that the Microprofile developer community still work on, but they aren't yet part of the main Microprofile stack. And the one we're interested in here is the reactive messaging specification. So this reactive messaging specification builds upon the reactive stream specification and the reactive streams operator specification. And essentially what this enables us to do is to really enable sort of reactive behavior within our application by utilizing these annotations. So Microprofile works by annotating an application's beans that contain methods. So we annotate those methods with either at incoming or at outgoing annotations. And these at incoming and outgoing annotations are matched up by something called channels. And a channel is essentially just an opaque string to match them up. Those channels can be internal or external. If it's an external channel, we call it a connector. So that way we can connect into systems like Kafka. Now the connectors, Microprofile is just a specification, so it is implemented by various different vendors. We have our own implementation called Open Liberty, and each implementation has its own connectors. So the connectors that will be available to you will depend on which implementation you're using in Microprofile. But you can see here an example of utilizing those annotations. We can see that we've connected up method A with method B by connecting that outgoing method annotation on method A with order channel to the incoming annotation on method B with that order channel. So you can see here how we can utilize those various different components. So how does backpressure work in Microprofile? So it essentially works by using these annotations, and backpressure works in a really similar way to the Akka backpressure I just described. So the flow to downstream components is essentially controlled based on these components making requests for data upstream. So essentially what happens is we have the incoming annotation where we use our Kafka connector, we have outgoing annotation using a database connector, and that database connector might become unable to continue producing. So as a result, the Kafka connector can stop requesting new records. That's essentially how backpressure operates using Microprofile in a reactive system. And as I said, there's very different implementations, including Open Liberty, which is our IBM open source web application server. But there's also things like Quarkus and Small Mutiny. And these individual implementations of Microprofile interpret this backpressure in different ways. So this is the backpressure for the Open Liberty interpretation. Our last open source sort of specification or toolkit that we're going to be touching upon in this session is Vertex. So Vertex is a polyglot toolkit. So it doesn't just have to be used for Java. You can also utilize it for JavaScript, Scala, Kotlin, and many other languages. It's based on the reactor pattern, which is essentially an implementation technique of using really event-driven architecture. So it uses this single-threaded event loop, blocking on resource-emitting events, and dispatches them to corresponding handlers and callbacks. So that code is really single-threaded in Vertex. It includes this distributed event bus, which really allows us to place sort of that event-driven architecture behavior throughout our application, not just in our interaction between our app and Kafka. So backpressure in Vertex, in terms of Vertex, it provides a separation for sort of polling from processing, and this gives developers the choice to either let Vertex handle the poll loop and this pause and resume functionality, or to handle the poll loop themselves. And this really helps with sort of backpressure within Vertex. So going into Vertex in a bit more detail, we actually used Vertex when we were sort of transitioning our Kafka application, our demo app, into a reactive Kafka demo app. So our demo app looks a bit like this. This is sort of a basic architecture diagram of what's going on within our application. If you want to check it out, it is on GitHub and it's all open sourced, including our UI. So you can check that out, and it's really useful for testing your Kafka to see if that's working. So in our application, we have this Vertex app, and that Vertex app produces events to Kafka and then consumes its own events back again, which isn't necessarily something you want to do in enterprise systems or maybe want to do in general, but it just helps us to show that Kafka is working and create this sort of very simplistic demo. And then we have a UI. We wanted a UI to be able to sort of see what was happening under the covers, so see those events being produced and see those events being consumed. And we send that information to the UI back and forth between the Vertex app and the UI via a WebSocket. So here is the application. As I said, it's all open source if you want to check it out. We more than welcome sort of improvements if you want to get involved and help us improve this application. Essentially, what we wanted to do with this application was we wanted to be able to start producing apps, sort of messages, then start consuming those messages back again. But then also we wanted to be able to stop producing and stop consuming and then restart again. And what this meant for our actual application is that when we built it as a non-reactive application, we had some issues in terms of pausing and resuming sort of that communication with Kafka. And we had some issues in terms of thread management when we were pausing and resuming. In terms of producing records, the benefits that we saw, so in the original application of the flow for producing records, is fairly straightforward. So we have a start command that's sent to the backend on the WebSocket. That backend then starts the producer, which sends a new record every 2 seconds. Then we have a stop command, as you saw in that video, and that stop command is sent to the backend on the WebSocket, and the backend then stops the producer, and no new records are produced. But in the original application, using the standard producer client, the call to produce that record was a blocking call. But when we switched over to Vertex, that meant that that Vertex producer was able to now use a future to get a future back from the send function. So you can see here, essentially, this change, switching to Vertex and utilizing this future function, allowed the application to asynchronously produce these new records while waiting for the acknowledgement from Kafka of in-flight records. So this is a fairly small code change, but changing to a non-blocking when talking to external services like Kafka is a really important feature of reactive systems. So this made it easier to build the application to be resilient when these when these external services become unavailable. So you can see here how we were able to introduce more reactive behavior and sort of that focus on asynchronicity when we were producing records. But the biggest change we saw was when we were consuming and processing records. So in the original application, we were having to use this sort of for loop inside a while loop that resulted in the following flow. So we polled for records. That poll function returns a batch of records. We then iterated through each record in the batch. And for each record, we sent the record along the WebSocket to the front end. And then only after that iteration complete are we able to return to step 1 and poll again for new records, which meant that whilst we were processing the current batch of records, no new records could be fetched. So again, it was a fairly blocking, fairly synchronous process. It didn't feel very asynchronous. So you can see here, sort of focusing down on that loop. When we switched to the Vertex Kafka client, we were actually able to make this flow a lot simpler. So in the Vertex client, instead of using all of this sort of poll loop and having to wait and iterate, we basically use a handler function that can be called every time a new record arrives. So this really allowed us to have this asynchronous consuming and processing of records, which fit in much better with the reactive paradigm. So we made the flow a lot simpler, and now Vertex is able to handle the step of polling for new records instead of us in our application logic. So now our application code receives a new record and then sends that record along the WebSocket to the front end. So this not only allows the application to process on a per record basis, but it also leaves the developer free to focus on the actual processing of the records instead of the polling, instead of consuming them from Kafka. So it enabled us to sort of simplify our code and really enable that asynchronous per record basis of processing. We also wanted the ability to pause and resume, like I mentioned, both producing and consuming records from the front end. In the original application, where the default Java client was used, the while loop that caused the poll for the consumer needed to be exited and resumed based on commands from the front end. And because of this, the client is single-threaded. The loop had to be executed in a separate thread to the main flow of the application. Like I mentioned, this caused us all sort of thread headaches. Because we wanted to produce records on a timer, a similar while loop in a separate thread was required for the producer. So we had to deal with the headache of sort of writing this logic to control the thread lifecycle and synchronize this data across threads just to get control over the flow of records. Whereas when we introduced this sort of Vertex client and the Vertex application, we're able to use a combination of Vertex features and the Vertex Kafka client features to make the flow control much easier. So for the producer, we used a feature in Vertex that allows a handler to be called, like we mentioned. This handler can be called once, like we're doing, or multiple times, and it was easy for us to be able to pause and resume the timer when we wanted to start and stop requests arriving from the WebSocket. So you can see here how it really has helped us to really achieve asynchronous behavior within our application. We were also able to take advantage of additional Vertex features like the Vertex config to again instantiate more of those reactive behaviors that we want to see. So the Vertex config library essentially allowed us to provide a Kafka.properties file with all of our configuration loaded at runtime. So we essentially allowed us to switch between any different Kafka versions, so secure and non-secure Kafka endpoints. So we were able to move the application much more easily between Kafka installations if they're configured the same way. But it also enabled us to write it in a much more sort of cloud-native manner because we were able to externalize that configuration, similar to what's done in MicroProfile with the MicroProfile config feature. If you want to see those specifics and dive deeper into our application to see sort of what we were able to achieve by switching to that reactive-based application, Kafka application, we've written a whole blog about it here, and you can access that with the link at the bottom of the slide. So hopefully what I've shown you from sort of this demo, our application, and from the introduction to reactive is that you can't just take a non-reactive application, add in a tool like Kafka, or just shove in an event-driven backbone and expect it to be magically reactive or magically non-blocking and asynchronous. Instead, you need to consider carefully the various different layers and levels in your applications and whether you're introducing reactive behaviors to each of them. But you also need to consider the Kafka configuration you're utilizing and whether it's the best it can be to make your application as reactive as possible. But you're not alone. Thankfully, the open source reactive community is on hand to help. There are lots of reactive toolkits and libraries available for you to utilize, all open source. And those reactive toolkits and frameworks can provide additional benefits as well for your application. So we're going to take a look at sort of how we can actually go about building a reactive application. And I'm going to show you just how easy it is to get started with some of those toolkits and frameworks when we're building Kafka applications in a reactive manner. So we produced these reactive labs. They are all based on the MicroProfile specification. So we've got I think there's about 7 in there. If you want to take a look at them, feel free. Or if you want to follow me along for this brief sort of interactive session, you can go to this link and we're going to be doing module number 1. So if you want to follow along and interactively do this alongside me, feel free to. This is all based on an online environment. So we're using IBM Cloud and Thea. So basically what it means is you don't have to have any prerequisites installed onto your own machine. So you can just essentially log in and the environment is created for you. So let's take a look at that now. So we're just going to restart. So I've gone to that link, and that link will take you to this sort of landing page. And this landing page shows you all the modules we have currently, and we are adding to this all the time. So do check back and there'll be additional modules here. The first module is the one we're going to be focusing on today. And this first module, I've lost my mouse, there we go. This first module is essentially just the basics of how to get started with microprofile reactive messaging and sort of Kafka Java applications. The second module goes into testing in a little bit more detail, and for that we're using something called microshed testing, which is really all about running those tests in an environment, so in a container that's as close to production as possible. So that's a really great tool. If you want to take a look at that, check out Module 2. Module 3 is all about how to acknowledge those messages. So like I mentioned, that acknowledgement is really important for the resiliency within our applications. So check out Module 3 if you're interested in acknowledgements. Module 4 is all around integrating with RESTful services. And Module 5 is all about how to use a reactive JAX REST client to asynchronously invoke RESTful microservices over HTTP. As I said, the one we're focusing on today is Module 1. I've already gone into it, so we're just going to restart this lab. Now, we'll ask you to log in. So if you're logging in with me and trying this out, you will have to log in, but you can log in with most social logins that are available, or you can just log in with your email address. So let's get started. So the way this environment works is we have on the left-hand side, we've essentially got instructions that you have to follow and sort of key educational sort of points to point out whilst you're doing this. And then on the right-hand side, we have sort of essentially a basic IDE and a terminal. So we're going to jump straight in to sort of step number 1. So this application is based on 2 different microservices. We have an inventory microservice and a system microservice. So in fact, if I go back to step 1, we can see here, so it should let you know, yeah, so the system, here you go. So every 15 seconds, the system microservice calculates and publishes an event that contains its average system load. So that's the purpose of the system inventory microservice. And then the inventory microservice subscribes to that information so it can keep an updated list of all the systems and their current system loads. So essentially, those are the 2 microservices we're using, and they're connected together via Kafka. So we're going to be utilizing the Kafka connector from OpenLivity whilst we're using these microprofile reactive messaging concepts. So the first thing we need to do is git clone. So I'll just git clone that, and then cd into guide microprofile reactive messaging. We've created a start and a finish repository, and that's so that you can essentially start from a place where it's not, you just follow these instructions and you'll get to the finish guide essentially. But if you want to check out what the finished guide's meant to look like and compare it to what you're doing, then you can essentially check out the finished directory to compare and to sort of check out what it should look like at the end. So the first thing we need to do is create a system service class. So we're just going to do that now. And then we're going to go in and open that up. So we're going to open up guide microprofile, start. This one's for the system. So in system, SRC, main, Java, IO, OpenLivity, guides, system, and then there's our system service that we just created. So we're just going to copy in all this code that we've got here. So it's quite simple. We've already provided you the code that you need. But interestingly, the parts that I'm going to point out link to the presentation we've just taken a look at. So you can see here, because this is the system service, so this is the one that's producing every 15 seconds to Kafka, we're actually utilizing the @outgoing annotation. So remember that those 2 annotations from microprofile were @incoming and @outgoing. So in this one, we're utilizing the @outgoing, and we're publishing to a topic on Kafka called system load. And you can see here we're using Flowable, we're doing it every 15 seconds, and we've got our average system load data. So we're actually using, so that flowable interval is actually essentially a method from RxJava. RxJava was, I mentioned it in the presentation, it's a reactive programming paradigm. So as well as using the microprofile specification for reactive messaging, we're also utilizing reactive programming within this application. The next thing we need to do is create an inventory microservice. So I'm just going to quickly do that now. Open that up again. So you can see here it's quite easy to navigate using our online environment to the different folders that I need to go into. So let's just navigate pretty much the same place, but this time in the inventory directory. And then we can see our inventory resource class that we've just created. I'm going to copy and paste this code in again. There's a little bit more in this one because we're consuming this time from Kafka. Save that. But you can see here, importantly, we've got that @incoming annotation because we're consuming from Kafka. And we're consuming from the same topic that we were producing to in the system service class, and that's system load. So in order for this to work correctly, we essentially need to set up those config properties files. Similarly to the Vertex config, we're using microprofile config in this case to externalize our configuration. So I need to create that config file, and then I need to go in and open that up so I can add stuff to it. So I need to go into sort of start, because we're just in the start, and then we need to go into where we go, system, src, main, resources this time, meta-inf, and then microprofile config properties. So let's copy that in. So in here, you can see that we've actually got the outgoing, we're using the outgoing sort of annotation because this is the system properties. So remember that system microservice is producing to Kafka. And you can see here that the connector we're using is the Liberty Kafka connector because we're connecting using OpenLiberty to Kafka. As I said, each implementation has their own connectors, so this will change depending on which implementation of microprofile you're using. You can see here we've set our topic to be system load topic, and these serializers enable us to essentially serialize that topic into JSON configured using the value.serializer. So the next thing we need to do is create a similar file, a similar config file for the inventory microservice. So I'm going to go in and open that one up. So open it up in Guide Microprofile Reactive Messaging, Start, Inventory, src, Main, Resources, meta-inf, oh, missed it, meta-inf, and then Microprofile Config Properties. So in here, again, similar sort of config properties to what we had in the system config properties file. But in this one, we've got an additional one here. So we've still got the Kafka connector. We've still got the same topic that we're producing and consuming to in Kafka. We've still got the deserializer and the serializer. But this time we've got the group ID. Like I mentioned in the presentation, consuming in Kafka requires us to use consumer groups because of that stream history and in order for us to make sure that we're not consuming duplicate events. So this group ID allows us to essentially put this consumer in a particular consumer group. So that group ID is the additional config value you'll need to add for any consumer config properties files. So now we need to essentially create our server.xml configuration file so that we can add in things like the microprofile reactive messaging feature. So let's open that one up. Guide, start, and then system, src, main, liberty, config, server.xml. There we are. And let's add this in. So we copy and paste this in. We can see here that we've added in the microprofile reactive messaging feature. We're also utilizing microprofile config, like I mentioned when we made those configuration files earlier. So now that we created our server.xml file, we've done that for systems here. The inventory one's already been done for you. So if you are running through this with me, you don't have to create the inventory server.xml because we've done it for you because it's pretty much exactly the same. So now let's create the Maven configuration file. So we can do that using pom.xml. So here we go, and then open that up. Open. Now with this one, just be careful if you are following along with me on this, because there's there's kind of two in this file structure. Make sure it's the top one. Should be empty when you open it up. That should be a key sign if you've opened up the wrong one. So we'll copy and paste all of our configuration in. Oh, not the right one. Didn't copy it properly. There we go. So in here, you can see that we've actually got plugins for, there's the microshed testing that I was mentioning that we use in module 2. There's RxJava that we utilize for that flowable method earlier. That's that reactive programming library that we're utilizing. We've got Apache Kafka in there as well. And here's the microprofile reactive messaging dependency that we've had to add. Because it's separate to the microprofile stack, you need to add that separately as a separate dependency. And here's the microprofile stack that utilizes things like microprofile config. But just remember that you do need to add the second dependency to enable reactive messaging using microprofile. So let's go ahead and essentially start running and installing this. This might take just a little bit of time depending on sort of whether you've run it before. If you've run it before, it should take less time, obviously. So we're going to start our Docker environment. So we've already provided you all the Docker files you need for it to get started with this application, if you are following along. Just wait for this to finish. Shouldn't take too much longer. almost it. There we go, finished. So then, have I done my npm package? Just double check. Cool. So I'm going to skip this step. So this step just essentially makes sure that you're pulling in the latest version of our OpenLiberty sort of Docker image. If you want to check out which Docker images we have available, you can go and check those out on Docker Hub. We have lots of different versions available of varying sizes depending on your application. So we're just going to go ahead and sort of build this application. So first one we need to build is system, and then we're going to build the inventory microservice. Again, depending on whether you've run this before, it will take varying amounts of time. Perfect, that's done. And then we're going to essentially start our containers. So once those containers have started and we have our application up and running, what we can do is we can go to the inventory/systems URL to essentially access the inventory microservice. And what we should be seeing in the inventory microservice is that list of the values that it's consuming from Kafka. So what this curl command really enables us to do is check that our systems microservice has been able to successfully produce to Kafka, and that our inventory microservice has successfully been able to consume that data from Kafka, all using microprofile reactive messaging, using those annotations, incoming and outgoing, and the channels connecting those, or the connector in this case to Kafka. So we just have to copy that curl command. Let's see if I've given it enough time already. Fantastic, yep. So you can see here that the data we get back shows me the host name and the system load data. Now, the interesting part is this is live, obviously, because we're getting your own system data. So actually, if you run that curl command again, you should see, yep, that system load changes over time depending on what you're doing with your machine, essentially. So you can see that is how easy it is to get started, sort of utilizing reactive messaging, utilizing microprofile reactive messaging and RxJava, Kafka, and sort of open source tools like OpenLiberty. It took me about 10 minutes to get up and running with an application that's utilizing all of those functionality and is a reactive Kafka application. So if you are following along, you will need to tear down your environment. So I'm just going to quickly do that now. And then you can clean it up using our scripts here. So it's just stopping those containers for me. And then once it's done that, I'll do a cleanup. Yep. Oh, and you can see everything disappeared. So it's quite handy. And if you want to go back and do some of the other modules, feel free to afterwards. This is all running on IBM Cloud. It is our own environment. So if you have any feedback for us, feel free to send that my way. So going back to the presentation, so I've taken you through sort of a hands-on learning in terms of just showing you how easy it is to get started using these reactive frameworks, these reactive libraries and toolkits, and really making sure that Kafka is as configured to be as reactive as possible for our applications. If you want a recap of sort of what reactive systems are, why you'd want to use them and when to use them and how to, this really brief ebook can help you with that. It's a free ebook written by myself and my colleague, only about 30 pages long, so not too long to read. And you can access that using the link here on the left-hand side. Just a really great reference point for you to go back to or share with your colleagues if you want to dive into reactive a bit more. If you're interested in sort of utilizing Kafka, but you want a supported version, we do offer IBM Event Streams, which is our supported version of Kafka with some value add-on capabilities. So, for example, the UI that you've seen in the videos that I've shown through this presentation, that in our application is the same UI that we use for our supported offering. So, if you enjoyed that UI, then we have the same UI experience for our supported version of Kafka. We also introduce things like that schema registry that I mentioned earlier, which is a really fantastic tool for introducing extra resiliency within our applications. But we also introduce things like connectors, so connecting into MQ, for example, so that you can utilize both traditional MQ sort of queuing systems as well as Kafka within your application. So you can check out more information about that using the link at the bottom here. And as if I haven't given you enough links already, apologies for that, there are additional links that you can check out here. So if you want to take a look into sort of more depth into getting started with reactive, then definitely check out our Intro to Reactive series or our article, Getting Started with Reactive. We've also got some great resources here for you getting started with Kafka. If you've not tried Kafka before, there's a fantastic quick start guide that you can check out here. It gets you up and running with Kafka in about 10 minutes. Do remember though that you don't just need Kafka, you also need Zookeeper. So you probably saw in that demo I just ran, we had some commands in there for Zookeeper as well. And that's because Zookeeper is still needed right now to store metadata for Kafka. In the future, that metadata will be stored in a topic in Kafka itself, but right now that's not released yet, and you do still need Zookeeper. So when you're running that quick start guide, make sure you run both. We've also got Stremzy on there. So Stremzy is an open source operator for Kafka, and it is produced by sort of an open source community if you're interested in running Kafka with Kubernetes. And then on the right-hand side, we've got some of those reactive Kafka libraries that I mentioned, including the Vertex library, the microprofile reactive messaging library, Project Reactor. So if you're interested in Spring or Spring Webflux, that utilizes Project Reactor, which is another reactive framework. And there's also Alpaca Kafka. And then the event streams link at the bottom. So thank you very much for listening. Hopefully I've shown you and taken you through sort of a deeper dive into how you can utilize Kafka and event streaming and reactive behaviors and characteristics to design applications and systems that are responsive to users and that are responsive to events that are placed at the heart of our system in this current event-driven world. With clicks, with sensors all over the place, IoT everywhere, and applications growing in the amount of data they have to handle. Hopefully, these tips and tools will help you to sort of evolve your applications to be able to gracefully handle these fluctuating loads. So thanks very much, and I think we have some time for Q&A now. If I don't get round to your Q&A, or you have a go with the labs and you have something else you want to ask me later, then please do reach out on Twitter afterwards. Thanks very much for listening.
Thank you very much, Grace. So now I invite you to join our Q&A Zoom room to discuss all the details with our participants. And thank you very much. Guys, next we will have a presentation from our partner, Luxoft.
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. The company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. NX is one of the most active employers in Ukraine, according to DOE, as it constantly has around 100 open positions. Join NX. Grow your career with one of the fastest-growing IT companies by your side.
Привіт! Вітаю Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте. Знайомтеся. А це Зеник – традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition, Ukrainian Spirit, Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка – перерва на каву з запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привіт, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в IT. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про IT та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. The company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. NX is one of the most active employers in Ukraine, according to DOE, as it constantly has around 100 open positions. Join NX. Grow your career with one of the fastest-growing IT companies by your side.
Привіт! Вітаю Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте. Знайомтеся, а це Зеник, традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition, Ukrainian Spirit, Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка – перерва на каву з запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привет, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в IT. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про IT та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. The company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. NX is one of the most active employers in Ukraine, according to DOE, as it constantly has around 100 open positions. Join NX. Grow your career with one of the fastest-growing IT companies by your side.
Привіт! Вітаю Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте. Знайомтеся. А це Зеник – традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition, Ukrainian Spirit, Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка – перерва на каву запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привет, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в ІТ. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про IT та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
In Itera, we are specialists in creating digital business. We have a proven track record of developing innovative solutions that bring great user experiences and high business value. Our method is to work in cross-functional teams, combining our skills of business development, service design, user experience, development, testing, security, DevOps, and cloud platforms. We are always excited about collaborating with new, innovative customers and have high ambitions for common achievements in areas such as designing excellent user experiences, scalability and cost benefits improvements through our hybrid delivery model, providing more for less, increased operational effectiveness through smart use of technology. And this is just the beginning.
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. the company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. Enix is one of the most active employers in Ukraine, according to DOE, as it constantly has around 100 open positions. Join Enix. Grow your career with one of the fastest-growing IT companies by your side.
Привіт! Вітаю Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте. Знайомтеся. А це Зеник – традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition Ukrainian Spirit Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом. Працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка. Перерва на каву з запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привет, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в ІТ. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про ІТ та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
The future of business depends on the transformation of yesterday's legacies. Luxoft meets the challenges of today by developing the solutions of tomorrow. Because innovation lies in our core, it allows us to reinvent and not just respond. Domain integrity, coupled with ability to scale, is how we define our purpose. Think about tomorrow's autonomous driving landscape. Digital companions that always steer you in the right direction. We will empower the mobility revolution to put stunning user experiences on the road. Imagine the patients of the future connected to 24/7 health monitoring systems and treated by algorithms that can predict and even prevent diseases. We can help our clients to improve patients' experiences and drive them into the digital era. Our perception of money might not change in the future, but everything else will. Luxoft helps integrate businesses with advanced technologies that deliver an unparalleled experience. Using our blockchain expertise, we help to remove data silos and improve trust. We are taking full advantage of the growing symbiosis between human and AI talents. With self-learning machines and robots on our side, we will be able to shape the world of tomorrow. With our client-centric approach, Luxoft quickly connects the dots to identify a perfect solution, from development to delivery. We offer technology hope. We embrace customer fear, and we drive the experience of tomorrow. And because we live and breathe technology, we see what others have missed.
Hello, Devoxx community. Even though I cannot see you, I can feel you, that you are there behind the screen, and it's a great pleasure to know that you're today gathered at this conference. My name is Lesia Manzevich. I'm an employer branding manager at Luxoft Ukraine, and it's a great pleasure for us to support Devoxx throughout the years, especially this year. It makes us even more proud that this year, in times when we are all threatened and many events are canceled, Devoxx managed to turn from the biggest Java-related Ukrainian event into truly global happening. Way to go, guys. This is beyond amazing. Java is actually one of the most popular technologies in the world, and hundreds of thousands of solutions are being built daily utilizing this technology. At Luxoft, we honor it and use it in many projects as well. If you enter our website and go through it, you will see many vacancies and events dedicated to Java. Please feel free to study more and join us at any event or join our team at any time. When we participate in conferences, we at Luxoft always strive to make new friends and to get to know people. This year, for obvious reasons, we are forced to do it digitally, but nonetheless, we really want to establish that contact with you. So please feel free to join our Telegram channel and to take part in our friendly giveaway, to test your knowledge in Java, and not only in Java, through our Galactic IT quiz. You can find the links in the partnership section of your screen, of your today's screen. We have a lot of presents for you at Devoxx. These are gift certificates, chargers, backpacks, and even a bike. So as the Devoxx is a two-day conference, we will announce our winners tomorrow. That means you have still plenty of time to join and to become a winner at our giveaways and Galactic IT quiz. That's probably, I will wrap up my presentation, but the last but not the least, I would like to mention that Luxoft unites over 3,500 people in Ukraine and over 12,000 people globally. We strive to make difference and to bring excellence to our customers. And we think that it's a great cause That's why we always encourage people to join our team and actually to make a world a better place somehow. So please don't hesitate, join, participate, take part in the quiz. And at Devoxx, learn, become smarter, and have fun. Enjoy. It was a pleasure meeting you.
Your domain is the backbone of your business. You need a stable, secure, and reliable DNS provider to protect your investment and ensure your customers can always stay connected to you. But being stuck in a room with a hungry mosquito is way more appealing than navigating the world of DNS management, until now. DN Simple has solved the problem of needlessly overcomplicated DNS management with automated tools that most people have never even dreamed of using. Want to register a new domain? Enter your information once and you're done. How about selling domains from your app? Integrate your sites with our API to instantly provide more value for your customers. Set up the DNS records needed to connect to services like Heroku, Shopify, and G Suite with one click. And use our automated SSL certificate generation to easily secure all of your websites. It's so user-friendly, everyone from grandma to this super genius can connect their domains to the services they use without ever thinking about DNS. Simple, secure domain management is right here at DN Simple. Try us free for 30 days.
Hi everyone, well, I'm back. Nice to see you here. I hope you're enjoying your time on Devoxx Ukraine 2020. And now I'm happy to invite our next speaker, Jayesh Ahire. Hi Jayesh, how are you today?
Hey, hello. Good afternoon. I'm doing good. How are you?
Thanks, good. Okay, are you ready to give us your talk?
Sure, yes. Cool. So, good afternoon, everyone. Today I will be talking about distributed tracing, which is getting a lot of mind share in last 2 years. Some people even call it a new foundation of DevOps, but we will see if it really justifies its fancy new title. So, I am Jayesh Bapu Ahive. Currently, I'm founding engineer at Traceable.ai. I'm also AWS machine learning hero and video champion. So, at Traceable AI, we are building a modern AppSec platform based on distributed tracing and machine learning. We also have open source our underlying observability platform called Hypertrace. And apart from my day job, I'm also involved in some AI research around distributed neural computers from last 2 years. And if you want to talk to me around my work or collaborate on some different projects, you can ping me on Twitter and I'm happy to talk about it. So let's go through our agenda for next 20-25 minutes. We'll see why observability became important and what is it. And then we will discuss in particular about distributed tracing. And then we will see a demo of an application instrumental with tracing. So let's jump into our first broader point for today, observability. So monitoring or traditional APM solutions have been around from quite some time, and as this code says, that monitoring tells you whether your system is working, and observability lets you ask why it isn't working. And this why here is very important. So let's first jump and see why do we need observability in the first place. So there are multiple reasons behind requirement for observability. So let's just walk through our thought process, which will help us understand the situation better. And let's just conclude on why do we need observability. So most of the tech giants, including companies like Amazon, Netflix, started to build their systems using monolithic architectures back in the time because it was much faster to set up a monolith and get the business moving. And getting the business moving was the first important thing at that time. But over the time, as product matures, or as we say, fat growth happens, with growing systems, the code gets more and more complicated. They all faced the problem and looked at the microservices as a solution. So one of the biggest benefits of adopting to microservices is that microservices can be developed, deployed, or scaled separately, and you can even replace or upgrade any part of the system independently. So everyone started adapting to microservices, and here we are today looking at bunch of different complex modern architectures. So one of the benefit of working with older technologies was that limited set of defined failure modes. Yes, things broke and things break, but in the previous times, you would pretty much know what broke at any given time, or you could find out quickly because of the common failure modes. But as the system becomes more and more complex, the possible failure mode also became more abundant. And we created monitoring tools to help us figure out what is going on in the guts of our software. So we kept track of our application performance using monitoring data and time series analysis over a period of time. But this process was manageable for a while. It got quickly out of the hand. And when we look at the modern systems, with everything turning into open source, cloud native microservices, which are running on a Kubernetes cluster, they are extraordinarily complex. And even going further, they are now being developed faster than ever. If you have seen the keynotes, Steve mentioned this, like between CI, CD, DevOps, agile development, and progressive delivery, the software delivery train is also speeding up day by day. And with this very complex distributed system being developed at the speed of a light, the possible failure modes are even multiplied. Like when something fails, it's no longer obvious that what caused it. We cannot keep up like with simply building applications or doing better monitoring. Nothing is perfect. Like everything breaks at some point, everything fails at some point. And the best thing we can just do as a developers is to make sure that when software fails, it's as easy as possible for us to fix it. And unfortunately, many modern developers don't know what their software failure modes are. Like in many cases, there are just too many of those. And even going further, sometimes we even have unknowns in our system. Means you won't put an effort into fixing something or some problem because you don't know that problem exists in the first place. So when we talk about standard monitoring, it is what the kind that happens after release. It cannot fix this problem because it can only track known unknowns. Like tracking KPIs or reporting performance, it is only as useful as that reporting accurately represents the internal state of your system or it determines the failure accurately. So we can say that your monitoring is only as useful as your system is monitorable. And this concept of monitorableness has a name, and we call it observability. So let's just put it into a definition and see how we can define observability. So in a control theory, observability is defined as a measure of how well internal states of our system can be inferred from the knowledge of the system's external output. So simply putting, observability is how well you understand your complex system. And metrics, events, logs, and traces, or melt as we call it, are at the core of the observability. But observability is about a whole lot more than just data. And like why we need it. Like consider your process of placing an order on Amazon failed due to some query timeout. So what characteristic did the queries that timed out at 500 milliseconds share in common? Maybe browser plugins or service versions, something like that. So here, instrumentation provides us the data, and queuing the data answers are some of the questions. So telemetry, a collection of a data from instrumentation, is a very important part when it comes to observability, as it aids observability in a way. And but we have to keep some things in mind, like telemetry data isn't observability itself, and instrumentation code is how we get the telemetry. So to aid observability use cases, your application needs to be instrumented in the first place. But basically, telemetry provides us the same underlying view into the same truth. So let's just talk about metrics, logs, and traces, which will help us transition into tracing itself. So first thing, metrics. Metrics are basically aggregated summary statistics, and they are so valuable because everything from operating systems to application generates metrics, and at the least, they are going to include name, a timestamp, and a field to represent some values. Since so many resources come ready to tell us about themselves, metrics are first obvious place to start looking into your monitoring systems. Whereas the second thing, logs are like detailed debugging information emitted by processes. And logs are perhaps the second most important tool in the monitoring toolbox because virtually everything logs information and like about what they are doing at any given point. And other than that, logs tend to give us more in-depth information about resources than in general metrics because if metrics show that resource is dead, logs will help us see like why that resource died in the first place. And our focus for today, the third thing, distributed tracing. Uh, Distributed tracing it provides insights into a full life cycle of a request, which happens throughout the system. Like traces allow you to pinpoint a failure or performance issue, and currently with so many application interdependencies, these operations will typically involve a number of hops throughout your system or multiple services, and those hops are what we call spans. We will see about this terminology in later slides. So traces add critical visibility into end-to-end health of an application. They are, however, like solely focused on application layer, and they provide limited visibility into health of the underlying infrastructure itself. So even if you collect traces, you will still need metrics to get the full story of your environment and logs to understand the problems. So APM tools feed trace information to a centralized metric store. So traces provide like a nice source of data for an app-centric view if you want it. So structured data can be translated into any of these forms like metrics, logs, and traces, and they all hold their own importance. But interconnecting them will help us make things easier as well. So let's just finally discuss about distributed tracing. Like that is why we were in the first place. So as I said, observability is all about understanding how transactions flow throughout the network and infrastructure. So if you consider a monolithic Java application, for example, like for just understanding, it's feasible to reason about the state and performance of the transaction. So if a client makes a web request, perhaps to a load balancer, to a web application or server, some database transaction happened in the backend, and maybe say some entry got created or record got updated, something like that, and the response is generated back to the client. So although there are hops in this entire process, this transaction is basically a linear path from client to server. Like client generates your request, which goes to load balancer, then A1, then A2, and maybe like at one point that just response goes back to client and the request got terminated. So it's hops, but it's still like a linear way. So it's quite possible to instrument each of the hops and visualize the state of the transaction and its performance to the monolith. But modern distributed system comprise several microservices. Like when we see something like this, it's a very complex entity. And even this doesn't satisfy our use case because this is not the actual system. The actual system will be distributed in a region way as well. Like in a real world use case, some services might be located in different regions and different locations. So you have to consider that thing as well. So when you look at this modern distributed systems, as we see, like these are very complicated. There are multiple transactions happening. Is maybe like several services are talking to each other, several services are talking to databases, and when you see distributed trace for this kind of a system, it's complicated. So ASIO service A calls service B, then service B might be calling service C, and then service C is replying back to service A or service B. So there are multiple transactions happening over here. And this lack of clear linear path makes it very challenging and tedious to track the transaction. It's often very hard to map a client's request to a transaction since there is no single service which we can map to. So relying on the traditional and the conventional tools for performance monitoring and bottlenecks might not provide us a clear insight on what exactly is going on where. So how is distributed tracing helping us here? Tracing tracks actions or events inside your system or inside your application. It records timings and collects information about the nature of the action or event, and it maps that to a trace. Like to effectively use distributed tracing, we need to instrument our code basically and to generate a trace, so it can generate a trace and for a particular action we want to monitor. For an instance, we want to monitor HTTP request or gRPC request, then you have to instrument that code itself. So the trace wraps the request and records the start and end time of the request and the response cycle. So putting it in very simple word, here, trace is literally a hop by hop map of your request. So, for example, booking a cab in the normal days, as you all know, comprises of calling several microservices like authentication, ride discovery, then pairing service, then calling APIs, payment service. So, these are several microservices you just call one after another to book a one cab. And these are just some I name. Like there can be thousands of services behind uh, one single request. So you can here you can see that a complete ride we can call it one trace, and all these intermediate service calls are hops, that is spans. And as we trace the journey of our ride throughout the system, we call it distributed request tracing. So why do I care? Why do I care about tracing, or why should you care about tracing? So tracing reduces time in triage by contextualizing errors and delays. It helps you visualize latency, like what time your service took, or for what time your service was waiting for other services. And it helps you understand your complex microservices like asynchronous code, or maybe like your very complex microservice architecture. It lets you see your architecture with live dependency diagrams built from traces. So let's just focus a little bit on terminologies here, and then we'll jump to demo for sure. So span is a primary component of a trace. A span represents a individual unit of a work in a distributed system. So spans usually have a start time and end time. First span in the request is called as the root span, and all the subsequent spans are called as the child spans. So here you can see that. So a trace constitutes more than one span. In our example, like as we have seen that complex microservice architecture, like BA2, B3, etc. were the request, and those were the spans in our trace. The spans are linked together via trace ID, which makes it possible to build a view of the complex life cycle of a request as it propagates throughout your system. So spans can also have user-defined annotations in the form of tags, and to allow us to add metadata to the span to provide assistance in understanding the where the trace is coming from, or adding context to it. Uh, it provides that functionality, so you can definitely go ahead and add your key value pair data to it. Then like if you want to know more about trace or read more about tracing, you can follow the open tracing documentation as well. It depicts the examples of typical span and illustrates it very easy way. So now we have this trace data like coming from our system, and what will we do with it? So with this trace data and its span and span context, all the data, it will be then supplied to backend where it will be indexed and stored. It is then available for queuing or to be displayed on a visualization tool, which we will see in demo as well. So this is how like let's just see, like this is how generally your trace looks like in a real world application. You can see like this is a trace for one single request to a particular API endpoint, and then like these are several spans for different microservice calls. So cool. So I guess we can jump to demo. We can quickly see a demo and then move forward. But before moving to a demo itself, I will just spend a little bit time on what the application we will be using for a demo, Hypertrace. So Hypertrace is a real-time observability platform that helps teams make sense of their production requests and trends in the network. It's a distributed tracing network. So Hypertrace converts distributed trace data into relevant insight for everyone. So infrastructure teams can identify which services are causing overload. Application teams can understand which requests put their service objectives at risk, and deployment teams can know if a new version is causing some problem. So Hypertrace accepts all major tracing data formats, which means that if you have already instrumented for Jaeger or Zipkin or Oten, you can try it without changing your application. You can directly you can use that default configuration, and still Hypertrace will be able to see and visualize your data. So we created Hypertrace at Traceable and open source it because we thought it will help a community a lot. And now we are seeing some traction over here, and community is helping us to make it one of the better platform for observability and distributed tracing. Cool. So enough talk. Let's just jump to a demo quickly. So if you want to check out Hypertrace or you want to try it out locally, you can just go over here, github.com/hypertrace/hypertrace, and you can clone this repo and try it out. We support Docker Compose and Helm installation, so you can either deploy it on your Kubernetes cluster or you can do Docker Compose up to it. This is an online boutique sample application which we will be using for sending traces to Hypertrace. Like this application consists of different start service, then recommendation service, payment service, and bunch of other services. So yes, okay. So I guess cool. So this was the online boutique application. We can generate some traces and uh, hello. I guess I'm hearing some background noise here. Cool. So when we send a data from our online boutique app to like Jaeger endpoint, this is your Hypertrace dashboard where you will see like various visualizations like visualizations like calls per second and error rate and all that stuff. In application, you'll see how your dependency graph looks like your front end service depends on bunch of different services, and you can see those here. As well as if you hover over any particular service, you will see all the details like latency, call rate for that particular service. It automatically identifies services and backends. So you can see like it identified Redis and SQL as a backend over here. Then, if you click on any of the service in the services panel, you will see a service dashboard, which is everything any service owner might ever need. Like if you can see that here, you can see what endpoints a service is talking to, and details about each and every endpoint, your top endpoints, then your health radar, then again error metrics, call per second metrics, and latency metrics. If you click on the endpoints, so you will see bunch of different endpoints for your application. Click on any of the endpoint and you will see endpoint dashboard, which is very similar to the trace dashboard we had with all that information. And these are all the traces from your particular endpoint. So if you click on any of those, you will see that you will see the spans for that particular trace. And if you go and click on see full trace in the top right corner, you will see the full trace for that particular endpoint. So here we are seeing that recommendation service is taking quite some time, and maybe like we will need to do some performance optimization there. So the problem isolation over here became easy because we can visualize latency very well, and we can see like what service is taking how much time, and we know it should take that time or not. So this is kind of cool application if you are looking for how you can use tracing. Then there are again separate metrics tab for detailed metrics for your endpoints. Then same thing for services again. So for from service dashboard, you go to traces and you can see traces for your service. There are various filters available. You can slice and dice on your traces. So if I set a duration greater than 300 milliseconds, I will get all the traces with duration greater than 300 milliseconds. If I click on any of the trace, I will see the detailed trace view for that particular call, and I can again the same thing. I can visualize latency. I can see what which service is taking how much time. I can see spans and trace for that particular call. Again, detail metrics for service, each and every service as well. So in the backends, we have we identify backend by default, so you can see detailed metrics for backends and traces as well. So in the Explorer, it is kind of like a SQL playground for you with visualization. There are a bunch of different filters. You can choose from any of the filter, and you can apply it, like you can slice and dice using these filters on your traces. Uh, so if I want just protocol traces with the HTTP protocol, I can just click on a protocol. I can go set protocol to HTTP, and once I apply that, I will get all the traces with only HTTP protocol. So here you can add group by, you can add like you can use bunch of different filters and pinpoint your requirement. So you can also change the duration. You can add any custom duration as well. So that's there. Cool. So that was kind of all about hypertrace. Like that, this is how the generally tracing helps you, and this is how generally the tracing platform looks like. And uh, Hypertrace provides you this different features on top of Jaeger, Zipkin, and Hotel, like topology, dashboard, extensibility, interoperation operational way to perform the tracing, GraphQL APIs, and API and trace analytics. So if you are interested to check out Hypertrace, you can surely go and check it out on GitHub. And we have a Slack community. So if you want to contribute to Hypertrace, as it's open source, if you want to use it or try it out, you can join the Slack community for sure, and we will be happy to discuss around distributed tracing and Hypertrace with you. Then the Google Slides for this are available on this. Like you can just scan this QR code and get the slides as well. So thanks for joining in, and thanks the DevOps community for having me here. Like really grateful to be here with all these uh, great speakers and so many attendees. So if anyone has any question, or if you want to ping me, or like talk to me about something, you can mail me on jayesh.iv@traceable.ai, or ping me on Twitter at jayesh_iv. So thanks, guys.
Thank you very much, Jayesh. Now you can meet your audience in Zoom room to discuss all the questions, and thank you very much.
Cool. Thank you.
And now, guys, I'm happy to invite our next speaker. It's Robin Moffat.
Countryside to go walking and stuff like that. And I promise this is relevant to my talk because nearby to here, there's a city called Bradford. And Bradford's kind of like where you drive to if you're going to go shopping or go to cinema and stuff like that. And so when you go to
Okay, guys, I'm not sure, am I on the air? Yes? Okay, if everything is okay and we checked our technical issues, I'm happy to invite our next speaker. So, Robin Moffat, if you have already joined us, welcome, please.
Okay, do you hear me?
Hi, one more time, Robin. Please try to remind that you said earlier because we had some technical issues. So, how are you today? Are you ready for Devoxx?
I'm all ready for this. This is great. So you can hear me and see me thumbs up. Am I good to go?
Guys, one more second, Robin. If you are ready, you can start.
Okay, so let's go for this again. So my name's Robin Moffat. Welcome to our session. Today I'm talking all about Apache Kafka and building Telegram bots. And so I want to show you how you can take this idea of being able to find out information about your nearest car parks. So I live in this lovely place called Ilkley. It's in Yorkshire in the north of England. And Ilkley is a lovely place, but there's not tons of like big shops and cinemas. So often I'll need to travel from Ilkley to my nearest city, which is a place called Bradford. And so I'll sometimes drive there, and on the way into Bradford, I'll be thinking, which car park am I going to stay in? Because obviously that's the kind of thing which is on your mind when you're in a car. And I wonder which is my nearest car park that's actually got some spaces, or how many spaces are there in my favourite car park? In fact, maybe there aren't any spaces available, so can you tell me when there are some spaces available? And it's interesting to know if you want to like analyse these things like data geeks do, how do the car park occupancy vary over time? So I'm a developer advocate at Confluent. Confluent, one of the companies behind the open source Apache Kafka project. And I want to show you how you can take data from an open endpoint. So there's open data in the UK. This one comes from the Bradford Council. And use this stream of data, streaming it into Kafka, and then serving it up through Telegram as a platform. So let me show you in action, and then I'm going to walk through in the time that we've got to actually show how we've built it. So I'm going to head over to here, and on the left-hand side is just like the bot itself that's running. So you'll see the various diagnostics that are going on. And on the right-hand side, we've got Telegram. And Telegram, many of you are familiar with this. It's a messaging platform, just like WhatsApp and Facebook Messenger. And it's got a really good API that you can write bots against. So as my user, sat in their car and either on their laptop, or Telegram's obviously got a mobile client as well, you connect to the bot and you say, right, I'm going to start talking to the bot. And the bot says, okay, here are the different things that you can do. And on the left-hand side here in the bot's back end, you can see we've received a message from the user, and it's this command saying start. So the user can do things like say, well, I would like to know where my nearest car park is. So I'm going to send you my location. Let's do this. And we say, well, my location is here. We're going to send this location. And the bot is going to say, okay, let me go and find out, based on that longitude and latitude that you've told me that you're at, I'm going to find out which car parks there are, where they're at, and like as a crow flies, which one's the nearest to where you are that's got some spaces available. So this is a live demo, so you have to kind of like sit and drum your hands a little bit, because these things don't always work first time, but this one fortunately has. And it says, okay, here's the car park. It's a place called Westgate. It's got these many spaces free. It's like, that's pretty useful. So it's got 103 spaces free. And like here in the UK, we've just locked down again. So there's going to be a bunch of people working from home and not driving into cities. So I'm guessing there's plenty of car parks with lots of spaces free at the moment. But we can also do stuff like this. We can say, well, I would like to know for Westgate, has it still got however many it was, 103 spaces free? Has that changed or not? And it probably hasn't, because the API only refreshes every 3 minutes or so. But we can say, okay, tell me for Westgate how many spaces there are. This is okay. At this particular point in time, so this is Greenwich Mean Time, UTC, there are this many spaces available. So as well as being told, like, here is your nearest car park, we can say, well, go and do a stateful lookup against the information that's streaming into Kafka, and just do a lookup against that information for a particular key. And we could do something like say, well, actually, I would like to know when a car park becomes available with a certain number of spaces available. So let's say I would like to know when there's a car park with more than 500 spaces. So we've created this alert definition. And now when data's received by the bot from the API, which I'm just going to trigger now, we're going to get a feed of data, and we now get event-driven notifications. So here it says, well, here are the different car parks within the area that are kind of like near to you, and they've all got more than 500 spaces. If I change that alert, and we're going to say something like, show me when there's, let's say, alert 10. So when there's 10 spaces, we're now going to get a ton of different car parks coming back, because there's lots more car parks. So you can define a threshold, and this is actually on the left-hand side here, you can see it's actually expressing it in SQL itself. So this is the kind of thing that we're going to build. In a way, it's a fairly silly example because you kind of know where the car parks are and stuff like that. But being able to take a stream of data and interact with it as a user and say, like, tell me when a condition occurs. So like you can do event-driven alerting. So when an SLA threshold is hit in your monitoring data, or a certain number of orders get placed within the last hour, tell the user about it. Or we can do lookups against that data that's in Kafka also. So let me show you how I've built that. I'm going to kill the bot for now, because otherwise we're going to keep on getting messages popping up in Telegram. So now let's see how it's actually built. So this is what I'm going to be showing you. And the code itself is all on GitHub, so you can go and try it out. But what we're doing here is we're building this thing out. So we're taking data from the source API, streaming it into Kafka, streams into a Kafka topic. We're going to do a bunch of processing, which I'll show you. And then we've got our bot, which is written in Go, which interfaces with Telegram. We're also going to stream the data over into Elasticsearch so we can build some analytics on top of it. So the code, as I say, it's on GitHub. I'll share the links on Twitter and anywhere else I can share them afterwards. But you'll see me kind of like looking up and down because I'm going to move this onto my bottom screen here so I can actually show you this all in action. So to get the data in, we're going to use the REST API of the information source itself, and we're going to just use curl to ping against it. So we're going to say, show me the data, and it's actually just comma-separated information. I'm piping it through tail to strip the header off because we've got the different names of the fields and stuff in there. But you can see here it's 6th of November at 8 minutes past 1 in the afternoon. Here's the car park, here's the capacity, here's the number of spaces. And we're going to take that information and we're going to stream it into Kafka. So this is not kind of like a production-ready pipeline. This is kind of like useful for prototyping, useful for building demos, but we're actually going to say take the output of this statement and pipe it into a Kafka cat. And Kafka cat integrates perfectly with the Linux pipelines philosophy. You can pipe data into it from standard out, and you can take consumer from Kafka cat and pipe it out of there and take the standard out into another standard in on another application. So we can actually do something like this. We could say, let's take our command, and we can consume from that topic that we've just loaded to check that the data is actually there. So we're saying, take the data from this Kafka broker, from this particular Kafka topic, -c, consume it. Now it says, here is the data that sits in that topic. And if we tell it not to put it, it says, here is all of the data that's in that topic. So I'm going to set this running, doing a little polling loop. It's very hacky, but it's actually going to do the job for us. We're going to say, do a forever loop in bash, do this. So pipe that information from the API into this Kafka topic, and then just do it every 3. So let's change that because it's going to make for a more interactive demo. So every 15 seconds, we're going to get a dump of data of the current state of that API. And it's just going to echo it to the screen here because we use the -t flag in Kafka cat, which says send it to the topic, but also write it to the screen. Now, let's go and work with this data. So I'm going to use a tool called KSQLDB. It's part of Confluent Platform, it's community licensed, and it lets you do stream processing on your data in Kafka. So take a Kafka topic, transform it, enrich it, join it to other things, write it back on another Kafka topic. It also lets you act as a database. So when I was doing those lookups, saying how many spaces does this particular car park have, this is looking it up against KSQLDB. So it's built on top of Kafka, and it builds these materialized views of the state on top of a Kafka topic. So it's pretty cool because it means you can build applications without needing to kind of like take your data and go and stick it into like a NoSQL store or a relational database somewhere else. You can actually have that event streaming database on top of Kafka. So with KSQLDB, we're going to take our stream of data. So I'm going to say show topics. What data do I have in my Kafka cluster at the moment? It's got a topic called car parks. I can say print car parks from beginning, show me all the data that's in it. And this just acts as a consumer. And it says, well, here's your data. It doesn't have any key. It's got these particular values. And we're going to declare what's called a stream on top of that data. A stream is just a Kafka topic, but it has a schema. Because we're working with data, data's got a schema. Schema acts as our contract between our different services that we're writing. So we declare that schema, because at the moment it's just comma-separated values. So we say it's got a date and it's a varchar, it's got capacity, which is an integer, it's got latitude and longitude, which are doubles. Take that schema and apply it to this topic, and the value format, it's delimited data. We could put this on top of JSON data, we could put it on top of Avro data, protobuf data. However you've serialized your data, you can ingest it and use it within KSQLDB. So we create that stream. It says, okay, I've gone and created that stream. And we say show streams. And it says you've now got a stream called car park source. So let's have a look at the data in that stream. Now the data in that stream is the data that's in the topic, but with a schema applied to it. And because we've got a schema applied to it, it means we can project fields. We can say select this field and that field from this place and show me the data, just show me the first 5 rows. So we do that, it says, okay, here are the first 5 rows. And we've got that particular car park there, it's got this many empty spaces. So as the data's arriving in from our source, which is polling that API, piping it into a Kafka topic, we can see that it's flowing into our Kafka topic, and we can apply that schema and those field projections. Now what we're going to do is we're going to take that data, we're going to transform it and write it back onto a new Kafka topic. So we've got source CSV data, which is fine, and it's the starting point for a lot of pipelines and applications, but we want something better than that. We want to derive some fields. We want to be able to do things like say, well, instead of two strings here, one string describing a date and one string describing a time, let's actually make this a proper timestamp and give it a time zone and store it as a timestamp native format. We can also say, well, it's in delimited format. We've had to manually type in the schema. Let's serialize it onto a new topic using a serialization format that supports schemas natively, like protobuf. Because that means that anyone else using that data, whether it's ourselves subsequently or any other application, they now have access to the schema. They don't have to type it in. So we're going to do this. We're going to say create a stream. And this stream, again, is a Kafka topic. And we're going to serialize it as protobuf. And we're going to say take our date and time and convert it into a timestamp. Here's our format. It's a London time zone. We're also going to start deriving different fields. We're going to say, well, let's work out the percentage full. If we know the capacity and the current number of places occupied, we can work out the percentage full. So do these calculations. We can also change the schema of the data that we're writing. We can say, well, take the latitude and longitude and write it as a location object, as a struct, because this actually makes it easier to use downstream. That's logically one object, it's a location object with two different fields within it. And we can also add some metadata, kind of lineage, and working out where this data came from. So we're going to create that stream. And when that stream's created, we'll see that it's actually going to have populated a new topic. So if we say show streams, we've got a stream here called car park events, backed by a Kafka topic called car park events, and we could change that if we wanted to, and it's in protobuf format. If I say show topics, we can see we've got a topic called car park events. And I could also run a consumer against that and say print car park events. It says here is the content of that particular topic. So now we're just running a consumer against the topic, which is being populated continually by that create stream statement. If we just remind ourselves what that looked like, it said create stream as the results of this select statement. And because that select runs against the source stream, which is a Kafka topics are unbounded and continue ever. It's kind of like an infinite stream of events. Therefore, KSQLDB queries, when they run against these streams, are all unbounded. They're continuous queries. So we're saying create this new stream here, populate that target stream with the results of this continuous query. So as every new event arrives in our source stream, which is our source topic, take that event, modify it, and write it out to this new topic. Oops, so we don't want to do that. We don't want to crash the thing because that's a shame. So let's instead restart our client. And once we've restarted our client, we can actually take data and we can start to transform it even more. So over here, my computer's on a bit of a go slow. So we're going to say streams. We've got a stream called car park events. And now we're going to take that stream of information and we're going to build a table on top of it. So far we've taken an inbound topic, we've transformed that topic and written it out to a new one. Now we're going to say, let's take that enriched data with like the struct that we created and the timestamps that we sorted and lineage information, take that and build a materialized view of the state on top of it. So within that, we're going to say, let's set the offset to the earliest, so process all of the data that we've got in that particular topic. And now we're going to do this. Create a table as the result of this select statement. So this statement here is saying create an aggregate. So we're going to group by the name of the car park. We're going to take the latest timestamp, the latest capacity. We're also going to say the average emissions, and the rest of them are just like by offset. So this is the aggregate saying just store the latest value of all these different things from our car park events stream and group it by the name of the car park. So we do that and we now have got a table. So KSQLDB, we've got streams, and streams are Kafka topics, unbounded series of events with a schema. Tables are also Kafka topics with a schema, but they are the value for a given key. So in our case, this table, the key is the name of the car park, and it's the value. And that value is going to change, but it's going to change in place because it's key value. That's what a table is in KSQLDB. So we can actually query that table. We can say select the latest timestamp, the number of empty places from car park, which is our table, where the name is Westgate. So that's the same one I used earlier when I was running the Telegram bot. And you can see here, so the empty places, earlier it was 103, now it's 105. But you'll notice it says, okay, here is your answer, query terminated. This is what's known as a pull query. This is what the bot was actually doing. KSQLDB saying, select this value from that materialized view that you've built and return it to the user. It's a pull query. It's pulling the value out. So you can calculate these averages and the latest and the sum and the average and all these kind of counts and any other aggregation that you want. And you can store a table, a stateful table, and it's distributed and resilient. And you can query that from your applications. So I'm using the command line interface, but there's a REST API, there's a Java client, there's a kind of community Go and Python clients as well. So you can actually do those lookups against those streams of data. We can also do what's called a push query. So with a push, we're going to take kind of like an event-driven approach to things. So here, we're going to say, tell me, we're going to take the example of like, tell me when there's a space available. So we say, select the name of the car park, the number of empty places, and now we're going against the stream of events. Because in terms of alerts, you want to know based on each event. You don't want to look at kind of aggregate overall. In this case, you're saying, when something happens, evaluate it against this predicate. And if it matches this predicate, then tell me about it. And you'll notice at the end here, we're saying emit changes. So rather than just saying select this, and then that's it, and the query terminator, and off it goes, and it returns it back, emit changes says, well, this is what's called a push query. This is a continuous query. So this now goes to our source data, and it says, well, we're going to start from the beginning, we set the offset to the earliest, and now we're going to return every single value that matches this, and then at the bottom down here, press Control-C to interrupt, because it's going to keep on running. And as every new value arrives, so like if you remember, we've got that source polling of the API here. Every 15 seconds, it loads it into the topic. And so that means that in KC, we get to see that every single time it changes, you get a new result echoed out onto the screen. So that's what's called a push query. And again, you can integrate with that using the REST API, using the Java client, using a Go client. So from your applications, you can do both queries, kind of like event-driven notifications, as well as stateful queries against the in Kafka. I'm almost out of time, so I'm going to head over to here and just show you a couple more slides to talk about what we've done. So this is what we built out. We said we've got data coming in from our source, streaming it into Kafka. We used a bit of a hacky approach just to pipe it in into a topic. We transformed and enriched it into a new topic with KSQLDB, which we then consumed with our Go client, echoing it out to Telegram. The Elasticsearch thing, let me show you super briefly just to prove that it actually works. You can also stream that data over into Elasticsearch and build a Kib dashboard on top of it. So you can say, well, we've got that longitude and latitude that we built into the objects, so you can actually plot maps based on that data and analyze the data based on it within that. And then we said, what we're going to take within that are some different principles of how we're building applications. So we've got event-driven alerts. So we can say when something happens in this data, then tell the user about it. We can also do lookups against the state of materialized view, which returns straight away back to our client, so Go or Java, whatever you're writing your applications in, out to the end user. And we also applied a schema to that CSV data and re-serialized the data onto a new topic using something like Protobuf or Avro or whatever we'd like to do. So let me share you a couple of resources. And if you follow me on Twitter, I'm at armoff on Twitter, so you can see my handle at the bottom right there. I'm at armoff. I'll tweet some links after this. There's a fuller version of this talk if you'd like to follow it. There's also a blog about it. But I'll finish off by just showing you a couple of these. So there is the demo itself that you can find on the demo scene repository. It's a Confluent repository. So scan the QR code or go to that URL, and you can actually clone the repository. The API is open, so you can try it out for yourself. Go and sign up for Confluent. The demo I'm showing you here, it's actually running on Confluent Cloud as well. So you can then use that as your managed Kafka service. And then head over to developer.confluent.io, where you can find lots of tutorials and podcasts and videos for learning lots more about Apache Kafka and Confluent Platform. So with that, thank you very much. Follow me on Twitter, look me up on YouTube as well. And I do believe we're heading over to Zoom for questions now. Is that right?
Yes, thank you very much, Robin. You are right. You should go to Zoom room to communicate with your participants here and answer all the questions. And you guys, if you enjoyed the speech, you can go to our mobile application and push like button for Robin's speech. Thank you. Bye. And next we'll have a presentation from our gold partner company NX.
Since 2002, NX has been a trusted software development partner for global industry leaders and Fortune 500 companies. NX offers expert solutions in cloud computing, data analytics, machine learning, business intelligence, IoT, and other tech domains covering various sectors, including fintech, telecom, media, healthcare, manufacturing, and more. Numerous industry rankings recognize the company, such as Global Outsourcing 100, Inc. 5000, CRN Fast Growth, Clutch, and Good Firms. Also, NX is a place for professional growth and exciting career opportunities for more than 1,100 experts. The company hires talent remotely across Ukraine and offers a flexible work format to choose between office-based, flexible, and fully remote work. NX is one of the most active employers in Ukraine, according to Dole, as it constantly has around 100 open positions. Join NX. Grow your career with one of the fastest-growing IT companies by your side.
Hello, we are glad to welcome our gold partner NX company and its representative Maxim Polomarenko, Director of Software Development Office. Hello, Maxim.
Hi, nice to meet you. Hi, everyone.
Nice to meet you.
So I'm happy to be at the conference and have a chance to talk to you, share information about our career growth and opportunities at NX. But as I was asked by organizers, just a quick reminder that we are also having a contest and this beautiful toy. So while I'm speaking, you still have a chance to register in your personal cabinet and maybe win this nice prize. So a few words about our company. So today NX is one of the fastest growing IT companies in Europe. Between 2016 and 2019, we grew by 330% and reached 1,000 professionals. In 2020, despite the worsening business climate, we still keep growing and reached 1,100 people. NX has also formed a strategic partnership with a variety of global industry leaders, including such recognized names as Libara, Currency Cloud, Fluke Corporation, GoGo, TuneIn, several Fortune 500 companies, and over 100 medium large-scale businesses. Only a small number of them are currently on this slide. And we hire talents remotely across Ukraine and the world. The company has 7 offices in EU and United States. In Ukraine, we have 2 large offices in Lviv and Kyiv. And for those who used to work office-based, now we have a new system of working, and it proved to work. This flexible working schedule, office-based for those who work 4 days and more and have dedicated place, flexible with shared place, and fully remote for those who enjoy working from home and still have benefits of all company services attached to them. Also, we are building NX hubs across Ukraine, uniting our communities in the cities where we are represented. Our vision for the future is to have 1-floor office space in 5 cities instead of 5 floors in 1 city. So we are starting with Dnipro, Vinnytsia, Zaporizhzhia, Odessa, and going to be represented in other cities of Ukraine, where our community really grows. A few words on how the professional growth is working in our company. I am the man to talk about it because we are responsible for the experience of engineers and the company. So it all starts from the day one when the engineer enters the company already having assigned the level after the interview, and he or she starts to learn career opportunities. Then they choose core competence from the profiles available, and all the profiles are deeply described within our competence model. They set up their career targets to level up and have the tools for instant and qualified feedbacks. These are performance appraisals from their teams and on-demand technical evaluations, which are conducted by our specialized expert trained for these purposes. The expert goes through the whole detailed competence model and gives feedback on any gaps found out, and also mentions the ways to cover those gaps to speed up growth. And we have lots of tools to speed up that growth. So these are personal development plans, competence model with the links to the best resources to learn new technologies. Also, trainings and mentorships available here, as well as external certifications, which we fully support from global vendors and providers. Those who receive promotions, they actually not only promoted by technological level, but we also invest heavily in leadership skills, because with the new opportunities go some additional responsibilities. So leadership skills is something our engineers also gain with each level up. And once they are promoted, they have opportunity to share their successful experience with internal Tech Talk platform. Also, they contribute to expert services, the same mentorship, expert networks, and also they may participate in R&D, pre-sales, and many other opportunities. That's all works on demand. Going back to Java community at NX, we have quite a few people from Java crowd here. So about 100 engineers by my latest calculations, and this includes web development, backend development, as well as Android. And they are spread across, I think, more than 50 projects with which have some kind of Java technologies. To name a few prominent names of those projects is a Fluke electronic test tools manufacturer, and they have very interesting technologies there with microservices, microkernels, as well as hexagonal architecture, and they integrate with PLC, SCADA devices, IoT, enterprise mobility. Very interesting tasks and challenges that they solve. Also, I can name Libara, a well-known British telecom, which we have about 12 agile teams working on, and some of them are Java directed. They develop a range of very different solutions, starting from Hybris CMS and also including very complex and challenging integration tasks with messaging payment solutions across different countries of Europe. And to name another prominent name, this is TuneIn, audio streaming platform. Probably you use it also. And our Java team is working with high-load APIs there. So that's definitely interesting to work with our Java projects. But we not only work, we also have fun. So we still have team buildings despite we keep social distance from each other. For example, in August we had company day online. Each of us received small packages with gifts and had an opportunity to raise a glass of wine, beer, or any other drink and stare at eyes of hundreds others simultaneously celebrating online. This was a new and very exciting experience. And we are one of the most active employers in Ukraine, according to the DOE, and we constantly have around 100 open positions. About 20 of them are in Java direction, so stay tuned. And check out our career website to find something interesting for you. Also, you can recommend your friend for an open position at the company and get bonus. All our hot vacancies have special referral bonus or referral bonus labels. And thank you for your attention. Visit our social media channels. Find out more about our lives, work, and here you can see and use the links about our Java NX communities. and hear what people say about Java here and the company. So thank you very much, and have a great days here at the conference.
Thank you, Maxim, and thank you once again, NX company, for supporting Devoxx Ukraine Online this year. Yeah, and dear participants, I just remind once again to register for the prize raffle from NX and to be the lucky ones to win their special prizes. Okay, and just in a minute I will invite our next speaker, Brian Vermeer, who will join us from Netherlands.
Hi guys, one more time. Hi, we are on the air one more time, and I hope you enjoyed Devoxx because I'm ready to invite our next speakers. It will be three of them: Ottavio, Santana, Werner Kyle, and Sodoris Bais. Hi guys, welcome to Devoxx.
Hi.
Hi.
Good afternoon.
Are you ready to impress our Devoxx audience 3 times during one speech?
Absolutely. We
Yes.
are definitely ready.
Oh.
Great. So
Right.
enjoy your
It's,
time.
I see Ottavio got a Disney-related T-shirt, even though it's not Marvel, but it's close.
Okay, guys, you can start.
Not
Enjoy your
worry.
time on Devoxx.
Great. Cool. So, first of all, are you able to see my screen?
Yes.
Yeah, we do.
Great. Cool. Thanks a lot, gents. So, it's about time, right? We're gonna talk about the NoSQL endgame. Of course, we are with the three of us, and the information we have to share is quite some, and the time is quite limited. So, with no further delay, let's quickly meet. Werner, first of all, who are you?
Yeah, I have my own company with clients across the world. I'm also the Jakarta EE Specification Committee representative for committers, and I'm leading various other open source projects or JSRs, including units of measurement or money.
Okay, that's cool. A bit of introduction about myself as well. Theodoris Bais, or Theodoris Bais in English, originally from Greece, living and working in the Netherlands for the last 5 years as a Scrum Master for the ABN AMRO Bank for the last 2 years. I'm also the founder and leader of the Utrecht Java user group, and really looking forward to this talk today to share information and to see what and how we can get the best out of it. Ottavio, what about you?
Hello, everybody. That's amazing to be here. My name is Otávio Santana. I'm from Brazil. Right now, I'm dev hell engineer from Platform SH. Platform SH is a cloud company who provides an easy way to you take your application, move to cloud. Therefore, we don't need to worry about the huge complexity to handle about cloud, such as security, this kind of details. I'm Jakarta E member. I'm also JCP executive member. And again, that's amazing to be here to talk about NoSQL.
Yeah, right. So before diving into the actual presentation, I also have one marketing slide. It will be the only marketing slide. So as I mentioned, I work as a Scrum Master for the ABN AMRO Bank, and nowadays we're moving towards a future-proof and sustainable bank. So in case you're interested in any kind of openings, vacancies, development opportunities, feel free to reach out to me or check our website. Now, Enough about it, just on marketing side. We're not about marketing here though. It is 2020, right? And it was quite a year, I would say. So let's start by having a look at the 5 main trends of 2020. First of all, nowadays more customers are going online, right? Which means that which brings us actually to the second trend, which is that the internet is nowadays connecting everything. A third trend is also that big data is getting bigger and bigger. Fourth trend, apps are moving to the cloud, and we will see more about it later on. And fifth and most important trend nowadays is that the world has gone mobile. Okay, cool. What does this mean though for us and the reason we are here today? It basically means that new digital trends create new technical challenges. So, I'm pretty sure you might be already wondering, what are those technical challenges exactly? First challenge is of course to develop with agility, right? Second of all, we need to operate at any scale. And third, to deliver the performance and availability required to meet the demands of digital economy businesses. Okay, we slowly start unveiling the entire NoSQL thingy, right? So what are those advantages that NoSQL brings us today? Once again, first of all, NoSQL can handle large volumes of data at high speed with a scale-out architecture. One of my favorite ones, though, it is that it can store unstructured, semi-structured, or structured data as well. Werner will tell you more about it as we start looking more, or as we start delving into the actual NoSQL thingy and how it works. Third advantage of NoSQL databases is that it enables easy updates to schemas and fields. And fourth, and most important one, it is that it is quite developer friendly, which is what we want nowadays, right? So that was it, right? No, I do have a fifth one as well. It is that they take full advantage of the cloud to deliver zero downtime. Okay, so we started with having a look at the main trends of 2020. We touched a bit upon NoSQL databases, but what is the rationale behind this talk? Why are we here today with the three of us trying to cover such a topic? First of all, the JVM can cope with heavy loads, right? And of course, there are quite some persistent frameworks for Java persistent frameworks for the NoSQL databases out there. However, here comes the question, which one of them performs best for your case? Now, it would normally take this for you to compare all those Java persistence frameworks against the different NoSQL databases. So we did it for you, and that's why we are here today. That was the introductory part and the rationale behind this talk. So Werner will now take you further, or will take you to the beautiful world of NoSQL databases, how they work, how they operate, and so on. And with that, Werner, it's over to you, and I will stop sharing my screen for now.
Yes, so what are NoSQL databases about? They usually don't have a unified structure. There are no transactions. You have the base principle, and there are at least 4 major types. First of all, there's key value, with examples like the Amazon solutions, Redis or Hazelcast. Then there are column-oriented, which are a little closer to what you might know from traditional relational databases like HBase or Cassandra. Document stores that use a document format like JSON or XML. For example, Apache CouchDB, MongoDB, or Couchbase. Then we have graph-based systems like Neo4j or Hypergraph. These are, of course, more sophisticated because they allow relationships not only between two tables, but between multiple objects. We're going to see that in our examples, how that can be used as an advantage. And then there are the shapeshifters, if you want, that cover more than one. For example, OrientDB supports both graph and document. Couchbase, in addition to document, also allows to use key value, and a few others that sometimes allow to use up to 3 different types, even in the same application. The key principles and terms in SQL are table, row, column, or relationship. In key value, there's a bucket, and of course the key value pair. Column-based also have the column. That's probably the main similarity with SQL. And documents have a collection, documents, again, a key value pair, and links to other documents. It's a bit like hypertext or the World Wide Web. And in graph, you have a vertex and an edge, or also nodes in some cases. The two principles of base and acid are basically available: soft state and eventual consistency, while acid stands for atomicity, consistency, isolation, and durability. Now let's look at some popular systems from the CAP perspective. Again, consistency, availability, and partition tolerance. And here you see that there's an overlap, while some of the systems go more in one or the other direction. The same with scalability versus complexity. Key value systems can be very scalable, while graph-based systems are usually the most complex ones because they offer additional types of relationships and graphs that the others don't. In a relational database system, you usually have the logic tier, then a data access object, then a layer like JPA, and different JDBC drivers underneath. With NoSQL, that's of course very different because each of them have their own APIs that may often be not compatible with each other. So when you switch from one system to another, or you want to support multiple, then you will often need to have n different APIs that also work differently and have an extra learning curve for your developers. So we compare 4 major frameworks: Spring with Spring Data, Micronaut, where we'll come to that. Micronaut Data does not fully support NoSQL yet. Jakarta NoSQL and its implementation JNoSQL, and Hibernate. Under Micronaut, we also look at Gorm, which can be used in multiple different containers. And for the sake of simplicity, we're only going to look at Neo4j, MongoDB, and very quickly with Jakarta NoSQL, also Hazelcast. Here are some of the others, but because we have 3 speakers and not so much time, that's why we are going to cut it a little short and not show all of them, but in our demo repository, you will also see examples for many major NoSQL systems. So while JPA works pretty well for relational databases, there are some problems for NoSQL. Asynchronous access and callback, time to live, the level of consistency. It's very SQL-like, while in NoSQL you have a large diversity with sometimes even different types of query languages. What most of these frameworks have in common, although they sometimes have slightly different names, is annotated entities with an annotation like entity, or in some cases you may also see others like node for graph databases. Then annotations for columns or fields. Most of them support the template pattern. Here's an example for a document template. As well as the repository pattern. Here again from Spring Data, but most of the other systems, especially Jakarta NoSQL, also support them in a very similar way. Both Spring and Jakarta NoSQL use a dependency injection mechanism. Here you have the Jakarta inject framework and spec, which actually also works underneath the hood in Spring. So you could use at inject, although Spring has its own flavors of annotations, but most of them are pretty compatible with at inject. And then the specific annotations like database. One of them for the type of column based and the other one for key value. The repository pattern also allows to inject and embed queries. And there's diversity by supporting specific annotations. Here we have two examples for annotations that are specific to Cassandra, while the other ones are general purpose and therefore also interchangeable between different systems. We allow query by text for selects that are closer to, for example, direct native queries in JPA. And I will show all the live demos together, so I don't have to switch back and forth too often. So the next candidate and contender is Micronaut. As mentioned, Micronaut also has Micronaut data. It's very much inspired by Gorm, which we're going to see next. In fact, it's actually driven by the same authors. In Micronaut, there's a repository, although it doesn't have to be annotated in some cases because it's not yet supporting Micronaut data together with NoSQL. So some of that may change as soon as Micronaut data also supports NoSQL. At the moment, you have to do it with the lower level APIs for each individual system. Here, the same goes for the entity. So you can pretty much use a POCHO. And there's query by text. In this case, the example is for Neo4j. And then there's Gorm. So Gorm comes from the Groovy and Grails world. It was created by mostly the same authors who also contribute to Micronaut. And with Gorm, it's a little similar. It has various supports for different systems. Including several NoSQL databases. The entity here again is annotated, so it's a little closer to the others. There's no real repository, so we'll show that in the demo that Gorm, a little similar to what Todoris is going to show you in Spring Data, it has a stronger focus on the controller, where a lot of the querying is actually done in the controller. So now let's look at the code. We have a couple of very quick examples for Jakarta NoSQL. First, a repository for a user with the Hazelcast system. So these are in memory, that's why they usually work pretty fast. In some of them, you don't even need the actual system installed because they're embedded through Tinkerpop. In others, you will have to install, for example, MongoDB. So here the black text is the actual query. The rest is some metadata by Hazelcast itself. And the same application with a template is actually very similar. You see there's almost no difference except that you have a key value template instead of a repository. I won't run that now because it will take a little too much time. But let's run a MongoDB example.
I can only see the slides still, not the screen, not your ID.
Oh, so who's sharing?
Maybe someone from the organization can help? Or maybe, Werner, you can reshare your ID?
Yes. Okay. Yeah, it looks like it was actually Ottavio's screen or somebody else's screen, or maybe they did the swapping. So let's go back to the repository because it couldn't see it first. So here we have the repository example using a repository approach and the repository pattern with Hazelcast. The same with a template. And to save a little time, I already run the next one. So here's the same with the repository as well as template for MongoDB. And you see there's almost no different way, simple examples. So you can use either one. And here we see the query of inserting some God objects and entities and creating relationships between them and then running the query. And after we delete them, the query shows no results. Then one more type of database is the graph database, which actually looks a little different because you can do fluid queries and also use lambdas here, for example. And since the relationships in the graph database are more sophisticated and can basically be end-to-end between lots of different elements, that means, of course, the code is a little different. And the API here also offers some more options. So here are the examples for some of the main Avenger characters and Iron Man characters traveling around the world. Let's stay in the IDE, and as promised, I will show you the controller. You already saw the entity using GORM on the slide. So here's the controller, and you see that a lot of the magic is actually happening in the controller, including there's a transactional annotation and also the actual operations like get all users or get a particular user. This happens very much in the controller. So for Neo4j, because the relationships in the graph database are different, let me quickly show you some of these objects. So we had the cities that I actually used in more than one example. We'll also see them in Micronaut, but I will show that in Postman so you can see the results. And here are the relationships between the different gods in the god example. For example, you see that Thor is the father of Magni, but the stepfather of the hunting god Ullr, and Odin is Thor's father. So you could also have additional relationships if you want, like for example, Odin being the grandfather of Magni and Magni being the grandson of Odin. That would make the graph a little more complex, but I guess you get the idea how you could use that even more extensively than in this example. And here we have the travelers from the travel example that you just saw. So in the GORM example using MongoDB, most of those are already prepared. So here you see the list of all users. I won't add yet another user, but I added this user the other day, and you see that there are 2 users. And if you want to show just one user by user ID, then you get a particular user. We won't cover the others because that would take a little too much time. Now the God example in the MongoDB database variant also shows you all the gods that exist, their number. And now here we see all the gods. The only reason why some of them are duplicated is because the database is shared between two different examples. So we inserted some like Tor and Ullr also from Jakarta NoSQL, and they already existed from the Micronaut example. That's why you see some of those as duplicates here. And then over to our last Micronaut example with Neo4j, you again see all the cities. 6, as you see them here. We get a particular city by name, like New York. And again, we'll skip the rest, so Doris also still has a little more time to show you how this can be done with Spring Data. So over to you.
Yes, sure. Thanks a lot. So with that, let's get back to the presentation first of all, right? So let me start by sharing my screen so we can do this properly. 1, 2, 3, yes. And I hope we are back to the presentation also in our view and you can see it. So we've seen quite some good examples from Werner, right? Now let's have a look at the Spring Data, right? We will see Spring Data against both MongoDB and Neo4j. So let's start with MongoDB. We distinguish two main parts here, logistics and domain, of course. Nothing super crazy, no rocket science here. Just the very basic dependency of for MongoDB with Spring Boot Starter, and of course some configuration properties for to which database the application should connect to, using which port as well. So this should be our logistics. Nothing that crazy, right? What about the domain? Let's get to the right column now. So in the domain, we only need to annotate our model class with the annotation document, right? At document. And of course, we need to point to which particular collection the model should be connected to. In this particular case, I'm still using the God examples, and I'm pointing this model class to look at the collection having the name gods. We will see more in the code as well. Now, what about the repository? The repository here for MongoDB needs to only extend the Mongo repository, right? Which is, of course, of a specific type. We will see it once again in the code. What about the controller, though? So, this one is a hint because I would really like this to see it together. I would really like you to have a look with me how different or how not that different, how easy it is to configure a controller for the MongoDB for Spring Data. So, two things so far, document annotation and just extending the Mongo repository to framework-specific things we should keep in mind about the MongoDB connection. What about our Neo4j, and for the sake of time and to also prevent, of course, quite some back and forth between presentation mode and code mode, I will show both Neo4j and MongoDB, and then we can go directly to some code examples. So, Neo4j, if you're not already aware of it, comes out of the box together with a basic movies example. So, once you're able to download the Neo4j database, you get a basic and quite rich, I would say, movies database example. In this particular case, of course, we have two entities, the movie entity and the person entity. And what can we see here is, of course, some connections, some relationships between the two entities. So, for example, in the movie Forrest Gump, how could we read this, right? In the movie Forrest Gump, we can say that person, entity, Tom Hanks, acted in it. And of course, the movie Forrest Gump was directed by Robert Zemeckis. Now, what about the logistics and domain of Neo4j? Once again, no rocket science today. So, for our particular examples, we used some reactive flavor of the Spring Boot Starter dependency, just to make our life easier. also for the sake of time. And of course, once again, the dependencies are quite straightforward, right? Neo4j database needs to run on top of Bolt, and of course, additionally, we need to configure username and password. Nothing crazy. What do we say? For the domain, we need to cater for our movie entity, our movie repository, also a secondary entity here because we are having graphs, so there must be some relationships between the different entities, right? And what does having relationships between the different entities mean? It means that we need to cater for some roles as well, right? So in terms of the repository, just like we did, or just like we could do for the MongoDB configuration, we just need to extend the corresponding one for Neo4j. In this particular case, the reactive Neo4j repository class. And of course, some framework specific or some reactive specific, so to say, mono entities in order to properly deal with the repository. What about the entity configuration? In Neo4j, everything is a node, or to put it better, our model classes should be annotated with a node annotation. So for our person entity, we should have a node at node person, right? Of course, some properties here, and same goes for our movie entity. Some properties, and then what do we see in the very bottom? We do see some relationship annotations, right? Exactly just like we've already said for both entities. There is some connection between the person and the movie, so we need to properly deal with that or cope with that in the code as well. So this is now possible using the relationship annotation and with a type acted and of course direction incoming. It always depends on your particular case. And of course, as we said, a fourth class is needed here, the class for roles, which we need to annotate with relationship properties annotation, and no rocket science here either. Now, enough about the slides. Let's have a look at some code, right? Before having the look at the code, and I hope my screen is still visible, and you can now see this graph with the movies database, Neo4j database comes out of the box with. Here is just how it looks like once you start the Neo4j database. You have the movies entity and the persons entity, and of course your movies database or your movies graph database should look like this. Now, before doing before performing some requests back and forth using, of course, our postman as Werner showed us, let's have a quick look at the MongoDB example, as we said. What I'm going to show here is not what we've seen in the slides so far. I just want to quickly point out the most important topics once again. Document annotation for our model class. Then in our repository, we just need to extend the Mongo repository. And remember what I said? How does our controller look like? I don't see any framework-specific annotations, do I? Of course not. So configuring your REST controller, in this particular case for MongoDB, with Spring Data of course, is quite straightforward. There is no magic added here. Everything comes out of the box and you can go around it the same way you're used to deal with REST controllers. So let's perform a couple of requests. Of course, my database is already set up, so by performing a request to get all available gods, I can see a good overview. Of course, every god should have a name and a power. I'm using the Greek gods, guess why. So, different request, get all gods by name. So what did we do here? We configured our query to return all the gods which name starts with her. In this particular case, Ira, let's say. And of course, get got by ID. For this particular ID, we do have some Solido in the system. So let's say I want to delete Sally from the system. I will paste this URL, and then I should see this entry being removed here, right? And what about adding a god? Of course, that should be quite straightforward as well. In this particular case, I do have something ready. So let's add Hercules, who has, of course, the power of strength. Let's directly add him. And that triggers me actually that if I fire this request again, I should get 2 entries, right? Yes, because now, once again, we are requesting the database to return all the available gods whose name is starting with the prefix her. So both Hera and Hercules. Now, enough about it. Let's directly delete all gods, because that would mean we are slowly wrapping it up for the MongoDB example, and yes, there is nothing else left here. The update got by ID, you can see it also in our GitHub repository. Let's quickly go through our Neo4j examples, right? API and domain. Let's start with the domain. Movie entity, as we said, everything in Neo4j, because it is a graph database, everything is a node when it comes to model classes. So some basic annotation here, some basic node annotation here, the relationship, as we said, and same goes for our person. Model class, annotation of node, some properties, no further rocket science here. In our repository, I repeat it once again, the only thing we need to do is to extend the reactive Neo4j repository and our roles. The magic, the thing I wanted to show you once again, our controller, right? And I give you a moment to have a look at the controller. Once again, nothing specific, nothing framework specific needs to be configured for Neo4j either. So everything comes out of the box for you, and everything can still be configured the way we are used to configure our REST controllers. And with that, let's also have a quick look at 2 or 3 basic examples here. Both of my examples are running here, as you can see below. Both my Spring Boot data Neo4j and my Spring Boot data MongoDB are running, and you can find all the examples in our GitHub repository. Ottavio will share the links later on. So, very typical, a very normal request, right? How to get all movies? By just doing these movies, by just firing this movies example, right? This movies query. And what do we have? We have around this many movies. Now, let's say I want to get a particular movie, so I'm going to request by title, with title equals the matrix, and of course, so we can see something more easy to understand and more readable, of course. Title, description, actors and roles is of course a nested JSON here with directors, as we've seen. And let's say I want to delete the very last movie, which is A League of Their Own, right? So A League of Their Own is a delete query here in our beloved Postman tool. I'm firing the query, and what I should be getting from the get all movies query is 1 movie less. So that would be all for both Neo4j and MongoDB using databases, using Spring Data, quite straightforward. Just a couple of specific annotations for a couple of framework specific annotations for configuring our back and forth, our persistence frameworks, our back and forth for the queries, and of course our controller. I want to stress this once again, our controller needs no framework specific configuration. It is just a REST related configuration. With that, I will hand it over to Ottavio, who will tell you more about Hibernate.
I don't think that we have enough time, so let's go to the conclusion. So, Theodore, do you mind if you go to the last slide just to share the links?
Can also happen. But first of all, organization. Do we have maybe 5 minutes before we wrap it up? Okay, feel free to directly go to the links if we exceeded the time. I feel we also started a bit later, but yes.
So let's go to the conclusions. Here you go. We have a couple conclusions here, but don't worry, we're gonna share the link with more information about that comparison. But basically, if you want to know, want to go deep, to get more details and try by yourself, right? So go to the GitHub repository. So go to JNoSQL organization / NoSQL endgame, where you can take the sample, take a look, and compare for sure to see each one fit better in your case. Because when we talk about NoSQL frameworks, we need to understand that any framework has your home strategy to handle that kind of solution. For example, Hibernate wants to use the same JPA annotation, the same JPA API interface to handle with NoSQL database. And that for sure has several trade-offs. So go there and take a look. If you want to know more about JNoSQL, we have the website jnosql.org, the credits, and that's it. So thank you. I'm glad to be here. Thank you, Werner Todors, to be here and share about a lot of knowledge about NoSQL database.
Great. Thanks a lot, everyone. And if there are any questions, feel free to reach out to us on Twitter or LinkedIn. We will share the presentation afterwards. Thanks a lot.
Yeah. Yes, thank you guys. So please go to Zoom Q&A room, and there you can continue communication with your participants and discuss all the topics right here. Thank you. And now we are ready to open the presentation of our gold partner. It's, well, give me a second. Sorry guys. Our gold partner, it will be Sigma Software.
Привіт! Вітаю Sigma Software. Мене звати Оксана, і сьогодні я покажу, як нам живеться у львівському офісі. Ходімте! Знайомтеся, а це Зеник, традиційний житель скандинавських країн і символ нашої компанії. Мініатюрна версія Зеника подорожує з нами по всьому світу. Ми беремо його у відпустки, в бізнес-тріпи і на конференції. Sigma Software – це шведська компанія, яка понад 17 років надає послуги з розробки та IT-консалтингу. Nordic Tradition, Ukrainian Spirit, Superior Software – це про нас, адже нам вдається поєднувати шведські традиції та підходи з українською гнучкістю та самовіддачею. У нас горизонтальна структура. Неважливо, який у тебе тайтл та скільки у тебе досвіду. Чи ти пишеш код, чи ти керуєш департаментом. Усі ми разом працюємо, обідаємо, спілкуємось та відпочиваємо. Запозичили шведську традицію фіка – перерва на каву з запашною випічкою. Проходить вона за участі засновників, а також топ-менеджерів. Разом ми обговорюємо новини компанії, ділимося думками, а також знаходимо відповіді на питання, які нас цікавлять. А зараз я вас познайомлю з одним з власників компанії – Вовою Червою. Вова, привіт!
Привет, Оксана.
Я вже трішки розповіла про наші шведські традиції. Поділися, будь ласка, нашими цінностями.
Ценности наши основные – это уважение к людям и одинаковое отношение к каждому, вне зависимости, это клиент или сотрудник.
А можеш розповісти трішки про наші бізнес-підходи?
Опять же, то, что делает наш бизнес успешным, это то, что мы уважаем наших клиентов и стараемся строить личные отношения с ними.
Чим, на твою думку, відрізняється львівський офіс від решти офісів Sigma Software?
Львивский офис – это относительно небольшой офис по сравнению, например, с харьковским, и это дает возможность знать людей по именам в офисе, более плотно и тесно общаться друг с другом, помнить, у кого когда день рождения.
Добре, я буду бігти. Рада була тебе бачити. Ще почуємось.
Взаимно.
Нам важливо розвивати IT-екосистему України. Нещодавно ми запустили Sigma Software Labs – лабораторію для стартапів і компаній, які щойно розпочали свій шлях. Наші резиденти мають змогу отримати консультації від бізнес-експертів, технічних експертів, а також доступ до світових фондів. Як і більшість шведських офісів, львівський побудований з урахуванням зелених технологій. Ми стежимо, аби він був озеленений і всім вистачало простору. Сам офіс працює за принципом ресурсозбереження, а ми популяризуємо зменшення використання пластику та паперу. Ми дуже гостинні. Окрім фіки, ми залюбки приймаємо гостей, хостимо мітапи, організовуємо внутрішні події та курси від Sigma Software University. Це наша освітня платформа, яка дозволяє здобути знання як зрілим спеціалістам, так і тим, хто тільки починає свій шлях в IT. У нас дуже дружня і затишна компанія. Ми не лише разом працюємо, але й проводимо багато часу теж разом. По п'ятницях взагалі організовуємо спільні сніданки, де можемо поділитися нашими новинами компанії, які відбулися за тиждень. В компанії відбувається стільки цікавого, що важко щось не пропустити. Саме тому виникло дві круті ініціативи. Insiders – подкасти про IT та Sigma On Air – корпоративне радіо, на якому ми з Максом розповідаємо про найгарячіші події компанії. Дякую, що були з нами. Зустрінемось у львівському офісі.
Готова?
Так. Вітаємо на хвилях Sigma On Air.
В студії Оксана Назаркевич
Та Макс Ковтун. Всім привіт!
Hi guys, I'm very delighted to see, maybe not see, but feel all of you here in Kyiv studio and at the Devoxx conference. My name is Kate and I'm PR manager at Sigma Software. First of all, I'd like to say thank you for all who are joining us today and organizers for make it happen. So today, I just will talk a bit about our company missions and possibilities for you at Sigma Software. Try to imagine the place where Nordic traditions meet Ukrainian spirit to create superior software. As you heard in the previous video, it's all about us. And actually this is true because from Sweden we took high demand for quality, minimum hierarchy, attention to details, and freedom in decision making for our team. From Ukrainian culture, we took flexibility and dedication to every customer, every teammate, and every project. With the help of our professional team, we deliver smartest solutions, IT solutions for over 18 years to our customer around the globe. Some of us call the company where company never sets, as our office is located from the Australia to the west coast of United States. In the time of COVID-19, you can work from anywhere. You can work from our offices in Australia, in the United States, in Ukraine, from home, from Bali, anywhere. And the company actually have a lot of possibilities and variety of opportunities for everyone. Here you can work with startups, with product houses, with large enterprises, with different technologies and modern directions. So if you're open for the new opportunities, you're eager for fast professional development, check our Sigma Software career site. I'm sure you will find something interesting there for you. Surely, with the switching online, we face significant transformation and a lot of challenges, and as well as our team. And probably the most complicated challenge for us, it was isolation at homes, and we really care about our health, mental health of our team and their work-life balance. So starting from March, we transform all of our events and activities to the online format. We meet with our teammates, I don't know, in online bars. So we share our thoughts during knowledge sharing sessions. We organize our internal conference, kids' days for teammate with children's, a lot of team buildings, and everything to make our team feel more comfortable. Also, we transform our online traditional fika to the online format. You know, in the time of COVID-19, it's really important to be informed. That's why our top manager share their knowledges, share their news, and our team could ask any questions during online fika. The main direction, one of the main directions in the company is the healthy lifestyle and sports. So we promote the sport is our main directions. We have gyms in our offices, we have sports clubs, we have online yogas, cycling teams, sport challenges, anything to feel more healthier. So there are actually a lot of that I could say about Sigma Software, but there are no actually a lot of times. And I want you to remind that we have kind of activities for you during the Devoxx hours. You can check the Devoxx site where you can find the links to our prize draw. It's Amazon Prime subscription for 1 year, and also you can check your knowledge from Java history. So if you are looking for challenging projects, if you are looking for new possibilities and fast-growing development, self-development, join us, and I really hope to see all of you offline next year at Devoxx conference.
Okay, guys, I'm back and I'm happy to announce our next speaker. It will be Hugh McKee. Hi, Hugh. Welcome to Devoxx. How are you today?
Good, thanks. Doing well. I hope you guys are doing well.
So, what topic have you prepared for us?
Well, it's a deep dive into Akka, and I've got a number of projects that I'll be sharing, and all these projects have what I call eye candy, which is there's a kind of a fun user interface in all these projects. So there's actually, I don't know if we're going to be able to do it in the 2 hours, but there's 6 projects, and they start from very basic to pretty advanced, like a simple Akka cluster in the beginning and an IoT application at the end. And they all have eye candy, and they're all downloadable, something that all the developers can take and try themselves.
Sound impressive. Okay, it's your time to shine on Devoxx Ukraine 2020. The mic is yours.
All right, thank you. By the way, I'm hearing another speaker though. I'm hearing Simon.
You hearing Simon? Okay, guys, organizational team, can you help us to check the sound problems with you?
All right, I'll go ahead, but as long as you guys aren't hearing me.
Great, I will try to do it to help you in progress.
All right, thanks a lot.
Good luck.
All right, so hello everyone. Like I said at the beginning, I'll be doing a bunch of different projects. I've actually got a bunch of these 8 projects open, and I'm going to be trying to go through all of them. I'm going to share some links to all these different projects, and I'll show you them. But they're all on GitHub. They're all under my username McKeeH3, and then there's a series of projects. So this is kind of the order that I'll be going through each of these projects. So it starts off from a basic Akka typed project with a basic Akka cluster, and then each of these subsequent projects, the next 4, kind of build up on that first project, adding a little bit more features to the Akka features. And then I'm going to show you another one that's called Where on Earth. These 2 projects go together, these 2 repos go together in a single application, but they're 2 different deployments. This is a much more ambitious project. It's running in Amazon. It's running at scale, and it has a fun map-based UI. Again, all the user interface stuff that I'll be showing you is stuff that you'll be able to that come with these projects. And the READMEs cover how to do the installation and how to get things working and so on. And then finally, there's another pair of projects that I actually just got working the way I wanted yesterday. I'm very excited about that, and I'll be showing that. And this is also running in a Kubernetes environment. So the first thing I want to show you, though, is this simple project. So let me find that one. It's just Akka typed Java cluster. So if I go back to the browser, I've got this is the GitHub repo. So it's like I said, it's just github.com McKeeH3 Akka typed Java cluster. And if you git clone that and then just do a Maven clean package, and then you can start running it. So I'm going to show you what this looks like here. I've already cloned the project, and once you've done I'll do it Maven clean package when you cd to the directory. So you need Java, you need Git, you need Maven, and that's pretty much it. And I'll build the project, and then these first projects start out with some scripts because they run on your laptop or on your development system. They're fairly lightweight, but they do run on Akka cluster. So if I show you the directory here, in this project, there's a bunch of different scripts, but they all start with just this Akka script. And if I go into this Akka script, it gives all the subcommands. So there's a set of commands for doing things at the cluster level, like starting and stopping the cluster, and then opening up the the eye candy piece, the dashboard. There's some commands for controlling individual nodes running in a cluster. And then I probably won't be covering this, but this one's kind of fun. And I've done some other videos on this, but this shows an Akka cluster running or where you can actually simulate a network partition or a split brain. And you can watch visually through the dashboard how the Akka cluster recovers from that. So that one's kind of cool. But really, the thing that I'll be focusing on here is these first ones, starting and stopping the cluster and then playing around with the nodes running in the cluster. So I built this thing, so I'm going to just start a cluster, and it defaults up running 9 nodes in a cluster. Again, it's all running on my laptop. I'm just on a Mac. And it starts everything up, and I can check to make sure that it's running by just doing an Akka cluster status. It hasn't come up yet. It should come up here pretty quick. Here we go. It's starting to come up. One more. There we go. It's running. So once it's running, then you can open up the dashboard, which is just /Akka cluster dashboard. And that should, let me get the right browser window that I want to use for this. This one. So that should open up a tab here, and this shows the running cluster. So the JavaScript for this is included in this project, and it's the JavaScript is written specifically for this project. So it's this is a demo project, but basically we're seeing a live view of 9 nodes running in a cluster. So just kind of it's showing you what's on this dashboard. On the right side, you see this kind of matrix, this 3x3 matrix of nodes. So that represents each of the nodes in the cluster. So you can see, and I'm showing the ports because they're all running on the same localhost IP. So it's 2551, 2552, all the way up to 2559. But the way this dashboard works is that the JavaScript is polling all of the running nodes in the cluster, and it's asking each individual node, what does the cluster look like to you? So I'm jumping ahead here, but with Akka, one of the main features of Akka is that you write, you write your Akka application, you write a single application, but then you deploy that application into a cluster of nodes. So it's like you write a program that runs across a cluster, and the code in that program talks, can talk to each other using Akka actors. And I'll show you some actor stuff in a little bit, but I want to just focus on at the cluster level here at a moment. So the view here is what does each of the 9 nodes look like in the cluster, and then on the left, it's just a kind of a view of what's called the leader. So Akka is not it's a masterless cluster type of a system. There is no master, but there is a node that's designated as the leader, and then the leader's role is only really limited to the node that makes a decision about letting nodes join the cluster or having nodes leave the cluster. And the strategy for who is the leader is quite simple. It's the node with the lowest IP and port. So when the Akka cluster is running, each node in the cluster, each of these 9 nodes are running on an IP in a different port. And when Akka goes to decide who's the leader, it's the node with the lowest IP and port. That's the basic strategy. And the reason for that is it makes it easy for every node in the cluster to figure out who should be the leader. Should I be the leader or should somebody else be? So each node in the cluster knows what other nodes are running in the cluster, and it looks at its own list and goes, well, like so 2541 goes, yeah, I'm the leader because I'm the lowest IP and port. But 2559 looks at that list and goes, nope, I'm not the leader because I'm not the lowest. So to show you that this is actually running live, the next thing I can do is I can do I can stop a node. So I can do Akka node stop, and I'll just stop node 5. If I go back to the dashboard, you can see it's already showing, that it's exiting, it's leaving, it's kind of a different color. And now 5 is grayed out. And you saw, if you were watching, you could kind of see that the other nodes at their own time, it all happened fairly quickly, but it's not, synchronized. It's not all locked together. That the other 8 nodes running in the cluster recognized that node 9 is no longer running. So this was an example of a node leaving the cluster, and actually as the JVM was shutting itself down, there was a process initiated where the Akka code running in that JVM was signaling to the rest of the cluster, hey, I'm leaving. So it sent a message to the rest of the cluster, say, I'm leaving the cluster. So it's kind of an organized departure from the cluster. So what's happening here is all the nodes in the cluster, when they come up, they're talking to each other. It's called gossiping. Gossiping is the word for in English for talking to each other. Just chatting back and forth. So it's basically all these different nodes that are running in the cluster are kind of saying, doing heartbeats. Are you there? Is everything okay? And expecting responses back. So there's all this heartbeating going on, and that's where they're gossiping with each other to kind of keep an eye on each other. Like node 2551 is gossiping with the other 7 nodes that are still running in the cluster. It also was gossiping with node 5, but when node 5 said it was leaving, then it's knew to stop doing that. But another thing that you can do is a little bit more spectacular, which is I can kill a node, which is simulating a failure. So I'm going to kill, say, node 7. So this is just /akka node kill. Again, these scripts are all provided in the project. We go back to the dashboard. What we should see is node 7 went away very quickly, but then the rest of the nodes in the cluster go, oh, wait a minute, I was talking to Akka, or that node 7 a moment ago, and it was responding, but all of a sudden it stopped responding. And when that happens, the node is flagged as being unreachable. So that's what we're seeing here. And the information that we're seeing here on the dashboard is where the dashboard is polling the backend, each of these backend nodes, asking it, what do you think the cluster looks like? These are things that you can do through the Java API, fairly simple to get this information. And then I'm feeding that information back to the dashboard in the response. So the kind of a JSON response comes back from the Akka, the Java code that says, yeah, well, this is what the cluster looks like to me, the 2551, or to me, 2556. It's we got one node that's no longer there and another node that's unreachable. The other thing that got flagged is that I'm showing the L. The L represents where the leader's at, and also in the top left, you can see the leader is on port 2551, which is the lowest IP port, but it's shown in red. And what that means is that the leader is in a state where it knows that there's something wrong with the cluster. And this has significance because a leader is supposed to be the one that promotes nodes to be running in the cluster, being in an upstate, and allows nodes to leave. So I'll show you what that means if I try and restart node 5. So I'm going to do Akka node, oops, just type node start 5. Back to the dashboard. So we should see 5 come up as joining, and then it goes into a weekly ups. So what I'm showing in the dashboard is the state of each node, and there's a life cycle that nodes go through, and that life cycle is defined in the Akka documentation. But really, what's happening here is that this node is running. It's asked to join the cluster, but the leader is not able to let this node go to a fully up state. So that's why I'm showing it as a darker green, to kind of make it clear on the dashboard that this node is trying to join the cluster, but it's not fully up. And this has a significance in many of the things that happen because Akka also is an actor system, the actor model. I haven't really talked about that yet, but actors run on different nodes in the cluster. And in many cases, you don't want actors running on nodes that are not fully up. So this is kind of an important state. So a lot of the built-in actors that come from Akka, for example, really keep an eye on this so that they don't say allow traffic to start flowing to this node until it's fully up. So to fix this, I need to resolve this issue that this node is unreachable. So the way to do that is you can down a node. So I'm going to go and do a Akka node down 7. Now these scripts are something I wrote. They're just part of the this project. If you look at the source code of these scripts, you can see how this is actually being done. I just added these scripts to make some of this stuff easier to do in a demo situation, and more importantly, easier for you guys to do if you want to play around this. So I'm going to send in the down, go back over to the dashboard, and right away you saw 5 go up because node 7 was down. So now it's no longer red; it's just gone. So now we're up. We're up and running, and we've got the 8 nodes running. We don't have anybody down. The leader is not red anymore. The leader is happy because all the nodes running in the cluster are in good shape. And there you go. So let me just, I'll just for fun start node 7. And see if we can watch that come into the cluster. There goes joining, and then it's up. Again, you can kind of see the up state kind of propagate through the other nodes in the cluster. And this was a fun part about doing this dashboard, was having it do the constant polling. Is polling about every 200 milliseconds, each of the nodes in the cluster, asking it for what does the cluster look like to you. So that's where you're seeing it. It kind of takes some time. It doesn't. They all don't change at once, but we're looking at a live system. So let's take a look at the project. So this is, like I said, it's I downloaded this project, the Akka typed Java cluster, and there's just a few classes in here. This is a very, very basic project, and it's just got 3 Java classes. There's a main, which is where things start. The main method is in this class. There's a HTTP server class, and that's used for the dashboard. And then there's a cluster listener actor, and this one is kind of a basic actor that I'll show you. But it's kind of it's an example of a simple actor. Let me go into main first. Let me get this guy out of the way. Hopefully my font is big enough for you guys. So in the main method down here, it just does a few things, and it starts up an actor system on this line, and this is how you start Akka. Basically, you start an actor system, and I often explain this as it's kind of a there's not a lot of code involved, but it does a whole bunch of stuff. It's like a glorified thread pool in a way. But this is what it takes to start Akka. Now, part of this process, though, is that I'm creating what's called the root actor or the main actor. So there, Akka actors can create other actors, can create other actors, can create other actors. So you have an actor system that forms a hierarchy. And that hierarchy has a root, and the root starts with this, with a supplied main actor. If you've done Akka in the past, before Akka typed, it's called Akka Classic now, there was a different process, but this is all Akka typed. And one thing I do is I invoke a method that does a little bit of configuration setup, which is not too much here. It's kind of setting things up. There's this project in the documentation and README explains how to do it, but you can set it up to run on localhost 1 and localhost 2, 127.0.0.1 and 127.0.0.2. There's some other commands that are provided in the script, but this is the kind of setup running the 9 nodes in the cluster where the first 5 nodes run on localhost 1 and the last 4 nodes run on localhost 2. And the reason for that is to set up a network partition where we actually block network traffic between localhost 1 and localhost 2, which triggers a network partition, which triggers a split brain, and and you can watch it in the dashboard. So I'm not doing that here, but this is what you're seeing in this code here, this setup cluster node config method. But this class is starting up a very simple actor up here, and because I'm doing the main create, and in the create, this is a basically just invoking a method where it's setting up a behavior, and the behavior is defining how an actor responds to messages. So with an actor, actors are really interesting. In fact, if you look up the actor model and go to Wikipedia, it's got an outstanding, concise definition of the actor model and actors in it. So that's a really good source to start with if you're brand new to actors, you've never used an actor type of a system. But fundamentally, with actors, they're, and I'll show you, you write them as regular classes. This is all Java. You can use Scala as well. And the main difference is that no external code directly invokes any of the code within an actor. The only way you can communicate with an actor is to send it messages. So a behavior is defining how this actor handles messages. And actors can have different behaviors depending on the actor's state. So as an example, say you have a simple actor who can be either in an idle state or a busy state. So when it's an idle state, it's ready to accept requests to become busy. But when it's in a busy state, it is going to ignore requests to become busy because it's already busy. And the way you do that is actually fairly simple using these different behaviors. So an actor can have an idle behavior saying, yep, when I get a message that says, I want you to do this task, it goes, yeah, cool, I'm going to do this task. And it's going to kind of switch from an idle state into an active state, which means it switches behavior from an idle behavior to an active behavior. So this is what behaviors do, is you're defining when you receive messages, which is starts right here. I'm creating a behavior, and you define as messages come in, what does this thing do? Like, what method does it invoke, basically? So this is a real simple one. This actor is really not doing anything other than bootstrapping the rest of the cluster. And as an example, is calling this bootstrap method, and all this bootstrap method is doing is spawning another actor. So this is the beginning of the hierarchy. This main actor is a root actor, and it's creating one actor as a child actor to it, which is the cluster listener actor. So this is how I'm kind of bootstrapping this system. When we get deeper into some of the other projects, this will get a little bit more involved. But here I wanted to have this project, like if you want to start a basic Akka cluster project, or you want to see one and kind of examine what's going on, and with just a few actors, with not a lot of other crap, to be honest, that just makes it hard to kind of grok what's going on, then this is a project for you. Start it up. It's very basic, but it also has this kind of cool dashboard that comes with it. So let's take a look at this cluster listener actor, because this actor is a little bit more interesting. So start out, the cluster listener actor, it extends a base class, and so it's extending what's called abstract behavior. And this is where the typing comes in, where the actor says what types, by class types, will this actor accept as messages. So here it's saying I'll accept messages that are of type cluster event, cluster domain event, which is actually an Akka class. And then in the behaviors, do a setup, getting down in there's typically the pattern is you have a create method, and the create method, it gets invoked in static, and it actually sets up the behavior, which basically here I'm just doing the setup is going to create an instance of this class. So I invoke the constructor down here. The constructor is past what's called the actor context. So this is kind of context information about this actor. This actor context has quite a few methods on it where you can get information about this actor, and things like its what its actor URL is, or it's what's called an actor reference, and other things. But the main thing this guy is doing is in this method is it's invoking this method called subscribe to cluster events. And down in the subscribe to cluster events, it's using an Akka API to create a subscription. And this line is where it's actually sending a message to this other thing, this other actor, saying, hey, I want to subscribe to cluster events. So this is the first example in code where one actor is sending a message to another actor. It's called a tell. And you'll often see this in Akka typed, where when you have your actors that are interacting with Akka, you're typically not invoking some kind of an API. You're sending messages to Akka saying, what you're requesting, and then you might get messages back with some kind of response. Now, so here we're just what I'm doing is I want to subscribe to cluster events. That's why I call this a cluster listener actor. This actor is listening to, it's written to listen to cluster events. So what are cluster events? Well, cluster events are things like other nodes in the cluster joining the cluster or leaving the cluster or becoming unreachable. So as I get further into code, all I'm doing in this actor is I'm getting those cluster events and I'm logging them out. So moving on, there's only one method that I need to implement from the base class, this abstract behavior, which is right here. And it's this create receive. And this is how you define it, yet again, what does this actor do when it receives messages? So in this case, I'm saying on any message, limited to the types that I've specified when I define the actor, I'm just going to invoke this method called log cluster event, which is right down here. So this log cluster event gets this, this message. So the message that was sent to this actor is when this log cluster event method is invoked, that message is passed to this method. So I just log it out, and I put some other information in the log message, like sent to, this event was sent to this node in the cluster, and then I invoke this method called log cluster members. This is a little bit more involved, but basically I'm just doing a little bit of Akka magic, using some of the Akka API because I've registered with some of this, and I'm logging out the nodes in the cluster. So that's pretty much it. I don't want to get too much into this. There's a lot of code here, but sorry about this. But there's this gets a little bit deeper in, and maybe if I have time, we'll come back to this. But really what I'm doing in here is I'm getting some information about each node in the cluster and then logging it out. I'm just looping through it. So we can see this if The log files from this cluster are written to the temp directory. So I can do just do a less on temp, and I'll just go and look at this log. If I do a search on, we can see some of the log messages coming out from the cluster listener actor. Let me get down to where it's more interesting. In fact, let me go to the end of the file and go backwards. It's hard to read. There's a place where it lists out all the nodes in order when I've got the text. Here it is. You can see it here. So it's listing out. It's in that loop, and it's listing out. Member up. It was the message that it got, and then it goes in and it says, all right, how many nodes are in the cluster? Oh, there's all 9. So it just lists them out 1 through 9. You can see here, and that this node information just kind of shows the cluster address, the node address, and then its state. Is it up or down or joining? Things like that. If go back a little bit further, we might see. Let's see. Yeah, see, here's one where the state of the node was joining, and not all the nodes had. The nodes were coming up and they were joining. So when I first started this project, I had just the logging here, but it's like, man, this is boring. Really would like to have the dashboard. So that's what motivated me to write this dashboard, so we can watch the cluster kind of come up without having to pour through a bunch of log files. You can see it live and things like that. It was a lot of fun to write this, and I'll show you a little bit about the source code and how this is done in just a moment. But that's kind of it. This cluster listener actor, it just sends one message to Akka, but then it sits there and it receives messages from Akka. So as the state of the cluster changes, which is kind of cool, Akka is sending this actor messages saying, hey, this member is leaving or joining or whatever's going on in the cluster, and I just that triggers an action in my actor here to go through this code I wrote that logs it out, basically. So the other thing I'm going to show you is the other thing, the HTTP server actor. So this HTTP server actor is using Akka HTTP is called, and it's getting different. It's set up to handle different incoming requests. So it handles the incoming requests for the HTML, the JavaScript from the HTML. There's 2 JavaScript files. There's one I wrote, which is called dashboard.js. And then this dashboard is written using a very cool library called P5.js. And a fave icon. And then this cluster state, though, is the one that's fun, because when a cluster state request comes in from the JavaScript, that invokes a method which gets the cluster state. So the action really starts down here in this load nodes. This is, again, gets kind of involved, and I'll leave it to you to take a look at it. But what I'm doing in this method is I'm basically going through, and I'm just using the Akka API. So the first thing I say is, using the actor system, I want to get what's called a cluster. And from the cluster, I want to get the cluster state. And then from the cluster state, I can get all kinds of information. So first I can give me the list of unreachable nodes. Are there any unreachable nodes right now? And it gives me back a set of what are called members. And then I do a little bit of streaming, and I go through a stream where I go to the cluster state again. I get all the members, and I just do a split array to get a stream of members. And then for the members, I do a little bit of filtering. Is the member up? And is the member not reachable? And things like that. And then I just reduce it down to what I'm trying to get is who's the oldest node in the cluster. which I haven't talked about yet. But I'm kind of filtering through the unreachable and the current members up members in the cluster to find out who's the oldest nodes, because I want to know what the oldest node one is, because I want to show that on the dashboard. And then I can give some other information, but then the next part is where I kind of build the full object that I'm going to send back to the browser, starting in this line, where I get the members, I create a stream, and then I just go through a consumer where I'm building up a list of nodes. And then this is how I'm returning that information back to the dashboard JavaScript. So the dashboard JavaScript is, like I said, is pinging all 9 nodes. Either if it gets a response back, then it uses the JSON that it got back to render that in the dashboard. And that's the main part of what this HTTP guy does. The other part was the where's the routes? Like feeding back the files that are part of this project, like dashboard HTML, the JavaScript. Those are all in the resources. Like here's the JavaScript, the dashboard JavaScript, the HTML, the P5.js code, and it's not minimized. I'm not really worried about performance in this demo app. While we're here, another thing I want to show you though is a file called application.conf, and this is using the type-safe config stuff for configuration. And this file is as minimal as possible for this application, so it's pretty light. I just wanted to have enough configuration so that I could run an Akka cluster and no more. Don't need any more drama than that's already there. So one thing I usually add to my config file is this log config on start, and you can set it on or off. When you set it on, you see all the config settings get dumped to the log file, and it's quite a lot. So normally I have this off unless I'm doing some debug on what actually is set in the config. But in the config, in order to run a cluster, I need to set this and say the provider is a cluster. And then another thing I'm doing here is when you're not running in a dynamic IP environment, you set seed nodes. And the seed nodes are used when the cluster starts up. And let me go back to the dashboard. So as each node in the cluster starts up, what happens is they look at their config and they go, am I a seed node or not? If I'm a seed node, then I'm expecting other nodes to reach out to me to ask to join the cluster. So these first 2 nodes are seed nodes. You can see that here, up in the dashboard, it says seed node on these first 2. So when, say, 2554 started up, it's each one of these is a JVM. Each JVM runs, it starts up, it grabs this config, it takes a look and goes, oh, I'm not a seed node, but 2551 is a seed node. So I'm going to send a message to 2541 saying, I'd like to join the cluster. And then they start talking back and forth, and if everything's cool, then it's allowed to join the cluster. So off we go. So that's what's going on in the seed nodes. I've got the split brain, what's called the split brain resolver. I've got this commented out because if I kill a node, I manually downed it when I showed you a few minutes ago. If I had the split brain resolver enabled, it would have downed it automatically. And there's a configuration setting for how long the split brain resolver will wait before it reacts. And the default is, I think it's 10 seconds. I increased it to 15 seconds when I'm using that for demonstrating a split brain. But in this case, I'm not demonstrating a split brain. And then finally, there's one part for what's called Akka management, and I'm defining, there's an HTTP port where you can hit for Akka management. And some of those scripts that I'm using use the Akka management port. They send curl commands to this port for, like downing a node, for example, goes through 855, whatever this port gets configured to be. So that's kind of it. I want to move on though, because spent a fair amount of time on that guy, on this project. I want to move on to the next one. So I'm going to stop this cluster and we'll watch it stop. So stop, I'll go back to the dashboard. You can see everybody's leaving. It takes a little bit while all the JVMs shut down. And then, all right, we're down. So that cluster is down. So let's move on to the next project, which is Akka Cluster Aware. So I'm going to go to that guy. And I'm just going to go ahead and start up the cluster, get things rolling as quickly as possible. Start the nodes, check on the status. There's no point in trying to open the dashboard until the cluster is up and running. So this status script is kind of a convenience for seeing has the cluster gotten itself in reasonable shape. Okay, we got a cluster running. Set the dashboard. And this is going to be a little different. There we go. So it's a similar dashboard, but now there's a little bit more of the empty spaces in use. And you can see things are happening. So what's going on here is that I took that first project and now I've added in, I created a new project, but now I've added a little bit more to it. So what's happening here is there's actors that are talking back and forth to each other. So what's going on is there's a new actor that I've added that's aware of the fact that it's running in the cluster, and it's aware of the fact that it has a clone of itself, itself running on each node in the cluster. So each of these actors are sending messages back and forth to each other, and that's what these counters are showing here. So this actor on 2551, what it's doing is it's sending messages to its counterparts on all the other nodes on the cluster. So it sent a message to the actor on 2552. When that actor gets that message, it simply sends a response back. It sends a message back to the first actor saying, "Yep, I got your message." So, and the messages are actually called ping pong, which is a game like table tennis or whatever it's called, ping pong. So when I'm showing it, kind of animating here, is the count of the number of messages that are getting ping pong back and forth between all these different actors. And I thought it would be kind of fun to show that this is happening. So already, just the short time that this guy's running, the actor on 2501 is sent to almost 20,000 messages, and so have the other ones. So it's kind of the rates are all kind of random. I'm showing the rate, like 162 messages per second, 175 messages per second, and so on. So again, it's same as the last project, but with a little bit more added to the dashboard. A totally different project, though. It's this Akka typed Java cluster aware, or Akka typed. I don't know. I have to look at the project name again. Akka type Java cluster aware is the project name. So let's take a look at the code in this guy. I'm going to go find that project. Here it is. So it should be somewhat familiar territory. There's a main, got an HTTP server, but we got a couple new things. An HTTP server actor, there's the cluster listener actor, just like the prior project is there, and then there's this cluster aware actor. But let's look at the main, because it's just a little bit different. So in the main, what's going on is it's doing its bootstrap. It's starting up the cluster listener actor. But then it also starts up two other actors, an HTTP server actor and a cluster aware actor. And the reason for this is that the cluster aware actor all the cluster aware actors need to report statistics. I got to feed all these statistics that are happening up to the dashboard. And all those statistics are, of course, reachable via the HTTP server. So I got to, feed all that stuff. So I'm going to go into this cluster aware actor. And starts out, it's another, it extends the abstract behavior. It bootstraps itself, and I want to just show you this create receive. This is where you define the what messages or how it's going to handle what messages it is going to take. And there's some message called listeners. I'll explain that in a bit. There's another message called tick. I'll explain that in a bit. And then here's the ping pong. So this describes, when this actor receives a ping message, it invokes this onPing method. When this actor receives a pong message, it invokes this onPong method. So how does this actor work, though? Well, when it starts up, it does a couple things. So back in the constructor here of this actor, which is invoked when the actor is created through the static create method, the actor is passed in the HTTP server. It's called an actor ref, and an actor ref is like an actor URL. So if one actor wants to send a message to another actor, it sends a message indirectly, as I mentioned earlier, and it sends it via this actor ref or actor URL. So when you create an actor, the spawn operation returns the actor ref for that instance of that actor that was just created. So when I created that HTTP server actor, I saved the actor reference so I could pass it on to this cluster aware actor, or this aware actor, and because this actor wants to send messages to that other actor. So I save that, but then there's this register and subscribe. So what's going on here? This is pretty cool feature. There's a feature now in Akka, and this gets more into the deep dive. It's a relatively new feature with Akka typed. It's called the receptionist. And with the receptionist, what it is that it allows other actors to subscribe to actors that register with the receptionist. So you can have some actors that register and some actors that subscribe, or you can have some actors that register and subscribe. So in this case, I have an actor who's registering and subscribing. So with this receptionist, which is fairly easy to get, the actor context, get the actor system, and then get the receptionist. This gives me a reference to the receptionist. In this line, I'm sending a message to the receptionist saying, hey, I want to register myself, context get self, which is my actor reference. And I want to register myself using this service key. So service key is a way for subscribers to group themselves. So you can have multiple groups of subscribers, and all the subscribers kind of form themselves into a group. It's kind of like a chat room in a way, what's going on here. So on every node in a cluster, when this actor starts up, it's registering and saying, I want to join this group defined by the service key. And here's my actor reference, my actor URL. So right now what's happened is 9 actors have registered with the receptionist. And then the other operation here, subscribing, what that tells the receptionist that send me the list of who's registered every time somebody new joins the list or every time somebody leaves the list. So that's where I'm subscribing to this. And that sets up the receptionist then will send this actor messages with a list of who's currently subscribed through this message, this listeners class. And it's basically a list that's coming back, a set. And that tells this actor, gives it this actor, who are the other subscribers? Who are the other actors like me in my service key group that I can ping pong with? So that's what's going on here. Now the tick one is also interesting. The tick is a timer. It used for a timer, because when I set this actor up, in the create method, one of the things you can do is you can set up a behavior and with it what's called a timer. And this timer is passed into a lambda, which I just use to pass to my constructor. So this timer here is just where you can schedule things. So with the timer, on this line, I'm just saying, all right, and you kind of tell what this actor is doing is telling Akka, I want to schedule sending a message, this tick instance at this interval. I want to send it to myself. So the reason I'm doing this is that I've used this to send a message to this actor to trigger it to send messages to the other actors, and it's happening at some kind of a rate, and the tick interval is where do I define that? Here's a tick interval, and I kind of do a random on it within a range, and I'm looking for a range of around 50 milliseconds. So it's like from 25 to 75 millisecond range. So I kind of randomize how often, but the tick interval that each of these actors start up with, roughly around 50 milliseconds. So every 50 milliseconds, it gets a tick message. And if we go into the on tick method, what it does is it pings up colleagues. And I'll show you that method in a moment. But basically, this is the mechanics of it sending messages to the other nodes in the cluster, the other actors running on the other nodes in the cluster. So this ping up colleagues, a little bit more involved. Won't dwell on it too much because just for the sake of time. But basically, I'm just looking for the other members in the cluster that are up, and I want to send a ping message to those guys. So at some point, where do we see the tell? Where's the tell? Sorry, I'm looking for where the tell is in this guy. There it is. Yeah, sorry, it's kind of buried a little bit deep here. So it's going through the stream, do a little bit of filtering, and then here's where the actual tell is at, where it's doing sending a message using that list that came from the receptionist, and it's sending a new ping message to that other actor. So this is how every about 50 milliseconds, this guy is sending a message to one of the other, or all the other actors on the cluster. In the stream, I'm filtering out myself. So, and then also making sure that the other things that I'm talking to are up. So if so that happens on a tick. So when an actor gets a ping message, it invokes this method. I do a bit of logging, and then I reply to the pinger with a pong message saying, "Yep, I got your message. Here's my reply." And then I capture up some statistics, which are then I use that to periodically send to the HTTP server. So let me go back to the system here. This list here then is coming from the receptionist in each of these actors. So if I stop one of these nodes, I'm going to stop node 1 this time, and I'll show you what's going on there. Akka node stop 1. Here goes, it's going down, and then you should see these lists shorten when node is down. So yeah, they all shorten by 1. So if you look, 2551 is no longer in this list, in any of the lists here, because all these other actors were notified that a subscriber left the receptionist, that node is no longer there. So they know not to stop send messages to them anymore. It's not capturing any statistics from them anymore. So the list adjusts. But I deliberately stopped node 1 as well to kind of go off on a side for a moment to talk about the oldest. And because I'll be getting into that in the next project. But notice that the oldest used to be, the leader and the oldest used to be node 1. And so the leader, 2552, is now the lowest IP in port. But the oldest, it happens to be, and it's just kind of random, it happens to be that now the oldest node in the cluster is 2555. Well, the significance of the oldest is where what's called a cluster singleton works, and we'll be looking at that in the next project here in just a moment. So, but these things move around. So if I start up node 1 again, though, let's start 1. We should see node 1 come back up. Like there it goes, it's joining. And then we should see the lists update. So now the lists go back to, 2551 is there, 2551. All the guys, other actors in these clusterware actors in the system see this. So all these statistics that we're seeing here are being sent in from the clusterware actor on node 2554, for example, or on node 2555. And they're all being fed to the web server via that web server actor. And notice now also started up node 1. The leader moved back, but the oldest didn't change because the leader is the newest node in the cluster. So that's not going to impact what is the oldest node. So the idea of the oldest node is it's the most stable node. So things that we'd like to keep running or keep as stable as possible, like cluster singletons, the idea is let's put them on what seems to be currently the most stable node in the cluster, the one that's been around the longest. So that's cluster aware. The receptionist is a very powerful. This is kind of opening up the cluster to you. I just wrote this code, and it's a simple, basic example of actors talking to each other across the cluster and how to do it. The basic code to make it happen is very straightforward. The akka documentation, if you look for akka receptionist, is pretty well documented. It's pretty easy to follow. It's definitely getting to a more advanced technique, but I think it's a very powerful technique that's not like super rocket science. So let's move on to the next project. Got to pick up the pace here. So first I need to stop this project, or stop the cluster in this project. So we'll make sure it stops. All right, it's down. Close this tab. And go back to code, and we'll find the singleton. Singleton. All right, so the singleton project, third project in this series, takes the second project and adds a little bit more to it. And so let me show you this one running. Now I go to the command window. So I got to change directories to the singleton. And I'm going to start the cluster. Status. It's up. All right, buddy. There we go. And open up the dashboard. All right. So now dashboard's running, same dashboard, but now there's even more. So the cluster aware actors are still in this project. They're still ping-ponging back and forth to each other. So the dashboard's getting a little bit more interesting. And now I've filled in the last big empty space in the dashboard here. And what this is showing is it's showing what I'm calling singleton aware actors. So what's a cluster singleton? A cluster singleton is a an instance of an actor where there can only be one instance of that actor across the cluster. And why would we do that? Well, maybe you have to have an actor that has to make cluster-wide decisions, and you don't want to have to go through any kind of, say, distributed negotiation about what the decision is between, say, multiple parties, like multiple actors. You just want to have one actor that can make that that decision. But so how do you handle that? Well, there's this really convenient pattern in Akka for having a singleton actor, and that's what I've done here. So what's going on is the singleton actors, and you can have more than one singleton actor. In fact, it's very common that Akka uses singleton actors, and of course we can write our own singleton actors for our own applications. But the singleton actors always run on the oldest node. This again is the significance of the oldest. So same thing's going on though, is that there are actors, individual actors on each one of these 9 nodes that are sending messages to the singleton actor. It's a ping message again. And then the singleton actor is getting those ping messages and sending back pong messages. But now all I'm showing is counters from the perspective of the singleton actor. So the singleton actor, what I'm showing here is so far it's received 25,000, 26,000 messages from these other actors, these other 8 actors, or I'm sorry, 9 actors, one actor per node in the cluster. So if I stop one of the other nodes in the cluster, like I'll stop, let's say, node 9 for fun. It's leaving, it's exiting, it should be gone. The lists get updated, and now all the lists, including the singletons list, is updated. Now we see we're not receiving messages from 2559 anymore because, of course, it's down. So the singleton actor is aware of that. It's just keeping track of who's sending it messages. Now, the next thing I'm going to do, though, is I'm going to stop node 1, which is going to stop this actor. And you can see the state of this actor right now. It's got a count of like 37,000 messages. But let's see what happens when I stop node 1. So node 1 is leaving, it's exiting. Now look what happened. The counts in the singleton actor are reset. Because I'm not persisting this anywhere. I'm not saving this information. I did this deliberately because I wanted to show that unless you're doing some kind of state persistence, maybe to some kind of a database or something, that when the singleton actor used to be running on node 1, and now apparently it's running on node 3, 2553. And when that happened, a new instance of that singleton actor was automatically started up. I don't have to write any code as a programmer to do this. An instance of my actor was started up somewhere in the cluster. So in this case, it's on node 3. Everything keeps going. Everybody's, they're all talking to each other. And then now if I start back up nodes 1 and 9, just to get back to a full complement, 1 and 9. See these 2 nodes start up. The list should get longer here. There it goes. The lists are filling out. And the singleton didn't move though, right? Because now this is the oldest. Even we have 2 new nodes, so these are very young nodes, nodes 1 and 9. So certainly not going to. I don't want that. We don't want that to trigger moving the singleton when new nodes join. We want the singleton to be as stable as possible. So that's kind of what's showing you. The counter kept going uninterrupted, and things are happening. So if we go into the project, I'm just going to jump. Well, let me see. In the main, I'm going to show you how. It's not in the main. The singleton actor is started. Well, there's actually 2 actors. There's a singleton aware actor, and then there's a singleton actor. So let's jump to the singleton aware actor. So in the singleton aware actor, The thing I want to show you is, it goes through the normal thing. There's a static method to do a create that invokes the constructor of the class, passing it things like the actor context. This guy has a timer, and it also has, let me get this out of the way, the HTTP server reference, because this actor is also feeding statistics to the HTTP server. But the interesting part is here, where this is how the singleton, what it takes to set up the singleton actor. Just do there's a cluster singleton class, do a get with the actor system, and then there's a init method. And then init method, I'm just saying, give me a singleton of cluster singleton actor create, and I'm passing it I'm just giving it a name, that this cluster singleton actor class gets simple name. So it's just kind of an actor name. So on every node in the cluster, there's this singleton aware actor, which is invoking the code that initializes cluster singleton on that node. So on each node, this happens, but then the nodes themselves, Akka negotiates, right, where does the create method actually get invoked? It's only going to start this actor on the node that's currently the oldest node. So it's not going to start this actor on all 9 nodes in this running cluster. It's only going to start this actor once in the oldest node. And then, because we've initialized it, giving it this information about how to create the singleton actor, when the singleton has to move because the node it was on is gone, then it again goes, oh, we lost the oldest node. A negotiation goes on. This is all in Akka. It figures out, here's the new oldest node, and then this cluster singleton create method is invoked on that oldest node to start up a new instance of the singleton on the new node in the cluster. And then this guy's just doing, it's sending out ping messages and receiving back pong messages. So that's what's going on here. So it's very similar to the cluster aware actor. The dashboard showing the statistics here. So this dashboard's kind of filled up. This was my goal at the beginning, was to kind of show some activity, going on, but there's more. So I'm going to move on to the next project. So let me stop this cluster. The next one's a lot of fun as well. So this project's stopping. There it goes. Everybody's gone. I'm going to close that. And I'm going to switch to it's called sharding, cluster sharding. And I'm going to switch to the project as well. Akka cluster. Sharding. Yep, this is it. All right. So now that we've switched over, I'm going to start this cluster. Wait for the status. Okay. And then I'll open up the dashboard. So you might have guessed this project has everything from the last project, from the Singleton project, which has everything from the second project, the Aware project, which has everything from the first project. But it has more. And so we got the cluster Aware actors talking to each other through the Akka receptionist. We got the cluster Singleton working in this one. But we also have cluster sharding working. And this one's kind of fun. It has a different view, and it's actually called viewer. So it's Akka cluster viewer. This time I'm going to give it a node number. I'm going to give it node 2, and I'll show you why when it starts up. So I'm starting it up on a different HTTP server. So this one's kind of cool. It's called somebody internally at Lightband, when they first saw this, they called it the crop circle. I don't know if everybody knows what a crop circle is. Crop circles are kind of famous in different parts of the world. What happens is that somebody comes into like a wheat field and creates an elaborate pattern, very elaborate patterns. If you do a search on crop circle, you'll see, and look at the images, you'll see this. And there's these really elaborate patterns, and they're supposedly from aliens, from people off Earth, people, UFOs, things like that. But really, it's very clever. Well, at least this is my opinion. It's very clever and talented people being funny by creating these, and a lot of spare time in their hand, creating these elaborate crop circle things. But anyways, this is a view of cluster sharding. So what's cluster sharding? Well, cluster sharding is a way for distributing work of stateful actors across a cluster. So this diagram is showing, up in the top left, is showing kind of something similar. This is a little familiar since you've been looking at the dashboard, that we're running on 9 nodes and they're all green, meaning they're all up. But this new diagram here is showing these big circles represent the 9 nodes. And then these little circles on the perimeter represent individual entities. So you can think of an entity as, say, a shopping cart. Like, say you're in a shopping cart, so this is your shopping cart. I'm in a shopping cart, and this is my shopping cart over here. Somebody else is in a different shopping cart, and they're in a different shopping cart. But these represent stateful actors that have the state of your shopping cart in your actor, in my shopping cart in my actor, and everybody else's shopping cart in other actors. So right now, there's a bunch of these different entity actors that are running across the cluster. And when I mouse over, you can I make it bigger. Each individual entity actor has an ID, which is usually like the primary key of the entity. So an entity is, think of it from a database standpoint, an entity is the thing, right? The shopping cart and all the data structures that are associated with the shopping cart, like, the customer information, items in the cart, shipping address, billing address, all that kind of stuff, billing information. That's kind of, the state of the shopping cart. That state can be maintained in these actors. But the trick is distributing this work across the cluster. And I have a brand new version that I just got working the way I wanted yesterday that I'll show you in a few minutes that goes into some more detail on this. But right now, I just want to show you a few things here. So you can see that these big circles have smaller circles out from them. And these smaller circles are called shards. So if you ever heard of things like database sharding, this is exactly the same process that's going on. And what the shards are used is to distribute actors across the cluster. Now, the number of shards is configurable and it's fixed. So in this case, there's, I think I've got 18 shards in this this configuration. And there's 18 because there's 2. You can see there's 2 shards per node in the cluster. But there's always going to be 18 shards, but there might not always be 9 nodes. So I'm going to stop a couple of nodes in this cluster and show you what happens. Actually, before I do that, I want to go back and show you another thing. I'm going to stop node 7. So I'm going to flag one of these entity actors. See, it turned red. I clicked it, and that'll turn that one red. So it flags. I'm going to kind of trace this actor 2556-4, and I'm going to trace shard 1, which currently happens to be running on node 7. So I'm going to stop 7, and I'll stop. And I'll stop node 1 because node 1 is shown in purple because that's where the cluster singleton's at. The reason why node 2 is a different color is this is where my browser is hitting. Which node is my browser hitting? And the reason for this is that if I click a node here, it's going to stop that node in the cluster. So I'm just going to click it, and we should see that node shut down here. There it goes. So node 7 is gone. But notice right away, shard 1 already has moved to a different node in the cluster. And now that node now has 3 shards versus 1. And there's our actor. The actor got restarted on this different node. So this is where Akka is built to be resilient. It's like in its DNA to be able to handle these kinds of things. This poor little actor was running along on node 7, doing its thing, had all of its state and memory, everything was cool, and then bam, node 7 went away for some reason. Maybe it failed, maybe it was scaled back, who knows, who cares? But what Akka does is okay, fine, no problem. When a message gets sent to this actor again, or any actor that belongs to the shard's going to be recreated, and all the associated actors will pop up as they receive messages on this new node in the cluster. And then I'll do it again. We'll trace another actor over here. Say, let's see if I can get it. 255-4-6, and on shard 7, and I'm going to stop the node with the oldest on it, and we should see the shard move, the actor move, and the singleton move. So the singleton pops up on node 3, and then we should see the shard pop up here. There it is. It pops up on node 5, and then there's our actor. So now this actor has also moved. Now, but when I say moved, of course the actor that was running on the node I shut down is gone, right? It was in memory on that other system, but now it's gone. So the actor had to be restarted on another node in the cluster. But this is how quickly Akka adapts to this. So what's happening is as the cluster scales in or scales out or has some kind of a node failure or whatever it is, the cluster adapts to it. So this project comes basically with these 2 dashboards. It comes with the familiar dashboard from the cluster singleton, and where we're seeing also the same thing that nodes 1 and 7 are no longer running. But now it also has this dashboard that is kind of visually representing cluster sharding and how actors are distributed across the cluster. And in another project I'll show you in a little bit, kind of takes things a step further, but that project's running in a Kubernetes environment. So this one's a little definitely more lightweight. It again, you can just clone it, Maven clean package it, and then use the Akka scripts to run it and play around with it. And that's all you really need to do it. The rest of the project I'll be showing you in a few minutes are going to be ones that run in Kubernetes, Akka running in Kubernetes. So anyways, let's look at this project. In the main should be somewhat familiar, but it's getting a little bit more crowded because we're starting up more actors. And we got the cluster aware actor that we're starting. We got the cluster singleton actor, but then there's these 2 other actors, which are entity command actor and entity query actor. So what these actors are doing is they're just sending out random messages to entity actors. So these are kind of simulators of traffic. So I didn't want to have like an external HTTP tester or something like that, which you could do, but I wanted to make this project simple, standalone, clone it, build it, run it, and play with it. And then not a lot of ceremony or drama to get it going. So these guys are just, they're using timers to send out messages periodically to entity actors. So that's the entity actors is set up with this in this cluster sharding method, which I'm going to go to here. So this is all the code that's needed to start up cluster sharding. Just the do a cluster sharding get actor system. This pattern should be familiar, like cluster singleton get actor system and so on. We did that before. And then you do a cluster sharding init. And basically what we're passing here is what is the actor that's used to handle entities. And in this case, it's an actor that I wrote called an entity actor. And I'm just doing a create. And again, I'm passing it the actor reference to the HTTP server actor because I want these actors to feed statistics to the HTTP server. This is it. This is all the code that I need to set up cluster sharding. And then if we look at the entity actor is, in this case, it's just another actor that extends abstract behavior. It's a little bit more involved, where it's getting some more information, but it's got a create method, which invokes the constructor of the class, and then there's a create receive method, which we have to override and implement. How are you going to handle our incoming messages? So the incoming messages are 3. There's on change value and on get value. So these are the messages that are being sent by those other 2 classes. Let me go back to the main. This command actor and this query actor. The command actor is sending command messages, and the query actor is sending query messages. And the entity actor is receiving those messages. So when it receives those messages, like when it gets a on change value, which is the command, go to that method, and all it's doing is this actor has a very simple state. When the actor first starts up, the state is null. And then once it receives a message, then it initializes its state. And from that point on, it has some state. There's no persistence or anything like that going on in this actor. No database yet. So I log it out, that it was initialized, but then here it send back a reply to the actor that sent me this message saying, yep, it's an acknowledgement. I've initialized myself. Or if it's already alive and it's stateful in memory, then it just sends back a reply of, yep, I've just updated myself. That's it. The other thing, though, is that when it's initialized, I invoke this method called notify HTTP server. And I create this, what I call broadcast message, which goes to the HTTP server actor. And the HTTP server actor then gets this message. So before I go into the code, I want to show you what's going on. Back on the diagram. So while this is running, you can see things are kind of moving around. And what's happening is that some actors, they kind of pop out of existence. You can see them, they get a little bit bigger and fade out. So they're kind of a nova, like a supernova, like a star going out. And then you can see new actors coming in. They're highlighted in dark color for a moment when an actor is first started. So what's happening is the actors stay alive while they're receiving messages. If they don't receive any messages after a certain period of time, these actors shut themselves down. So I've set the timing on how often messages are sent so that get a little bit of this coming and going of individual entity actors that kind of show actors stay in memory as long as they're receiving messages. But if they're after a configurable amount of time where no messages have been received, the actors will shut themselves down, or what's called passivate themselves. So that's what we're seeing here. But what the trick, though, is that my browser is sending in requests via node 2. So this web page is sending in HTTP requests to node 2 to get JSON responses back to tell it what's running in the cluster so it can build this tree. But the real challenge is that, say these two actors that are dark, they just started on this other node in the cluster. So how does the fact that these two guys just started on node 9 get communicated to node 2? Well, what's happening on node 9 is these two actors that just started send a message to a single actor that's running on node 9, the HTTP server actor, and saying, hey, I started. The HTTP server actor running on node 9 gets that message, and it broadcasts it to all the other nodes in the cluster. And I'll give you a moment to guess, how did I do that? And if you were paying attention, if anybody's out there, I don't know if anybody's out there or not, I use a receptionist. So the broadcast, the HTTP server actor registers and subscribes with the receptionist to say, hey, I'm here. And when I receive messages that new entity actors have started or stopped, I'm going to send notification message to all of my counterparts across the cluster. And I'm using a receptionist to do that. And then now the HTTP server has that data. So if I move this viewer to a different port, which I can do by just changing the port, I'll show you. I'll go to 255 4. Oops, come on. There we go. I'm hitting a different HTTP server. See, now 2554 is highlighted with a lighter color. So, but I'm still seeing the whole tree. So the trick with this project that was fun to implement, but it wasn't super hard for me to do it as a developer. I'm just a developer. I'm not an Akka, engineer. But I want to do cool stuff like this, is that it was fairly trivial for me to write my own code that did this, whereas new actors are starting up, all the other HTTP server actors and the server itself have a I'm building a tree basically of all this information. So this tree of what this tree that's represented in a circle is a data structure that's being maintained in all 9 nodes in the cluster, or however many nodes are in the running cluster. I guess in this case it's 7. So if you look at the HTTP server actor, we should see where it receives a broadcast message. And if we look at the on broadcast, it is just looping through the list of service instances that it's been maintaining using the receptionist. So I'll leave that as an exercise for you guys if you're interested to jump through that. But that's what's going on here. I hope I got some of that across. It's a very cool. This is starting to get much deeper into Akka, but it's not, again, rocket science. So this project has the two dashboards. It has the dashboard we've been looking at throughout this whole thing, and now it has this viewer. So let's move on. I'm going to stop this guy. Cluster. We should see all the nodes shut down and the tree go completely away. Boom, there it goes, it's gone. All right, and then I'm going to stop this guy. And then wait for everybody to shut down. Go away, stop, there we go. All right, there's another app, and it's already running. I'm going to show you right here. More eye candy. This is another Akka cluster demo application. It's composed of actually 2 repos, 2 projects that work together as a single application. 2 Akka microservices, basically. The UI is included. The UI you're seeing here is just some JavaScript that I wrote that is included with these projects. And it's currently running on, this is running in an Amazon environment. And it's also using a database. I'm using a lot of the things that I just showed you in the previous projects, in this project, I'm using cluster singletons, I'm using cluster awareness, I'm certainly using cluster sharding, and I'm running things at scale here, because what we're looking at is a map of the world. And this map is a simulation or a demonstration of like a basic IoT, Internet of Things type of an application. So with this demo application, what you can do is you can zoom around this map. It's like a Google map, and you can create IoT devices in different geographic regions around the world, pretty much wherever you want, including in the water if you wanted to do that. So you can see that there's these markers that are distributed in different places around the world. And what they indicate is where I previously populated some IoT devices in these different geographic locations. If you look at the bottom left and right, there's counters that tell how many devices are created. So on the left, it says how many devices are in view, and it's 209,000 devices are in view. And on the right, it gives just a worldwide count, because as I zoom around the map, it's going to show, what's in view will change. But as I mouse around, it gives me information. So I mouse around this region in South America, and it says that there's a total of 37,000 IoT devices that have been created in this geographic region. And every IoT device has a very simple state. It can be either happy, green, or it can be sad, red. So in this case, the marker is showing yellow because some of the devices are sad and some of the devices are happy. And it's saying that there's 1,344 that are sad. So all the data that I'm getting on the map is coming from the back-end Akka microservices. We're using things like cluster sharding, cluster singleton, and so on. I go to different regions in the world. There's 5,000 and a couple markers here. Down in Mexico, I think there's 6,000, 10,000 in the San Francisco area, 16,000, and so on. And just for grins, because this is a conference in Kiev, which I really wish I was there. I love coming to Kiev. But I created some devices in this region, but there's only 64 devices. So what I can do, though, is I can zoom in. And the way this works is that now you can see on the left, it shows that there's only 64 devices shown in view. But there's still, of course, there's still 209,000 worldwide. Up on the top left of the screen, there's some information. It shows a zoom level. As I zoom out, it goes to a higher number. As I zoom in, it goes to a lower number. So the lowest number, of course, is zoom 1. The highest number is zoom 16. My mouse, when I move my mouse around, the latitude and longitude of where my mouse is pointing changes. And then there's this other indicator which says device density. And what this means is that if you can see that there's this grid that's superimposed over the map, which, by the way, is being done by JavaScript that I wrote that's provided with this project. So this grid, each grid region, the way this app works, I could place 1 million devices in this region. So in the region where there's currently only 64 devices in the Kiev area, I could potentially create 1 million devices. Then in the top right, when I zoomed in, this other thing appeared, which shows some information. It's like a little menu, and it shows that there's a rate setting. Capital R increases the rate, lowercase r decreases the rate, and the rate is set at 1,000 per second. I'll explain what that is in a minute. And then you can type a C for create, a D for delete, a H for happy, and an S for sad. So what's going on here? So let me zoom into the Kiev area a little bit more. You should zoom into the point. There it goes. The marker, when I zoom in close enough, the marker changes to the region where there's devices. So you can see in this region, there's 64 devices. If I zoom in more, the resolution gets lower. So it's 4 regions of 16 devices. 16 regions of 4 devices. So at every zoom level halves, or the area is reduced by 3/4. So this big region, when I zoomed out, it went 64 to 16 to 4 to 1. So this is as far as I can zoom in. The zoom level is 1. So what this means is that here, and I'm kind of at the city street level, that there's one device per region here. And so the idea is that with this demo app, I want to generate load. And the way I can do that is that I zoom out a little bit and say I want to create some more devices. So I'm zoomed out, so the device density is 64. If I type a C, if I move my mouse around, it highlights the area where if I click, it's going to create devices there. So if I click this region right next to the one I created before, we should see some device. There they go. They start showing up. So now there's 16, 16, 16, 16. So I created 64 devices. Big deal. I mean, I can zoom all the way down and create one device. And what's happening is the request goes into, there's a couple of microservices. It actually goes through one microservice into another microservice, and when it's done, we see the result. But this is boring, creating one device, creating 16 devices. Let's get a little bit more adventurous. I'm zoomed out. Now I want to create, say, 256 devices. So if I do a create, now 64 already exists, so it's not going to recreate those. But we should see devices get created. There you go. So now I've put some load on the system. I just sent in requests to create 256 devices. So this is like, say you have say this is a shopping cart app, just for a moment. This is really an IoT app, but say it's a shopping cart app, and there's customers in 64 customers in each of these regions. So it's like 64 customers hit the buy button right now, and they all said, I want to buy what's in my shopping cart. So we're generating that load. So the goal of this project is to generate load, but to visually show that load getting generated. So now I'm zoomed out even more to where the device density is 4096. So I can do the same thing. I'm going to hit create, but now a couple things. The rate is set to 1,000 per second. And if you notice at the top, I don't know if you can see it, but it says 4 seconds. So it's giving me a clue that it's going to stagger the creation excuse me, of these 4,000 devices over 4 seconds. So I'm going to click it. I'll zoom in a little bit, and we should be able to watch the devices get created over this region. So 4,000 requests came in to the backend services. 4,000, there's a microservice sitting back there that received 4,000 gRPC messages, and it processed those messages. It updated databases, and then when the database, all the updating of the databases was complete, we saw the data on the map here. So the delay there that you're seeing is a kind of an eventual consistency delay, because the microservice that I'm using is using CQRS, Command Query Responsibility Segregation. If you're not familiar with it, it's a very, very interesting topic. Certainly won't have a lot of time to get into it here, but because I kind of want to just show you the mechanics of what's going on. But the backend microservice is receiving all those HTTP requests and processing them. And I can do similar things. I mean, so I've just created 4,352 devices now exist in this region. I can zoom out again, and another 4096, and just for fun, I'll do it. Well, let me show you something else. I'm going to zoom into 1024. So it should just be 1 second, but I'm going to submit that, and I'm going to move, type C, submit another one, move and type C, submit another one, move and type C, submit another one. So this is another thing I mean, it's pretty easy to overwhelm the backend system with this demo app, because I can very quickly generate a lot of load. So now we've got 8,000 devices in this region. Now, the other thing I can do is I can make some SADs. I'm going to zoom in a little bit more. So if I type an S, move around, if I click, it's sending messages to the existing IoT devices that are in the backend service, and it's saying change your state to sad. And there we go. We're starting to see some of the changes, and here we go. So the changes are going through. I could do another one. Oops, I want to do a sad. So this is running on, like I said, it's running on Amazon. I'm using Cassandra for, if you know CQRS, there's a write side and a read side. There's an event. The right side has an event log, which is a very simple data structure. I'm using Cassandra for the event log. And then for the read side, which is the data that we're seeing here, I'm using Postgres, a SQL database. So what's happening is both those databases are getting updated here. We're looking at the data coming from the Postgres database here. Create some more SAD. I can zoom in and maybe I'll make some of these happy. It should change them to green. So this project has been a blast to implement. The UI was fun. Yeah, I didn't really call it out, but there's a kind of an activity indicator that's in the middle here. It's showing some rates of a creation rate of about 1,000 per second, which is kind of where we were set. There was some spikes where there was 1,000 per second created, things like that. So let's go and look at the projects. There's two projects. It's called Where on Earth, WOE. So if you look in, actually, let me go to GitHub, and I'll show you the repos. So there's one project. I got to fix the name of this one. It's called What on Earth, but it doesn't really matter. It's called Where on Earth Sim, and then there's another repo called Where on Earth Twin. Like I say, these two work together. So it's when you the READMEs have instructions about how to set this up to run on Minikube on your own laptop, or I've run it in Google. I've run it in GKE, Google Cloud Engine, I think it's called, and Amazon EKS, Elastic Kubernetes Service. I've used different databases, different database engine back engines, but these are the two projects. So the simulator project is simulating the outside world. So it's actually when I send in a request to create devices or delete devices or change the state of devices, the simulator first gets that request, and then it changes or it takes that request and builds up all the individual requests for every single device. And then the twin service is the thing that's actually handling the state of the individual devices. The reason I call it a twin is there's some folks at Tesla that are doing some really cool work with Akka and IoT, and they coined the term digital twin, and I just love that term. So to me, the way they explained it was, you have a physical device, an IoT device, say a battery, like a Tesla battery. In the real world, on the back end systems, there's one or more digital twin devices. It has a state about that battery back in the back end system. So it's a twin. So I just kind of use that term, twins. So back in the map, what happens is that when I do a click here, say to send in a request to create 1,024 devices, that goes into the simulator service as a single simple HTTP request. And it's basically saying, create devices in this region on a map. And a region is defined by its top left longitude and latitude and its bottom right longitude and latitude. So and of course the zoom level. So those 3 pieces of information, or actually 5 pieces of information, describe a region on the globe. And when the simulator service receives that, it cascades that into 1,024 gRPC requests from the simulator service to the twin service. So the simulator service has a gRPC client, and the twin service has a gRPC server. Now, the project is configurable to do HTTP as well, so I can, it's just a configuration setting to switch back and forth between the two. But I was experimenting with gRPC versus HTTP because I'm doing the service is doing a lot of messaging. In fact, let me zoom out to the full world again. There's 217,000 devices that are have been created. The way Akka is running here is that all 217 devices have an actor on the backend system. And all those actors are alive right now. This is by design by me, the implementer of this application. But the point I'm trying to make is that I've got an Akka cluster running, actually 2 Akka clusters running, 1 for each service. They're not too big. I think they're like 5 or 6 nodes running on the back end. And they're handling 200,000. Each Akka cluster is handling 200,000 plus live actors. And the SIM service is, if it's not sending commands to say create devices or delete devices or change the state of devices, it's periodically sending telemetry messages, a ping message basically, to kind of simulate you got a real device in the world that's periodically sending in telemetry messages saying, say it's a temperature sensor or a battery charge level sensor. My charge is 50%, and it sends that in every minute. And then, so it sends in 50% the next minute. My charge is 50%. The state hasn't changed of the device, so nothing happens on the back end, other than the fact that the back end system knows that that battery is still communicating because it just received a message from it. So in this demonstration app, I'm sending every minute, every single device from the simulator is sending a gRPC message to the twin service. This is around 3,000 messages per second that are running right now. And it's running on about, I think, like I said, I play with the scale, but it's fairly modest. I think it's like a 5 or 6 node clusters on each side. I don't know what it is. I haven't looked at it for a while, but like I said, it's scaled it up and down. But it is fairly modest. But this is a lot of traffic. And it can also generate a lot of database traffic, right? Because when you do create devices or do some kind of a state change that requires some persistence, this is going to put a real strain on databases. And I'm using this demo app to also kind of explore the limits of different databases, like Cassandra, say Cassandra running in key spaces on Amazon, which has quite a bit of capacity, say, compared to maybe my own setup of Cassandra or a different setup of Cassandra. On Google, I haven't tried it yet, but I'm going to be hopefully soon testing with Google Spanner for a backend database, things like that. But let's look at these projects. So this is the main. And the main should be very familiar. It's kind of a similar pattern. In fact, I'm even using that cluster listen reactor that I've been using all the prior projects. Oh, I'm sorry, I'm in the wrong project. Let me go back here and I'll go to the sim project. Sorry, here we go. Now we're in the main. So sorry, it's a little bit different. So I start up an active system, and then I'm starting up a number of things. I'm starting up the Akka cluster bootstrap, starting up the HTTP server, and I'm also starting up a singleton. I call it a region pinger. The singleton running on the simulator is the thing that triggers sending telemetry messages every minute. And how that works is very cool. I wish I had the time to go into it. It really takes advantage of Akka. But I'm using cluster sharding here, and that's what I want to show you. So the same thing we saw earlier in the last project using cluster sharding, and very similar. Not, but other than the fact that I'm dealing with some databases. But I've got a cluster sharding setting up, and I have an entity actor, which is I call region. And the region actor is a little different because it's extending a base class called event source behavior. And this is what's called Akka persistence, because in this case, when these actors receive messages that trigger a state change, that's going to trigger persisting state change events to an event store in Cassandra in this current setup. So this is using Akka persistence. Because the simulator service is also keeping track of the regions of the map where devices have been selected. So if I stop this application and restart it, it's going to pick up where it left off. It knows that there's 209 or 200, however many thousand devices. It knows the locations of them, and so the simulator service can be restarted and it can pick up where it left off. I also need the persistence because this is running in an Akka cluster and nodes can come and go. But the messaging, the and so on is all done in the same way that we just saw. And the last thing I want to show you, I only have a few minutes left, is kind of the backbone of this. So again, these projects are here. This one's it's set up for you to take. I've got instructions where you could say set up Minikube, set up your Cassandra, set up Postgres on your local system, and make it work. It definitely takes some work to do it, but you can get the map running. And then the map UI you can pull up in a browser. I've got it all defined. I've also got instructions for deploying it to Akka or to Amazon and Google. Those things are kind of a work in progress right now. I'm cleaning up some of the READMEs in these repos. These guys are definitely a work in project. But the map itself is a very fun way to do things. And if you're looking for something to generate some load, this thing can do it. But to finish things up, I want to move on to a final project, which is this guy. Like I said, I just got this working the way I wanted yesterday. So it should be familiar. It's the crop circle. In fact, let me turn a bunch of this stuff off for a moment. But what's happening though is that this thing's running in Kubernetes, and I'm actually using two Akka clusters here. So the Akka clusters are represented on the left and the right. So on the left, this shows the cluster sharding application and is currently running with 5 nodes. And I'm showing like the IPs and the number of messages that each of these nodes has processed. On the right, I've got another Akka cluster that's a simulator. So what this guy is doing is real simple, but I wanted to be able to scale up the amount of traffic easily. So if I scale up the number of nodes running this cluster or scale it down, I increase or decrease the traffic from this cluster, which is sending HTTP messages to this cluster, the cluster sharding cluster. So it's a familiar, cluster sharding diagram. I'm not using a database here, but what I wanted to show you is this is kind of the anatomy of the Where on Earth demo application. The Where on Earth is using cluster sharding. It's an integral part of the way it works. But I wanted to have a way to visualize some of the traffic. So if I click one of these nodes, I can toggle on or off what's happening. So what I'm showing here is that HTTP requests are coming in from all of these different nodes, all these different IPs, at varying rates, and the requests are going in through a load balancer. So what I'm showing is that I'm tracking the requests that came in from these guys that landed on this one node in the cluster, just this one node right here. So what's happening is these are commands coming in for specific entities here. And then these lines that are radiating out from the node to the entities are showing the actual entities that these guys are talking to. And you can see that the lines are changing because the messaging is changing. So I'm tracking like the last 50 messages that this guy has received, and I'm visualizing it here. But you can see that different actors are getting hit. But what the flow is showing here is that these are messages getting sent in from all these guys. It landed on this node, and it's saying, hey, I want to send a command to entity like whatever, like this guy. And yeah, it can click to trace it. So, no line is coming into that, and that actor just went away. So let me click another one. I know I'm just about out of time. But so it's just showing the distribution work. So messages come into this node, and then it could talk to entity actors that are running on that node, or it could forward those messages to entity actors running on other nodes in the cluster. So this gives you a little bit more, hopefully, intuition about the flow. So I can turn off and turn on individual nodes. And so now that I'm following the messaging on this node, and I can just go crazy and turn them all on. So that the visualization piece was the last thing I got running. So it's just really showing that the environment of routing messages that's handled by Akka is pretty wild, pretty sophisticated. But the programming to do it for us as developers is quite simple. And this also is another project that's available. Let me go back to the GitHub. Sorry. It's called Simulator and Visualizer. So it's Akka Cluster Kubernetes Visualizer and Akka Cluster Kubernetes Simulator. Work in progress. I've got documentation on setting it up in OpenShift on it's called Code Ready Containers, and on Minikube, just Kubernetes. So I think I've used up all my time. I really appreciate if anybody's hung in there through the whole thing, and I'm done.
Hi, Hugh. Thank you very much for your speech. Sorry for our agenda and that we should finish your speech, but you can continue the communication in Q&A Zoom room. And also, if participants have some questions, you can answer here too. Thank you very much, Hugh.
Thank you.
Guys, and now we have a short break with our platinum partner EPAM and amazing online quiz. So have a break, enjoy the game, and we'll have the last, after the quiz, we'll have the last for today speech from our keynote speaker. It will be Josh Long. So I'll say you goodbye, see you tomorrow, and enjoy the rest of the conference.
Hello, we are back, and I'm glad to welcome Miroslav Harmatej, software engineer from EPAM. Miroslav, do you hear
Hi.
us?
Yeah, hi.
Hi. So, what you will present to us today?
Oh, I will present you the great thing, like the old game, and at the same time the new game. It's called Snake from the EPAM. So let me like show you the stuff, the whole stuff. Okay. So here we have like, do you remember the old game Snake from the 1970s where the people got crazy and like fighting who got more score on the snake, and they got their Tetris and they played that. But here we have like the same game, the same snakes, but a little bit changed. So here you're able to create your snake, like self-driving snake, which runs the battlefield and collects the apples, collects the points, and the winner actually, as in the different game, is the person who got the more points. So here you have like the battle here, like the different like players, like Alexander, like Metro, and like this is the battlefield number 178. On the right hand, you have like the players, like the old players that are on our server, like here, like DPA, like Victor, someone with A, and their score on the right side. So here also you have like the different fields, like 1, 2. You can also like zoom those stuff and like to look like the bunch of the other fields on our website. You can also like scroll down and you will see like more and more battlefields, so you can like review like different players rule their snake. So here's actually the documentation how to deal with our snake, like how to deal with your snake and how it should work. So like here are the basics of the game. So you write the code and it connects to the server. Like for example, if you have like some here's like the bar from the here you have like the endpoint, like the URL of your current basic field, and you can connect it to your code here. Like for example, you make the variable here with the URL, and it connects to the server, and every second it gets the code you write in the like return function, and the stuff, the code you wrote here rules your snake. Actually, here's like the battlefield, like the smaller part of this, like the different symbols. For example, you have here the wall, like the apple, stone, like the gold, like the parts of the snake, like head or like the body. You have also like different the other things, like also here like is written the battle rules. So the negative impact, for example, if the snake hits the wall, it dies, or if like the snake width is like smaller than 2 cells, so it also dies. Like the positive impact, so we have the pills, like the flying pill, for example, if you take the pill, so it can like fly over the stones or like the other snakes, for example, the fury pill, so it can bite the parts of like the snake for the 10 moves. Exceptional cases, hints, how to work with your snake, how to ride it. So actually here's like the link for your snake battle for the like documentation. So you write quickly here and you will be able to read the documentation also. Like for example, to log in to our snake battle, you should go to the some URL, like add the valid email address, add the password, or you like should sign in and your name, surname, email address, password, confirm password, and you'll be in our database will be able to compete with other snakes. Let me time myself on our battles. For example, if I found Miroslav Hermatis, so I can, if you click on the right side on some person, you can go directly to the battlefield which this person is. So if I go to this field, this is the field where I am, where my snake works, and where's my code is also working. So here's my snake. It always goes right. That is because here I return the thing that makes my snake only go right. But if I, for example, write here top, oh, right, or top, and in our terminal go no runner. Oh, there's the thing. There's the bug. Okay, let me run again. So here in the terminal, you will be able to see every step for every second your snakes made. So here's the battlefield, like the other snakes, like the points, the stones, the other stuff, like the walls here at the stars, and every tick here you are logged some stuff. For example, where's your snake head? Where's the other snakes? So you can buy them, or you can go over them. So you can also find the apples, where the apples are, their coordinates for X and Y. You can also find the gold, the flying pill, for example. There's no flying pill right now on the field, and the furry pill. So there's also no every furry pill on the battlefield. And so here, for example, if we stop, the answer is the empty string. But if you write here the same thing, right, and reload our server local, so the answer is right. So our snake will always go to the right. So also here we have different rounds. The round is probably 1 minute. So the winner is the person who got the more score, the bigger score for their one round. Yeah. So you have half day today to train your snake to write some code, and also you have the half day of tomorrow, and from 15 to 18, or 3 p.m. till 8 p.m. you'll be able to fight with different people, to fight and compete with different persons, different snakes, and the winner will get some prizes from our company. So let me for example discuss the what is going here. Here's the old stuff is going right. Let me okay, so here's the snake super A. So it's written by our developers, and it actually knows where the old stuff, the old apples, the old stones, the old walls, and it makes some things correctly. It's not going only to the right. It's not going to only to the to the bottom or to the top. It not buys the walls, and so it's taking the decisions basically on the next step, basically on the other stuff there's on the other battlefield. Yeah, exactly. So here also you will be able to start your snake from some positions here. You have triangles, so there's the starting position of your snake, and yeah, that's the whole stuff. Please come here and compete with other people's the other snakes and get some crazy stuff from our company.
Okay, thank
Yeah,
you,
thank you.
Miroslav.
Thank you.
That's a very exciting snake battle, and dear participants, I encourage you to join. You will find the link to it at the user page under the EPAM section. Thank you once again, and thank you our platinum partner EPAM for supporting Java Devoxx Online. Thank you. And in a few minutes, we will connect our last speaker for today, Josh Long, with a keynote talk. So stay with us. We will be back soon. Okay, I'm glad to welcome at our online stage Josh Long, Spring Developer Advocate, who is connecting from California. Good morning, Josh. Do you hear us? Yeah, we have some technical issues a bit. Yeah. Okay, so while we are connecting Josh, because you know California is very far away, so we need some time to connect him. And while we are connecting Josh, I will remind you that you can vote for the best speaker and the best talk using the mobile application. A link to the mobile applications you will find at our user page. So install them on your iPhone or Android mobile phone and vote for the best speaker and best talk. The results will be announced at the closing ceremony tomorrow at the end of the second day of Devoxx. Yeah, and yeah, while we're still connecting Josh, again, I will remind you that we have some interesting prize raffles from our partners, and some of the partners has prepared very exciting prizes for you, like MacBook, bicycle, and some AirPods, new and a bit old ones. So a variety of prizes you can win. Just find the links at our partners section at the user page. Fill the registration forms or solve some Java quizzes. And I hope you will be the lucky ones to win. And also we have prepared some prizes from our Devoxx team. You can post the photos with hashtags Devoxx Ukraine and Java 25th anniversary. Post the photo how you watch Devoxx Ukraine online. And the best photos will win the prize from us. It's a 1 year free subscription to any product of JetBrains. So our gift partner JetBrains will provide the licenses for you. So just do the photo, just post it in Facebook or Instagram, and I hope you can win it. Okay, so Josh, welcome.
Morning.
Good morning.
Thank you.
From the sunny California, as we see at your room. The sun is shining.
Yeah, wonderful today.
Yeah,
sorry about the
Sorry?
Sorry about the delay.
Yeah, that's no problem. You know, online experience is a new experience for all of us. So I'm glad to welcome you at Devoxx Ukraine Online. We are very thankful to you that you can join our conference. And now the mic is yours, so please start your talk.
Okay, thank you. Let me open my presentation. Okay. Okay, you can hear me. Can you see my screen? I think you can. Let's wait for this to load.
We see your screen. Everything works fine.
Okay. All right. Good morning, everybody. Good afternoon. Good evening. I am sorry about the delay. There's a little bit of a mix-up. My fault. Clearly, I will try and make it up to you. I appreciate that you all came to this wonderful show, and thank you so much for having me. And I thank you for coming to my presentation. Obviously, I know there's other things you could do. It's late in the day right now, so I thank you for being here. Since we don't have a lot of time, and since I don't want to waste your time, I always remind people of this slide. This is the most important, right? This slide contains the coordinates where you can find me if you want to reach me for questions. I am on Twitter. I'm on email, so please don't hesitate to reach out. At Starbucks Man, my direct messages are open. My email is josh@joshlong.com. And of course, my code is at github.com, joshlong, rsocket revolution. So please find that, take a screenshot of this for later. We're going to go through a lot of stuff right now, but you don't have to follow along right now. Just, use the code for later, right? You can follow that. A little bit about myself. My name is Josh Long. I work on the Spring team. I'm a Kotlin Google developer expert. I'm a Java champion, and of course, I'm a Spring developer advocate. So I've been serving in that last role for more than 10 years now. And as part of that, I've done, I used to travel before this crazy year. I used to travel a fair bit. And I got to see amazing people in the community. And I did some training videos. These are videos that you can buy on Safari that are out there. I have a book called Cloud Native Java that came out in 2017 that I wrote. I have a podcast called A Beautiful Podcast, which is every Friday. That's today. There's a new episode today, of course, every Friday. And so today's episode was with Thomas Risberg. If you've ever used the JDBC template, then you should know Thomas Risberg. And it's fun. And then every Tuesday, I have a blog every Tuesday since January 2011. I've got a blog called This Week in Spring, where I recap all the news that's fit to reprint in the Spring ecosystem. I have, of course, a screencast series every Wednesday, and I have a book that I've just finished writing called Reactive Spring. And this is now out. You can buy it. It's on reactivespring.io. You can buy it on Leanpub or Amazon as Kindle, EPUB, Mobi, PDF, or actual book, printed book. And reactive programming is a big part of what we're going to talk about, but we don't have a lot of time to go into the details. So I'm going to quickly review that. But what we're going to talk about today is something called RSocket. Now, RSocket is a binary protocol that sort of is the logical next step if you understand reactive programming. So hopefully we'll be able to review reactive programming. But what you need to know is that reactive programming is a way of writing software that gives you a solution for three big things. One, how do I write software that is more resource efficient, right? So I can scale better. I can handle more users, more demand. Two, how do I write software that is more resilient? That is to say, it fails correctly. It does the right thing when there's weirdness in the network, right? If there's errors in one service or another, right? And then three, something that gives me a way to write software that's more composable. So if I have service A and service B, and one service speaks WebSockets, and the other one speaks service end events, and the other one speaks SQL, and the other one speaks HTTP REST, and the other one speaks whatever, gRPC, and if I want to talk to Kafka or RabbitMQ or whatever, without reactive programming, all of these are different APIs. In the world of reactive programming, there's just one. It's called the publisher. It's called a reactive stream. And if you understand how to use reactive streams, suddenly it's much easier to compose data from different sources together, right? So data from my my WebSockets, my service and events, etc. All that stuff composes very easily now. So reactive programming is very valuable. And in order to do all these things that I've just described, it changes the programming model. It says that when you are dealing with data, you are dealing with data that is not here yet. It will be here eventually. It's asynchronous. And so when you write code with reactive APIs, you're dealing with stuff that is asynchronous. You're saying, I want to do this with this data when the data arrives. Not right now, because it's not here yet, right? I'm describing a pipeline through which data can flow. And so this requires a little bit of rethinking about how you write code. But once you get used to it, it's a very functional style, and it's very easy. So in order to see all of that in action, we need to write some software. Now, obviously, we have many ways we could do this. But today, we're going to do this by going to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. Now here, we're going to build new software. And we're going to build reactive using RSocket. Now, obviously, there's a lot of good stuff. Most of what we're going to talk about today, in fact, almost all of it, is going to be generally available. It's going to be stuff using 2.3.5, the current generally available released version of Spring Boot, right? But I do want to encourage you to take a moment to explore 2.4.0. You see, there's a lot of other features that we just don't have time for today. Just a lot of stuff that I would love for you to see. There's stuff that's in Spring Boot 2.3 that makes Spring Boot even more relevant, even more natural in the cloud, right? So things like native support for liveness and readiness probes in Kubernetes, things like easy image generation of Docker containers using the Spring Boot Maven plugin, things like graceful shutdown, so that when a pod is killed in Kubernetes, Spring Boot will stop accepting new traffic, wait for the existing traffic to finish, and then shut down, and so on, right? In 2.4, there's two new big features. One is native support for config map as configuration, right? So you can point Spring Boot to config map directly, and it'll just read that from there. And then two, we have support in Spring Boot 2.4 for working with the Spring GraalVM project. Now, the Spring GraalVM project is really nice, right? Like it's we don't have time to go into all this, but it's a good idea for all of your code. It's just a very interesting thing, and it gives you very, very fast, very, very lightweight binary. So here, if I run this application, you can see I've got an application that starts up. What was that? Oh, that's better. You can see my application starts up in 0.13 seconds, right? So, or 0.128 seconds, whatever. Either way, you can see this is an application that has data, right? It has data in it. It's talking to a SQL database. The reason it takes so long is because this actually embeds a SQL database, so that it's starting up a database and it's starting up the application. It's faster if you just connect to another database that already exists. So it's just really, really interesting opportunity, right? You get applications that start up in no time at all. You get applications that take very little memory, tens of megabytes of RAM instead of hundreds. So all of these are very interesting, but we don't have time for all that. But if you try Spring Boot 2.4, you can experiment with all that stuff, okay? So what we're going to do is we're going to build an application today that takes advantage of reactive APIs. We're going to call this a service, and we're going to leave the default version of Spring Boot. We do have some choices down here, friends. We have some choices. There's 3 choices. There's Java 8, 11, and 15. It looks like you have 3 choices, but you don't. You've only got 2 choices, right? 2 choices. Java 11 is the current long-term supported version of Java, and that's okay. It's not great. It's a cowardly version of Java to use. And then there's Java 15. Java 15 is the current supported version of Java. It's not the long-term supported version of Java. So I can choose which Java I want. I will, of course, unless I'm doing GraalVM, I will, of course, choose the current long-term supported version, or the current version, right? So, okay, let's see. Here we go. Okay, use Java. Good. So now I have Java 15 specified. Let's go ahead and select that. Okay, now we're going to use the RSocket support. We're going to use Lombok. We're going to use security. And I think that's it for now. I think that's it. Yeah, okay, so I hit generate. And we're going to go ahead and open up this project in our IDE. Oops, not sure what it's doing. Okay. Come on, go faster. People are waiting. Okay, good. So, public static void main application. I need to set up the JDK 15. Thank you. Okay, there's my application. And so what we're going to do is we're going to build an application that that demonstrates, first of all, some basic principles in reactive programming. So before we get too far into Spring, let's just take a brief moment to look at some reactive APIs, okay? In the reactive world, you've got these types called the reactive streams types. So there's 4 types. The first one is called a publisher. A publisher broadcasts data. It publishes it asynchronously to a subscriber. The subscriber, when it first subscribes, is given a subscription. This subscription is super important. We're going to come back to that in just a second. When the publisher sends new records, they are broadcast in the onNext method. When there are errors, they are broadcast in the onError method. And when the processing is done, it's signaled here using the onComplete method. Now, I said that the subscriber gets a subscription, and the subscription is super important. This subscription is what the subscriber uses to ask for more or less data. The subscriber can say, I want to request 10 records or 15 records. And it can also cancel the production of data if it wants, right? So both of these are very convenient, right? This is how the subscriber controls the rate of consumption. The subscriber says, I want only 10 more records, not 1,000, not 1 billion, whatever, right? It's up to the subscriber to decide how much it can handle. And in this way, you create more resilient services because you can push back against the producer. You can stop it from overwhelming you, right? This is very useful because it creates stable services in the same way that a message bus in an architecture helps protect a consumer because it allows it to absorb the extra data. That ability to push back, to say, I can't handle this right now, is called back pressure or flow control, right? Very, very useful thing. It's a foundational API. Org reactive streams. This came out of the joint collaboration between the Spring team, Netflix, the Eclipse Foundation, and Lightbend, nay TypeSafe, right? So all these different organizations got together and extracted out these common interfaces. There's a fourth one called a processor. And a processor is a source and a sink, a bridge, a producer and a consumer, right? So let's see. So we've got now those 4 foundational types. They're very useful. They're obviously foundational. They're so useful that they're now in the JDK itself as well. So Java util concurrent, subscription, subscriber, publisher, and processor. And these are very basic types. So we have 2 specialized types that provide rich operators that come from Reactor. Reactor is our library on the Spring team. It helps build on top of the regular foundational types. And so we have two specializations, one of which is called a Flux. Flux is a publisher that produces 0 or more records, right? So 0, 1, 2, 5, a billion, 1,000, whatever, infinite, right? There's also a Mono. A Mono is a publisher that produces 0 or 1 record. So 1, 2, 0 or 1, but not 2, 3, 4, 5. Both of these types, both Flux and Mono, have lots and lots and lots of operators. Look at all these operators. Things that we can use to make it easy to consume more or less data. So very, very useful types. And now that we understand that, let's use them. What we want to do is we want to create an RSocket endpoint, an RSocket service. You see, one of the things about RSocket that's so nice is that it's natively reactive. It's a binary protocol that was designed to support our use cases in a production environment. It was originally developed by people who worked at Netflix, who then went to Facebook. And these people knew about HTTP2, they knew about gRPC, they knew about those options, but there were certain things that were still missing. HTTP, for example, has a lot of good things, right? It has a stateful connection, just like RSocket. It has binary data, right? So the payload is no longer text, just like RSocket. But it still also basically request response, right? That's the first issue. You can use gRPC, but gRPC requires code generation, and everything must be using Google Protocol Buff's IDL, very inflexible, right? So RSocket gets around all that as well. And RSocket goes further by also making it natively reactive. So it's in the wire protocol itself. The protocol gives you a way to say, hey, I am too busy. I can't handle any more data. I'm going to push back. It can apply back pressure in the protocol itself. Remember, from the perspective of HTTP, there's no such thing as back pressure, right? The only thing you can do if you're being given too much data from an HTTP producer is just disconnect. That's all. But wouldn't it be nice just to say, I only want 10 records, then you can process them, and then you ask for another 10 records, and then etc. Or 1,000 or whatever, right? And what if you asked for 10 and then you stopped asking for anything for an hour? Wouldn't it be nice if you could just pick up where you left off, right? That's built into RSocket. The other thing that's nice about RSocket is that it's built for production. So if you've ever used Spring Boot, then you know that Spring Boot has a set of management endpoints called the actuator. Actuator gives you information about the services that you've deployed. Things like the health, the uptime, the runtime, the metrics, etc. Wouldn't it be nice if that was a convention for all HTTP services, not just Spring Boot based ones? Well, in RSocket, it's built into the protocol. There's information about the service health in the service itself, built in. So every service can do this. This makes it much easier. So now that we understand the benefits of reactive and the benefits of RSocket, let's actually build an endpoint. You see, when the engineers that developed the initial implementation built RSocket, they built the clients for different languages in C++, JavaScript, etc., and in Java. In Java, they used Reactor. So the same Reactor that powers the reactive support in Spring also powers Facebook's RSocket implementations, right, for Java. So we can use it as well. It's very easy to embed in our Spring application. In fact, we even built on top of that low-level integration in Spring Framework to make it even easier. So we can build a controller, so class controller. And what I want to do is I want to build a service that sends a lot of, a fair amount of data, but I want to do it asynchronously. I want to have a heartbeat. I want to send a new message every second. So I'm going to create a greetings service. Okay. And I want this service to send back data of type greeting response, right? So here we are. Private string message at data at all-args constructor, all-args constructor. And given that we get a request, we'll see the response. So private string name. Okay. So Given those, I'll say greetings request, and I'm going to return an infinite stream, or not an infinite, we'll just return 100 records, okay? So from stream.generate, new supplier, new greetings response, hello, request, get name, instance of that now, okay? There's our basic stream. I did say I want to limit it. I don't want it to be infinite. It could be, but I don't want it to. I just want to have data. So we'll say delay elements, duration of seconds. We're going to slow down the data. We'll take, let's say, whatever, 10 records. And once we've got this service, what I've done is I've created a stream. It's going to give us just 100 records, and then we're going to see those 100 records one every second. Okay, so there's going to be a little bit of a heartbeat. Just take 10. Now I want to create this as an RSocket endpoint. So greeting controller, and here greeting service at message mapping. Publisher of greetings response, greet. And we'll say greetings request is the required parameter. We'll say this.greetingservice.greet request. Okay, so there we go. There's our existing API. There's our new RSocket endpoint. The only thing we need to do to make this work is we need to configure a port. So we say RSocket server port equals 8888. All right, so there we go. There's our endpoint. Now we can start this up. Look, see how easy this was, by the way? We didn't have to do anything special here to get that to work. It just worked, right? Good, so there's our application. Oh, I should not forget the Spring security dependencies. Let's comment these out for now. Okay. Looks like that's all taken care of. Maven reload project. Okay, so there's our service. Now we can talk to that service using a number of different things. First of all, we could use RSC. RSC is a very convenient command line interface for RSocket. It's like the curl for RSocket. So I can say RSC TCP localhost 8888. We're going to specify a route. The route is greetings. And the type of exchange, the interaction model that we're going to support is a streaming interaction. So we're going to send in one record and we'll get back multiple records. You could also do request response, so one record in, one record out. You could do channel, where you send in multiple records and get back multiple records. And you could also do fire and forget, where you send in one record and you get no records. This is actually a very useful part. I love fire and forget. There are so many different protocols where I don't care about acknowledging the response. I don't need to, I don't have to, and it doesn't help my service if I do, and it just slows everything down. I think about StatsD, right? StatsD is a protocol where you emit metrics, and it's sort of, obviously it's good if you have every metric, but you know, if you lose a metric here and there, it doesn't matter, right? As long as the service is basically healthy. And so it's a shame that we have to wait for the acknowledgement if you were to use something like HTTP. You don't have to do that with messaging buses, right? You don't have to wait for the response if you don't want to. You can in a lot of cases, but you don't have to. So that's another very useful protocol is to support fire and forget. Just send the data out, broadcast it to whoever wants it, but move on because you don't have time to wait. Okay, so there's the data, and the data that we're going to send in is, and by the way, we can do content negotiation. So I'm going to do name Devoxx. Okay, whoops, no handler for greetings. Whoops, greetings, silly me. Compiling. There we go. There's our data. One record every second. Okay, so we've got some asynchronous data. Now, of course, that's one way to get the data. Another way to get the data that I really like is to actually build an integration pipeline, right? So I'm showing you how to use the service from a command line, but a lot of times when people are using something like RSocket, they want to integrate with the rest of the ecosystem. One of the nice things about reactive programming is that if you are in an all reactive environment, everything is reactive. Your database, if you're using something like R2DBC, then it's reactive. If you're using something like Spring Web Flux, it's reactive for service socket events and service and events and WebSockets and all that. That's wonderful. But sometimes people want to integrate, right? They want to take non-reactive and reactive things and mix them together. And so for this, we have Spring integration, right? Spring integration is a framework for building integration flows. So I'm going to bring in Spring integration, and I'm going to bring in an RSocket. We're going to call this integration, and we'll hit generate. Now, Spring integration is a pipes and filters messaging technology. It's an enterprise application integration framework. Okay, it's been around for a long time. It's not only reactive. You can use it to write code that talks to anything really. I mean, you can talk to file systems. You can talk to JMS. You can talk to Kafka, RabbitMQ. I mean, all sorts of different things, even if they are not reactive, right? And so it'll help you write very easy glue code to make these things work together, right? So what I'm going to do is I'm going to use Spring Integration's file support, and I'll use their RSocket support. Okay. Okay. So I'm just the two different dependencies here. Good. 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 So there's this. Now, what was that? Oh, okay. Okay. So what we're going to do is we're going to build a Spring Integration bean that responds to any issues. Okay. Sorry. Forgive me, friends. So what we want to do is we're going to build an application that responds to changes in a local file system, and we're going to do that by, first of all, creating an integration flow. So an integration flow is just a way to describe a pipeline. This book, this technology, borrows from the patterns from the amazing book called Enterprise Integration Patterns by Gregor Hope and Bobby Wolf. Okay, so great book if you get a chance. This framework supports these patterns, and so we create an integration flow to describe how data connects together. We do that by describing how data comes into the system, where it's originating from, and we describe the transformations on the data, and we describe the destination for the data, the output of the data. So what I'm going to do is I'm going to create a pipeline where I read data from a file inbound adapter. Okay, so the first thing I want to do is I want to take a regular thing like a file system, file inbound adapter equals files. Got inbound adapter. I'm going to create a new file here. File, new file. I'm going to inject a reference here to the home directory. Home. Okay. Desktop. File. Okay, and new directory will be actually here, just do that in. Okay, so we're going to say whenever data comes in to that directory then we want to make sure that the directory gets created. We're going to use this inbound adapter here. So we'll say file inbound adapter. And remember, file systems don't tell us when something has changed. So we have to poll. We have to constantly re-ask the question. And we can do that by specifying a poller. So p.poller pm dot fixed rate 1000 1000 milliseconds 1 second. And once the data comes in, it's going to give us we can chain together transformation. So I can provide another operator here that it provides a transformer, a spring integration transformer. And here I can read the current message that I'm being given from the inbound adapter. I can take the message, do some work on it, and return another message. This is a Spring Framework message, okay? It's in Spring Framework itself. So you have headers, and you have a payload. This is the basis of the integration patterns, because I have the ability to do lots of little transformations like this. This is kind of like reactive programming, right? So it's very convenient, very natural. And what I want to do is I want to take this message, I want to get the payload, and I know that the result is a file because I know that the output of the inbound adapter is a file, right? So I could do that if I wanted, but what I want to do is I want to take the data and turn it into a string. I want to read the data from the file and just convert it into a string. So in this case, the thing I'm going to have from the file will be a name. Once I've done that, I want to transform it again. So remember, the output of this is a string, right? So I have a string now. So I want to take that string here as the input of the next thing and turn it into a new greetings request. So I'm going to go back to my code and adapt these types. Okay. Okay, so I need to add Lombok again. Okay, so come on. Okay, from there, greetings request, new. Okay, so I'm transforming it from a string to a greetings request. And then I want to send that string. No, actually I want to take that string, I want to transform it first. One more time. String class s.trim. String it, and then I'm going to send it here as a greetings request. And then I'm going to send it out to my RSocket endpoint. So I've got a message coming in from the file system. I'm going to send the message out to my RSocket service using something called a gateway. Now, usually when you adapt data, the data comes in and you take it from the outside world and you turn it into a framework message, or you can take a framework message and send it out to the outside world. So one message in, one message out, but it's one direction, right? With a gateway, the message comes in, you transform it, produce a response, and send a response back out. So gateway is in and out, or it's out and in. So it comes in from the outside, it gives you a response, and then you respond backwards, right? So I want to create an RSocket gateway to make a request of our RSocket endpoint, right? I'll use the RSocket gateway here. RSocket, come on, RSocket, outbound gateway. RSocket, is this not here? There it is. Okay, good. So it's here. So RSockets. Outbound gateway, greetings. Right? Let's see here. Is this not compiling? I am very confused. Integration DSL. Okay, let's go up here and see what we got. Spring integration R socket. Is this not real? It's right there. So why? Org Spring Framework integration. Yeah, that looks right. So let's see here. Maybe I just delete the local one. Org Spring Framework integration. Spring integration R socket. When in doubt, flush it out. Okay, good. Maven reload. Compilation failure. Yeah, I get it. Okay, let's see. What's the issue now, I wonder? Expected a semicolon. Of course. Now. Okay, don't care about that. Okay. Now, R sockets. Maven integration. R socket. Integration R socket DSL. R sockets. Integration R socket DSL. Feels like that should be there, right? I think we can agree. Let's see. Maven re-import. Spring integration R socket. There's this. What is happening? Okay, we're going to try this again. Something is very strange about this. Maven reload projects. See if that compiles, even if it doesn't work in IntelliJ. Okay, there we go. See, it does compile. That's weird. Okay, so it's IntelliJ that's having the issue. IntelliJ doesn't think that library exists for some reason. So we close it and we start again. Spring integration, rmrf target, rmrf integration.iml, rmrf.idea, idea pom.xml, etc. Okay. Got the SDK. There it is. There it is. What is that about? Do you understand? That was so weird. Okay, so we got it. Get rid of that. Return this. Good. We'll come back to this in a second. Okay, got get for now, but we'll come back. And this and that. There we go. Okay, there's our outbound gateway. And so the outbound gateway is going to it's going to send a request to the RSocket service that we've already got running on port 8888. In order to do that, we need to create some way for the service, the client rather, to connect to it. Yeah, so we use a client RSocket connector. So var crc client RSocket connector, localhost 8888, crc.set request strategies, and here we're going to inject the RSocket strategies. Okay, we'll say strategies, return crc, and then crc dot, and actually that's it. I think that's all we need. So that's going to describe how to connect to that service. We can inject this here, crc, and we provide that as the outbound bit there. So crc, and then finally we want to connect. We want to describe the streaming type. So remember I told you about the interaction model. So RSocket interaction model dot streaming, right? Request stream. And then finally, we want to describe what kind of data we want back. So we want a greetings response, right? So greetings response dot class. Okay. Oh, interaction model. There we go. So there's our basic interaction, our pipeline there. So we're going to say, okay, handle the message by sending it to the RSocket outbound gateway. Now the data that comes back might be, there's going to be multiple records, and I don't want to process, like if I wrote code at this point right here to transform the result, for example, I would say new transformer, and the data that I would get here from each message in this case would be a publisher of greetings response, right? So I'd have to cast that to a publisher of greetings response, and I would get back the payload, and that would be the right type. But I don't want a publisher of each one. I want just a single greetings response. I want to have a different message flow for each one. So what I'll do is I'll split. Okay, I'll split the data, and what that gives me is now I've got each new message has only a greetings response, not a stream of greetings response. The problem is, of course, that once I've split the data, I'm on this side for this component. I need to deal with back pressure, right? I might have too much. I need to be able to push back. And so we want some way to communicate back pressure. And one way you can do that is to use a flux message channel. So behind the scenes, Spring integration uses something called a channel to separate messaging components from one another. And you don't normally need to worry about it unless you want to. It's a great way to explicitly say this component communicates to a message channel, and that decouples one integration flow from the other one, right? So I can use that here. I can say channel, and now I have back pressure built in, and now I can actually just process the data. I can actually say, okay, I want to handle the results just to log something out, right? Generic handler. And the data that I'm getting here is a greetings response. Okay, good. Good. So I can process the data. I can say, okay, system out new message o dot toString, etc. Okay, so I'm just logging out the results, and there's my integration flow. Run this. And so we create a file, echo Devoxx desktop in hello. There you go. Hello Devoxx every second, right? So that's an integration flow using regular non-art reactive things and showing you how you can adapt them to work with something as awesome as RSocket. This is just one way. There's lots of other things you can do. Now this is great for if you have some other stuff you want to connect to. But if you just have a regular service and you want to connect to an RSocket endpoint, then of course you can go and create a client, right? So we'll do that as well. We'll create RSocket security Lumbach. I'm going to hit generate, and we'll do UAO client.zip, CD client, Maven installed. Everything's there. Okay, so now we have a client, and what we want to do is we want to talk to our application. So we create an RSocket requester. This is the native non-blocking reactive client that we can use to talk to that endpoint. So RSocket requester builder. Okay. And notice that when you create a client, you connect at one time, right? When the application starts up, you connect at the very beginning of the life cycle of the application. RSocket services, once they start up, they can connect to each other. They're not client and service. They're requester responder, right? A requester can ask a responder for information. But the thing that's interesting in RSocket is that that responder can also be a requester. Both sides can ask questions of either side at any time. It doesn't matter who first connected to who. The other one can make the request. So here, RSocket requester, and I want to actually create a little bean to listen for that data. I'll say application ready and RSocket requester. I'm going to log the result out. I'll say dot route greetings. And I want to get the data, right? I want to send the data that I'm expecting to come back. I'll say I want a stream of greetings responses. We'll go to the service, get all this stuff here. Paste. Okay, so I'm going to say I'm expecting to send some data in. The data I'm sending in is a new greetings request, Devoxx, right? And I expect a stream of responses back, and I'm going to log out those results. Okay, so system out print line, and voila. Okay, there's this. Now, run this if I want. Oops. One of the things is that the application is asynchronous, right? I'm starting up the connection, I'm making the request, and there's nothing to keep the socket open because it's not an RSocket server, it's a client in this case. There's no process serving anything yet. So I need to keep the thread open by squatting on system in. Okay, so there you go. You can see we're getting the records back one by one from the service downstream. And that's great, right? That's exactly what we wanted. So now we have a very simple interaction model. You can see we create the RSocket requester. Once the application starts up, it connects. It stays connected. That's a benefit because it means you're not constantly reconnecting each time. It's very efficient this way. I'm using the RSocket requester. I like the RSocket requester. But some people asked about, would it be possible to have a more RPC style model, right? So I actually went out and built one. That you can try. It's experimental. It's definitely not GA, but it works. Maybe you appreciate this. So here's how you get started. It's called RetroSocket. Okay, and you can easily add it to your code base. You just pick the version of the dependency here. And the version, of course, is 001 snapshot. It's GA, not yet finished, not real. Add the snapshot repository, so I'm going to add that here. Okay. Maven, reimport. Hopefully this doesn't go worse than last time. Let's first do the build. Maven install. Okay, so now Maven reload. Okay, and now what I'm going to do is I'm going to describe an RPC-like experience for that service. I'll say, this is OpenFeign or retrofit, right? So it'll be a greetings client, RSocket client, okay, and then publisher of greetings response, greetings request. There you go. So there's that. I'm going to do message mapping, greetings. Okay, so this is my client. I need to enable RSocket clients. Okay, and now I can build another client. I can actually just build another bean to listen to that. And this will be this is a RSocket requester listener. And this will be RetroSocket. listener. Okay, so here, I just need to inject that interface. There's no code required really, right? So I'm just going to say greetings client dot greet new greetings request Devoxx from RetroSocket dot subscribe system out print line. Cool, right? We got the experience now, so we can run this. Let's comment this one out so we don't get redundant data. Okay, there you go. So that's working as well, right? So either way works just fine. The problem with Spring RetroSocket, even though I like it, the problem is that it is a client that's built in, right? It's for RPC. It's for acting as a client to a service. But remember what I said before. RSocket endpoints aren't necessarily client or service. They can be bidirectional. And that's really powerful if you think about it, right? Because that gives you the ability to write a service that asks questions of the client. The client, in turn, is its own kind of service. And so what we're going to do is we're going to take a look at how to use that functionality to expose information from the client that the service can use in determining what to do next. So what I'm going to do is I'm going to create a simple endpoint here. Okay, let's say that my service, let's say that my client rather, has some health data, some telemetry data, something like that, right? That tells the service whether it's healthy or not. And if it's healthy, then the service will keep giving us data. If it's not healthy, it'll cancel, right? We'll say data, all args, no args, constructor. Okay, so it's like a heartbeat. So I'll say health controller, message mapping, health, publisher of client health state. Okay. Return publisher of new supplier. Return new client health state. Okay. Math.random greater than 0.5. So we're randomly determining whether we're healthy or not. Okay. So there's that. The elements. I'll say get a new record every second. Okay. And there's my controller. And the benefit there is I want to create that controller and expose it to the service, so the service can ask me as a client once I've connected for information. Okay. In order to do that, I need to configure my RSocket requester a little bit here. So I've got my RSocket requester. I need to configure a bean, socket acceptor, and in order to do that, I'll create a RSocket message handler responder client. Okay, so we'll say RSocket strategies, and then I'm going to return the client health controller, right? The health controller. Good. So there's my socket acceptor. I can inject this here. Okay. And we actually can just configure it. Sorry, wrong side. Over here. Okay, so we're gonna configure this. There you go. So now we're actually, when the client connects, it will say to the service, hey service, I can also answer questions if you send a message to my health endpoint. Okay, so now it's bi-directional. So now what I want to do is I want to take that data here, and this is an example where we can use the really, the bi-directional capabilities, or we can say on the service side that you want to inject the client socket, okay, client socket, and then we want to ask it questions, right? And I can do that. I can say, okay, health, and what that gets me is a stream of health information, right? So I get this, take that, Command C, paste that there. So I'm going to call the service, the health service, and once I've got the service, I want to get back a stream of client health state class, and then I want to filter it. I want to say, okay, if I get a certain kind of data, then I want to send back. If I get back information that says that the client is healthy, then I want to continue sending more greetings. But if it's not healthy, there's no need to send more greetings, right? The 10 greetings or whatever. And this is very common. You have like a video game where if the client disconnects, there's no reason to keep sending data back and forth from the server because it's a waste of resources, right? And so we can actually describe that kind of flow here pretty easily. We can say client socket.route retrieve flux. And we want to filter the data, CHS is healthy. So basically, this will give us a stream of client health objects. But we don't want all of the health, because if there is no problem, then we don't care. Everything is fine. We want to filter, we want to drop all the messages, all the responses that are healthy. If they're healthy, then no problem, don't worry about it. But if they're not healthy, then we want to keep it. So for most of the life of the application, health is going to be empty, right? But as soon as it's not empty, as soon as there's one record, then I want to stop producing the response, okay? So I say, here's my greetings, my response. And what I want to do is I want to say return response take until other health, right? So this gives me a way to say keep producing this stream as long as this is empty. As soon as it's empty, though, don't send more data, okay? So an example of I'm injecting the client's socket. I'm using the client socket to ask questions. I'm going to use that information to determine how I respond in the service. So it's a conversation. The state of one thing, what I'm doing over here on the client, affects what's happening here on the service. Isn't that cool? So let's go ahead and run this. There you go. Looks like we got 3 records in, and then we ran into a bad health. It stopped sending the data. My friends, we've just looked at the very beginnings of RSocket. We've looked at reactive programming. We've looked at integration. We've looked at different ways to do clients, including RSC, including RetroSocket, including the RSocket requester. And we also looked at one of the most powerful features, which is the ability to do bidirectional communication. We also saw, thanks to reactive APIs like Flux, that we have this very easy ability to compose different reactive streams, right? So I'm dealing with publishers all the way around. Everything I've showed you so far, except for the Spring GraalVM native support back in the very beginning of the talk, is already GA, so you can try this out and so on. Unfortunately, it looks like we didn't have enough time to cover Spring Security and RSocket, but it's really nice. You can use JWT tokens, or you can do something like a username and password based very easily. So you can encrypt, you can secure your RSocket streams. We've only begun to look at RSocket. RSocket is the first project that the Spring team and Lightbend and Facebook and Alibaba and others, it's the first project that we all donated to the Reactive Foundation. We're all founding members of the Reactive Foundation. So all of us have gotten together and we are working on RSocket, all these different organizations. I spend a lot of time traveling from one place to another. I used to be before this year. I would go and spend several days, maybe a week in China with Alibaba. Every year, I would talk to them about different things. I'd say, "Oh, look!" Back in 2014, I'd say, "Look, we have this thing called Spring Boot. You will like it, right?" And then they tried it out, and of course they were already using Spring, so they loved Spring Boot. And then I showed them Spring Cloud, and then I showed them all the sort of new stuff, and then reactive programming. And then 3 years ago, I finally got to show them RSocket. Now RSocket is becoming an organizational standard, right? And so they're heavily invested in this use for their applications. It allows them to go faster. They even built a broker, but they're not the only ones. We also built a broker. And the idea behind the broker is pretty simple. Imagine if you have a broker where requests come into the broker, and then the clients, they connect to the broker, the clients stay connected, and the broker can act as a hub. Other services contact the hub. The hub has all the different live client connections from all the other services, and it says, oh, your health is very good, you can handle this, and it load balances the request to that socket that it's got, right? The best part about this, of course, is that since there's bi-directional communication, all the clients that connect to the hub, they can be completely black box, right? They don't have to have open IP firewall rules. They can have no ingress, no inbound requests. That's easy, right? It's very secure that way. They stay connected. The clients connect to the hub. They stay connected. The hub gets data from the outside world, from HTTP or something. It transforms the request, load balances it to a particular service. If there are no instances of the service, because we have session resumption and we have true back pressure, the hub can apply back pressure to the client, wait for something to come online, and as soon as it comes online, it doesn't apply back pressure. It forwards the request to the downstream service. So there's some really amazing possibilities here with this broker that we're all working on together. I hope you'll investigate. I hope you'll get a chance to try it out. You're certainly not alone. Everything I've showed you here for RSocket, except for RetroSocket, is GA. So this is in Spring Framework, it's in Spring Boot, in Spring Security, Spring Integration, etc. Right? It's all over the place. Thank you so much for your time. I hope that you're all healthy, happy, and safe. And as always, I encourage you to find me online, josh@joshlong.com or at StarbucksNet.
Thank you, Josh. Thank you very much for connecting this morning from California and conducting this talk. Dear participants, you can join the Q&A Zoom room with Josh and ask your questions. Maybe you will even have some time to discuss the security in Spring, the topic that we didn't have time to cover right now. But again, I'm very thankful to you for supporting Devoxx Ukraine online. Stay safe, stay healthy, and hope we see each other next year.
Me too.
Thank you. Okay, dear participants, our first day of the conference is over. I hope you enjoyed it as much as we did, together with our speakers and with you and with our partners. And tomorrow the conference will start at 10 o'clock GMT +2, so join us. And we will be back with even more interesting talks and quizzes and challenges for you. See you tomorrow.